Generative AI is changing everything from the way we work to the way we create, and this course is your one-stop guide to master it. We will start with the basics like generative AI for everyone, large language models, and beginner-friendly GenAI models. Before diving into practical tutorials on ML, deep learning, MCP, and LSTM, you'll learn how to build your own LLM chatbot, explore GenAI agents, and get hands-on with advanced concepts like LLM prompting with Gemini, multimodal prompting, and benchmarking models. We'll also cover real-world tools and frameworks like LangChain, Hugging Face, and N8N to help you build powerful AI apps step by step. Plus, we'll guide you through a career roadmap, AI tools for job interviews, and portfolio-ready project so you are ready to apply today's booming AI job market. So whether you're a complete beginner or looking to upskill, this course makes complex AI concept easy to understand and fun to learn. And by the end, you'll have the skills and confidence to create, innovate, and land exciting opportunities in the world of generative AI. So let's get started. Before we commence, if you're interested in mastering the future of technology, the professional certificate course in generative AI and machine learning is the perfect opportunity for you. This course is offered in collaboration with ENICT Academy, IIT Kanpur. This 11-month live and interactive program provides hands-on expertise in cutting-edge areas like generative AI, machine learning, and tools like ChatGPT, DALL-E 2, and even Hugging Face. You'll gain practical experience through 15 plus live projects, integrated labs, and live masterclasses delivered by esteemed IIT Kanpur faculty. You'll also earn prestigious certificate from IIT Kanpur, and you'll receive official Microsoft badges for Azure AI courses and career support through Simplilearn's Job Assist program. So hurry up and enroll now, and you can find the course link below.
Now, the agenda for today's session. Firstly, let's get started with the agenda for today's session. Now, we will have a brief introduction to this session. Followed by that, we will have a briefing of what exactly is AI, then how does it work. Next, we will understand the key technologies and frameworks involved, and we will also go through some everyday use cases where we can take help of AI, and also some of the responsibilities that we need to keep in mind for the ethical use of AI. And lastly, we will explore some prompts. Now that I have made myself clear with the agenda, let's get started with the first part, introduction. How can AI simplify daily tasks? As we discussed in the use case, a human might have a lot of routine and mundane tasks. For example, automation. AI can simplify your daily tasks like checking up emails and drafting email responses, enhancing productivity by getting AI assistance for research in marketing trends or any other researches based on your job profile, and you can have a personalized AI assistance for recommendations for learning and much more. And after that, it will save you a lot of time, reducing effort. Now, the next part. Get set up with generative AI models like Microsoft Copilot and try some of the examples. So if you get access to one of the generative AI models like GitHub, then you can access GitHub Copilot easily, use it in Microsoft 365 apps like Word, Excel, and Teams. Then you can also explore prompting basics to start up with simple commands like drafting emails or summarizing documents. And proceeding ahead, we have another opportunity to experiment with different use cases like trying Copilot for brainstorming, planning, and organization. And fourth one, customize and iterate. Improvise AI generated results by refining prompts based on your needs and requirements. Now, let's proceed ahead and understand what exactly is AI and how it works, which will involve some of the key topics like understanding the basics and technologies involved, etc. So, sync up with human activities and gather requirements to assist humans in their daily tasks, improving efficiency and effectiveness. Not just these professional tasks, AI can create new content like text, images, music, and videos. It uses natural language processing and neural networks to learn patterns from existing data and then generate new content. Now, let's see how we can use AI to simplify our daily tasks and make life easier. Firstly, AI can create unique content, not just analyze data and make predictions. It can assist you in real-time generation of original text, images, music, and more. Next is AI as a creative partner. Generative AI can produce original text, images, music, and much more. It goes beyond traditional AI. Unlike predictive AI, generative AI creates new content rather than just analyzing data. Proceeding ahead, we have the next functionality where it can enhance human creativity by assisting with brainstorming ideas, storytelling, design, and content generation. Lastly, it is widely used in multiple fields, found in marketing, education, entertainment, and software development. Now, let's proceed ahead and understand the key technologies behind generative AI. Large language models is the first one, trained on vast amounts of text to generate human-like responses. For example, ChatGPT, Palm, Llama, and Microsoft Copilot. It is used for writing summarization of code and emails and much more. Now, the next part is natural language processing. It enables AI to understand, interpret, and generate human-type languages. It powers chatbots, voice assistants, and translation tools. Next, it helps improve communication between humans and AI. Now, let's proceed ahead and understand the everyday use cases of AI assistants, starting with creative writing and content creation. You can create and generate blog posts, articles, social media captions, and scripts. AI assistant in brainstorming ideas, editing text, and improving clarity. And lastly, you can also create poetry, stories, or some song lyrics using AI. The second one is organizing and planning. You can make use of AI to plan a trip itinerary based on preferences and budget. You can generate meal plans and grocery lists as well. You can schedule events and set reminders and manage to-do lists. The next use case is personal assistance. You can use AI to draft and refine emails or messages. It also helps you by providing phone books and recommending movies and music. And lastly, summarize documents, articles, or even meeting notes. Lastly, we have some other practical uses which include the following. Learning new skills with AI-generated study plans, translating languages to provide real-time interpretations, offering health and fitness suggestions based on personal goals. Now, proceeding ahead, we will understand AI agents. AI agents are advanced virtual assistants designed to perform tasks autonomously. They interact with users, process information, and execute commands. Some of the examples are ChatGPT, Microsoft Copilot, Gemini, and others. Now, what do AI agents actually do? So, AI agents conduct the following tasks. First, automate some repetitive tasks. Repetitive tasks like scheduling meetings, setting up reminders, and managing emails is done by AI assistants. It can enhance decision making by providing data driven insights and recommendations. Third is it can act as a personalized digital assistant which can help you with learning, travel planning, productivity, and much more. Lastly, integrating with tools and apps which can help you work across Microsoft 365, CRM platforms, and much more. And now, let's proceed with the major part of today's session where we have to focus on how to use AI responsibly and effectively. So here we have a detailed Microsoft Copilot AI overview and also AI agents and their role in productivity. Let's go through that first. So here we have a quick briefing of Microsoft 365 Copilot, and we have also some links to the Copilot Success Kit, Copilot Chat, Agent Starter Kit, and the community links over here, and resources, Copilot mobile version, what's new, and all and everything you need to know about Copilot, about the technical readiness, etc. Now, back to the presentation where we were discussing about the responsible use of AI. So the importance of ethical use of AI. AI should be used in a way that it is fair, transparent, and accountable. Understanding AI limitations will help you prevent misinformation and misuses. Ethical AI usage ensures trust and reliability in everyday applications. Proceeding ahead, we will discuss about ensuring transparency and accountability. First one, clearly communicate when AI is used in content creation. Provide with the specific prompts that you're expecting in your output so that it cannot miss on the target. Secondly, we need to verify AI generated information before sharing or acting on it because there might be instances where we might go wrong explaining our inputs or there might be some discrepancy in the data provided to analyze and generate a report. And lastly, understand how AI makes decisions to avoid over reliance. You need to understand the thought process of an AI and expect what kind of results it might generate so that You don't have to rely on one single prompt every single time. Now, let's move ahead and address some potential biases in AI. AI can sometimes reflect biases present in its training data. Common biases include general bias, racial bias, cultural bias, confirmation bias, and socioeconomic biases. Let's discuss each one of them. Firstly, gender bias. AI generated job descriptions may reinforce stereotypes, example, associating engineers' roles with men. Second one is racial bias. Facial recognition systems may misidentify individuals from certain ethnic backgrounds. Third one, cultural bias. AI might prioritize Western perspectives in content generation. Fourth one, confirmation bias. It may reinforce existing beliefs by favoring information similar to past searches. Lastly, socioeconomic bias. For example, AI generated loan approvals may favor individuals from higher income backgrounds. Now, you also need to focus on responsible prompting. Use clear and neutral language to avoid influencing biased results. Ask AI to provide diverse perspectives and sources when generating responses. Be mindful of data privacy and avoid sharing sensitive personal information. Now, let's go ahead and check some of the prompt examples. So now we are on the Microsoft Copilot prompt gallery, which will show you some of the sample prompts that you can make use of. For example, get a to-do list, add an image, quiz yourself, create a technology, write more confidently. For example, you might have a description. You can just add it to improvise or add more impact onto it. Find a specific information, draft an email, create a shopping list, and so on. So here you can also go through some other prompts as well by clicking on View All Prompts, and a whole new world of prompt gallery will open up for you. Try it out and let us know your experience in the comment section below.
So today we will start our tutorial with an example. Imagine a world where computers can write stories, draft legal documents, translate languages, and even hold conversations that feel human. It's the power of large language models. Take GPT-3 by OpenAI for example. This AI marvel with its 175 billion parameters can generate coherent essays, create poetry, and even code, all from simple prompts. Or consider the Megatron Turing NLG530B, a collaboration between NVIDIA and Microsoft, boasting an astonishing 530 billion parameters, excelling in complex language tasks like reading comprehension and natural language inference. These models are transforming industries. In healthcare, they are predicting protein structures and disease patterns. In finance, they are summarizing earnings calls, and in customer service, they are powering dynamic chatbots. The journey from early models like ELIZA, which debuted in 1966, to today's sophisticated LLMs showcase an incredible leap in AI capabilities. So join us guys as we delve into how these models work, their applications, and what the future holds for this groundbreaking technology. And don't forget to like, subscribe, and hit the bell icon so you never miss on any update. And let's jump in. So let's start with large language models. And large language models are advanced AI systems that are designed to understand, generate, and manipulate human language. And they're trained on vast datasets and use deep learning techniques to predict and generate text. So this enables them to perform a variety of tasks such as translation, summarization, and even creative writing. Now we'll delve into the evolution of these models, from their early forms to the revolutionary transformer models. So we'll start from RNNs to transformers. So humans see text as words, sentences, and paragraphs. But for computers, text is just a sequence of characters. Initially, recurrent neural networks, that are RNNs, were used to help machines understand text. And these models process one word at a time, which sometimes leads to forgetting earlier parts of the sequence. But there's a game changer. There comes transformer models. In 2017, the introduction of the transformer model revolutionized this field. Unlike RNNs, transformers use an attention mechanism, allowing them to consider the entire sentence or paragraph simultaneously, rather than one word at a time. This approach significantly improves context understanding. So now we'll see how transformers work. So transformers first tokenize text into words or subwords, and these tokens are then encoded into numerical representations and converted into embeddings, which future capture their meanings. The encoder pre-processes these embeddings to create a context vector that represents the entire input. We'll understand this with the help of an example. So here's an example. And the sentence is, as she said this, she looked down at her hands. So now first we'll convert into tokenization. The sentence is broken down into smaller pieces called tokens. As you can see on the screen, we have shifted all the words and provided into inverted commas. Now we'll process with encoding. So each of these tokens is then converted into a numerical representation. Think of it as giving each word a unique number. And now we'll process with embeddings. So these numbers are then turned into vectors, which are multi-dimensional representations that capture the meaning of each token. For instance, the word she and her might have similar vectors because they often appear in similar context. Now we'll process with context vector. So the encoder pre-processes all these vectors together to understand the entire sentence. It creates a context vector, which is like a summary of the meaning of the whole sentence. And at last, we have autoregressive generation. So using the context vector, the decoder can start generating new text. It might predict the next word in a sequence based on the context if it has learned. For example, given the context, it might generate the word and next, leading to a continuation of the sentence. Now let's break down the transformer architecture and understand how all these processes are coming. So this is the diagram for transformers, and this architecture comprises an encoder and a decoder, each with multiple layers. So starting with the encoder, the first layer is input embedding. So the input text is tokenized and converted into embeddings, that is vector representation. And after that, we have positional encoding. This is the second layer. This adds information about the position of each token in the sequence. And after that, we have multi-head attention. That's a layer, and it allows the model to focus on different parts of the input sequence simultaneously, capturing various aspects of the input. And after that, we have add and norm layer. So this adds the input of the previous layer and normalizes the result. And then we have feed forward layer. So this is a fully connected feed forward network that pre-processes or processes the attention outputs. And after that, we have again the add and norm layer. This adds the input of the previous layer and normalizes the result again. So this structure is represented n times, that is indicated by nx. And now we'll move to decoder. So decoder has the first layer, that is output embedding. This is similar to input embedding but for the target sequence. And after that, we have positional encoding layer. This adds positional information to the target sequence. And then we have mask multi-head attention. This processes the target sequence while masking future tokens to prevent the model from looking ahead. And then we have add and norm layer. This adds the input of the previous layer and normalizes the result. Then we have multi-head attention. This attends to the encoder's output, allowing the decoder to focus on relevant parts of the input sequence. And then we have add and norm layer. This adds the input of the previous layer and normalizes the result. And then we have feed forward layer, another fully connected feed forward network. And then we have add and norm layer. This adds the input of the previous layer and normalizes the result. And at last, we have linear and softmax layer. So the final layer that converts the decoder output into probabilities, predicting the next token in the sequence. So this was all the process flow, and the encoder processes the entire input sequence, creating a set of encoded representations. And the decoder generates the output sequence step by step using the encoded input and previously generated output tokens. Now talking about why transformers can predict text. So there are two mainly reasons. Number one is redundancy in language, and the next is entropy and predictability. Now talking about the key concepts. Number one is attention mechanism. So it enables the model to weigh the importance of different tokens in the input sequence, improving context understanding. Then we have positional encoding. It helps the model understand the order of tokens, which is crucial for meaning in language. Then we have multi-head attention. It improves the model's ability to capture different relationships in the data by focusing on various parts of the sequence simultaneously. And this architecture allows the transform model to handle long sequences and complex language tasks effectively, making it a cornerstone of modern NLP applications. Now that we have understood how transformers work, let's discuss what makes large language models so popular and their capabilities. So a large language model is a type of artificial intelligence algorithm that uses deep learning techniques and large data sets to understand, summarize, generate, and predict new content. They are a subset of generative AI specifically designed to create text-based content. Now talking about its historical context, so language is crucial for communication. But in AI, language models serve to communicate and generate concepts. One of the earliest AI language models are ELIZA that debuted in 1966. And then we have modern LLMs like GPT-3 and Megatron, Turing, and LG530B that are vastly expand on this idea of billions of parameters, allowing them to understand and generate text more effectively. Now we'll see the examples. Number one, as we have discussed, that is GPT-3, that is released by OpenAI in June 2020, and this model has 175 billion parameters and can generate text and code from short prompts. It's highly versatile and can perform a wide range of language tasks. And after that, we have Megatron, Turing, and LG530B that is developed by NVIDIA and Microsoft. And this model boasts 530 billion parameters. And it excels in reading comprehension and natural language inference, making it one of the most powerful LLMs to date. So now we'll explore the various capabilities of these large language models and how they are utilized. So starting with the capabilities. So the capabilities start with generation. So they can create stories, marketing content, and more. For instance, GPT-3 can write a coherent article or generate creative writing pieces. Then we have summarization. So condensing legal documents, meeting notes, or any lengthy text into concise summaries. This is particularly useful in legal and corporate settings. And then we have translation as a capability. So converting text from one language to another or even translating text into code. This makes LLMs invaluable in global communication and software development. Now we'll move to classification. It can analyze text to determine sentiment, classify topics, or identify toxic language. This can help in moderating online content and understanding customer feedback. And after that, we have another capability, that is chatbots. So building virtual assistant and Q&A systems that can interact with users in a human-like manner that provides customer support or general information. So these were all the capabilities. Now we'll look at some real-world applications of LLMs across various industries. And we'll start with healthcare. So LLMs are used to predict protein structures, uncover disease patterns, and analyze medical text and patient records. This can lead to breakthroughs in medical research and personalized healthcare. Then we have retail as real-world application. It can enhance customer service through dynamic chatbots that can handle inquiries, provide recommendations, and improve the shopping experience. And then we have real-world application in software development. And after that, we have software development. So LLMs assist developers in writing code, debugging, and even teaching robots to perform physical tasks. And then we have finance as real-world application. So LLMs can summarize earning calls, creating meeting transcript, and analyzing financial documents to provide insights and support decision making. And then we have marketing as real-world application. It can organize customer feedback, segmenting products, and generating compelling marketing content. Now that we have seen their applications, let's understand how large language models work and the learning techniques they use. So large language models work with training with unsupervised learning. So LLMs are trained using unsupervised learning, which means they learn from large data sets without labeled data. They find patterns and relationships in the data, enabling them to perform various tasks like text generation, summarization, and translation. And there are three types of learning for the LLMs. And we'll see, number one is zero-shot learning. So zero-shot learning, LLMs can perform tasks they were not specifically trained for, and thanks to their extensive training data for this. And then we have one-shot learning. So they can learn from a single example to improve their performance on a specific task. Then we have few-shot learning. So learning from a few examples, enhancing their ability to generalize and perform tasks accurately. And then we have customization techniques for LLMs. Number one customization technique is prompt tuning. So adjusting the prompts or instructions given to the model to guide its response more effectively. And number second is fine tuning. So retraining the model on specific data sets to improve its accuracy for certain tasks. Then we have adapters. So adding smaller network to the model, allowing it to adapt to specific tasks without needing to retrain the entire model. That's the adapters and the customization technique for LLMs. Now we'll move to the types of large language models. And number one type is encoded only models. So these models are excellent for understanding tasks such as classification and sentiment analysis. An example is BERT, that is bidirectional encoder representations from transformers. Now moving to second type of large language model, that is decoder only models. So these models are great at generating text such as writing stories or articles. An example is GPT-3, that is generative pre-trained transformer 3. And then we have third type of large language model, that is encoder-decoder model. These models combine understanding and generation, making them ideal for tasks like translation and summarization. An example is T5, that is text-to-text transfer transformer. Now we'll move to advantages and challenges of large language models. So starting with advantages, Number one is extensibility. So LLMs serve as a foundation for various customized use cases, allowing for adaptation to numerous tasks. Then comes flexibility. LLMs apply across diverse tasks and deployments from chatbots to content creation. And then we have performance. So LLMs provide high speed, low latency responses, making them efficient and responsive. And the accuracy. So there's an improved accuracy with more parameters and larger training dataset. And the ease of training. It utilizes labeled data, which accelerates the training process. And then comes efficiency. So LLMs automate routine tasks, saving time and resources. And now coming to challenges. So number one challenge is development cost. So it requires significant investment in hardware and large data sets. And then comes operational cost. So high ongoing expenses for running and maintaining LLMs. Then there comes bias. So its potential for inheriting biases present in the training data. Then comes ethical concerns. There are issues around data privacy and generating harmful content. Then comes explainability. So there's a difficulty in explaining how the models generate the results. And then there's the last challenge, that is hallucination. So there's a risk of generating inaccurate or nonsensical responses from the LLMs. Now talking about the future of large language models. The future of LLMs is very promising. With continuous improvements in accuracy, efficiency, and applications, businesses will increasingly leverage LLMs for various tasks, enhancing productivity and innovation. So in conclusion, large language models are transforming the AI landscape by understanding and generating human-like text. While they come with challenges, their potential to revolutionize various industries is immense.
Welcome to the short course on Generative AI Models for Beginners by Simplilearn. So in this course, we will learn about the basic understanding of Generative AI. Then we will move on to the applications of the many GenAI tools. And thirdly, we will understand the GenAI models, and then we will create our first GenAI model. And then we will move on and see the real world impact of the generative AI models. And then we will create a chatbot using the GenAI model. And then we will conclude the course with the limitations of the GenAI models, and finally we will see the future of GenAI models. Now let us begin with the first chapter, that is basic understanding of generative AI. So let us begin with what is generative AI. So generative AI is a type of artificial intelligence that creates new content such as text, images, music, or even code from scratch based on what it has learned. So unlike the traditional AI, which just analyzes or classifies data, like recognizing faces or recommending products, generative AI creates. It's like the difference between a judge and an artist. One evaluates and the other one imagines and produces. So let's break it down with a simple real-world examples. The first one is ChatGPT, that is a text generation. So what it does? So ChatGPT, like the one you are talking to right now, generates human-like conversations and answers. So you can ask it to write stories, emails, explain difficult topics, or even debug a code. For example, you say, write me a bedtime story about a robot and a unicorn. The ChatGPT creates an entire story for you on that particular spot. So let's move on and see DALL-E, that is for the image generation. So DALL-E creates pictures from words, that is the text prompts. Then artists and marketers use it to generate logos, illustrations, or more without hiring a designer. For example, you type a cat wearing a spacesuit on Mars, and DALL-E draws it instantly. Now moving on to GPT-3, that is text plus logic task. So what it does? So GPT-3 is a powerful language model that can create and write essays, summary books, translate languages, and even write computer code. So developers use it in apps to create smart features like the AI writing assistant. So then you give GPT-3 a blog title and it writes the full article with an intro, subheadings, and conclusion. So after knowing all this, let's move on and see why are generative models. So generative models are changing the way we create content across multiple fields. So under the text field, we are writing books, articles, reports, or even poetry. And then we are assisting in the customer support with the chatbots. And then under the images section, we are helping the artist generate concepts and visuals. And then we are even handling the speeding up design and marketing content creation. And then under the music part, we are composing the background scores for videos or games. And then we are helping musicians brainstorm the melodies or the lyrics. And then finally, we write the boilerplate code under this coding section, debugging, or even creating full web apps. So now moving on, we'll see traditional AI versus generative AI. So let's compare both side by side with the simple explanations. So the main goal of traditional AI is to analyze and make decisions. And the main goal of generative AI is create new content. For example, under traditional AI, predicting stock prices or recommending books on movies. And the generative AI, we are writing stories, generating images, and so on. So traditional AI handles data. It uses data to classify or forecast, and generative AI learns from data to generate something new. The traditional AI, it labels, scores, and categories as output, and generative AI, the text, images, music videos, and so on. For example, traditional AI is face recognition, fraud detection, spam filters, and generative AI is ChatGPT, DALL-E, Music LM, and so on. So down the line in the next chapter, we will see the applications of some generative AI tools like the ChatGPT, DALL-E, and GPT-3. So imagine this. You are working on a college project. It's late at night and the deadlines is tomorrow. You need a well-written report and a poster design and a clear presentation. So total chaos, right? But what if I tell you that there's an AI assistant that can help you with all of this in just minutes? So welcome to the world of generative AI. Today we'll explore how tools like ChatGPT, DALL-E, and GPT-3 are being used by the students, content creators, and professionals to do amazing things faster, easier, and smarter. So let's break down each tool and see how you can actually use them in real life. So this is ChatGPT 4.0. If you're not aware of what ChatGPT is, so ChatGPT is an AI chatbot that can create, write essays, summaries, articles, explain topics, solve coding problems, and even conduct mock interviews all through one single chat. So let's look at real ways you can use it. So ChatGPT model, it uses this GPT-4, the latest in the generative AI pre-trained transformer that is a GPT family. So GPT-4 is designed for more nuanced and human-like conversation. So have a look at the real ways we can use it. So the first prompt we are going to try is explain the greenhouse effect like I am in class 12. So basically this prompt is asking for the greenhouse effect explanation, and it is asking the ChatGPT to behave that it is explaining to a class 12 person. So we will give this. So you can basically see a human-like generation. Just like, sure, the greenhouse effect is a natural process that warms the Earth's surface. It happens when certain gases in the Earth's atmosphere trap the heat. Here's how it works. It will have a detailed explanation on the solar energy, Earth's surface absorption, greenhouse gases, heat trapping, and all. So after all this 4 points, it has also given without the greenhouse effect, the earth would be too cold to sustain life. However, human activities like as burning fossil fuels, deforestation, and industrial processes. So you can basically think it has given one nutshell, and if you just understand this, you have a clear vision of what a greenhouse effect is. So the first point we can see over here is that it is like a own tutor. So the first point, we have just been to ChatGPT that is founded by chat.openai.com. We have typed a question and we have got a simple and easy to understand answer. And even you can have a follow-up question like, if I ask, is solar energy related to greenhouse effect? You can even have a follow-up question. Yes, solar energy is related to the greenhouse effect. So it's almost like its own tutor. So great for the late night cramming or the quick concept clarity. So this is it. And now moving on to the second thing that it can help with, that writing assignments or essays in just minutes. So we will ask ChatGPT, write a 350 word essay on climate change for college purpose. And you can see I have provided conditions. You can even customize it by saying make it simple and yet engaging and awesome. So it will basically it has even created a own title, a growing concern for our future. Climate change, it has created paragraphs, and basically you can even customize this word count and topic, then review the generated draft. You can even personalize it. Do you like this personality? And done and dusted. You can just have this. Now writing feels less stressful and it would be more fun. It can even give you an interview experience. For example, just imagine you are having your interview on the next Monday and you are preparing and you're very confused about what to prepare and what not. Then you can basically ask ChatGPT to behave like an interviewer for a particular job. I can even paste your job description from that particular company and you can ask that what are the probable questions I can have. So let's have a demo. Ask me 3 HR questions for a software development internship and suggest improvements. And we can even post this. And in no time, it has started generating. Here are the 3 HR questions for a software development internship. The first one, can you walk me through a recent coding project you have worked on and explain how you approach solving the problem? And you know what? This is a very, very common question. And it has given one tip also, suggestion. This question evaluates your problem solving skills, your technical ability, and how you approach development tasks. It gives the interviewer insight into your practical experience and thought process. So how do you manage the deadlines when working on the multiple projects or the tasks simultaneously? So this question assesses your time management skills and ability to prioritize the task. So the software development often involves juggling multiple assignments. So this gives the interviewer an idea of your organization skills. So this is very important. It has also written, how do you keep yourself updated with the latest programming languages and technologies? So basically this question looks after your own learning ability. So the self-improvement part. So it has even created one answer over it. And it has also suggestions for the improvement, provide specific examples, highlight the soft skills, prepare for the problem-solving questions, and so on. And for example, if I write, customize it with a data analyst fresher role, having no experience, what all the interviewer can ask me in the technical round, and it will give you answer in no time. HR questions for a data analyst fresher. Why are you interested in pursuing a career as a data analyst, and what are the steps you have taken to prepare yourself for this role? Can you describe a situation where you had to analyze data or solve a problem using numbers or data in your studies or personal projects? How do you approach learning new tools or technologies, especially when it comes to data analysis software? And then we have this technical question. What is the difference between the structured and unstructured data? What is data normalization? How comfortable are you with the data visualization tools? Can you describe a visualization you would use to represent sales data over time? Can you explain what a pivot table is when it is used in data analysis? And there are suggestions that showcase your learning journey, focus on the problem solving skills, prepare for the basic technical questions. Since you are a fresher, the technical questions may focus on the fundamentals like the Excel, Python, that is the libraries, pandas, and so on. So in no time, it can even have a mock interview over here. So you can even create ideas over here. It can brainstorm you with the ideas available. For example, you have a group project and you want an idea. I'll type over here, give 5 creative ideas for a group project on sustainability. And if you post this, in no time it has created this 5 ideas. Sustainable packaging design challenge. Objectives, design a sustainable. It has created one objective, it has given one approach for you and one outcome. Then it has created community-based urban garden, and for each topic if you see, for each idea if you see, it has created the objective, the approach and the outcome. So these projects can not only be educational but also impactful. So you never run out of inspiration from ChatGPT. So ChatGPT is a lot. And here if you can actually see, it has various search, deep search and create image, and you can basically do everything you want from ChatGPT. Let's now move on to DALL-E. The next we would be seeing is DALL-E. So DALL-E is an AI that creates images from text. You tell it what to draw and it generates the artwork, logos and visuals. So you would be getting DALL-E from this ChatGPT only, and in the Explore GPTs in the sidebar, you have to just mention DALL-E 2. So there are various versions of DALL-E and we'll start chatting. And now if you close this sidebar, you can basically see DALL-E 2. So DALL-E is an AI that creates the images, and DALL-E, this model uses a version of the CLIP model, that is a contrastive language image pre-training, combined with the VQ-VA2 or other generative image models. So DALL-E creates images from the text descriptions, generating highly creative visuals based on the natural language input. So let's see how you can use it. So for example, you're going to design when the college poster design. So instantly it would be done. So we would write create a poster for a college fest with DJs, neon lights and a crazy crowd, okay? And you can basically give the prompt. And in no time, it will create one great image for you. You can write and you can see it has created a great image. You can basically download this image and do anything. Here's the poster for your college fest featuring a vibrant DJ scene with the neon lights and the energetic crowd. So forget Photoshop, let AI do the heavy lifting. So then you can create presentations over here, adding better visuals. So I'll write, draw a cartoon showing water pollution in a river. And you can basically see this. Now, you can insert it into the PowerPoint or Canva and design it on your own. It acts as a vector, it acts as an icon, and anything you want to act. Then you can instantly create club logos and branding. So you can even generate a logo for over here through DALL-E 2. Logo for a coffee club with books and steaming mugs. And you can see it has created a drastic logo and it feels like real. So you had just given one prompt and get 4 to 5 variations of logo. You can even ask it for a different version. So great for the student clubs or college events. Then you can even have it for the costume design or any ideas again. So we'll write futuristic costume design for a sci-fi play with glowing elements. And even you can see here, it has created a futuristic costume design for a scientific fiction play with the glowing elements. And it is and use vivid descriptions, use more detailed prompts, and you will get a great output from DALL-E 2. So art students and theater class, this is your new secret weapon. So let's move on to GPT-3. Our next Genai tool is GPT-3. So GPT-3 is the powerhouse engine behind the tools like ChatGPT. So it doesn't just chat, it can write full code, research summary papers, business emails, and more. So GPT-3 is a predecessor of GPT-4 based on the same GPT architecture but with a 175 billion parameters. It was one of the most advanced language models when it was released. So let's explore how it helps in the real world task. So initially, we can use ChatGPT because it is a ChatGPT 4 version. There is a GPT-3 is basically a predecessor of GPT-4. So I'm using ChatGPT over here. You can also use ChatGPT 4 to understand the GPT-3. So the first one is building websites without coding. So you can even write a HTML for personal portfolio with my name, bio, and contact form. And in no time, it has generated this. You can just copy it, paste it in VS Code or any of the code editors you like, and you can definitely get a proper output of this. Perfect for the beginners or the design students. Then you can even summarize a lengthy research paper. You can have to just upload the paper, and if you see this plus section, you can just click on this. You can just upload from your computer and summarize it in 2 seconds. It can even brainstorm you with the project and the startup ideas, like suggest 5 unique app ideas for college students. Now you can see the first one is Study Buddy Finder. Helps students find partners based on their courses, schedules, and many preferences. And you can even see Campus Event Hub, Course Material Exchange, Mental Wellness Check-in, Foodie Finder, and so on. It has even created bullet points for better understanding. So it is a noise-free study timer. Use it to kickstart your next hackathon or competition or anything. So I'm not dragging it more because as I have already showed you the use of ChatGPT. So that's it. Moving on to the next lesson of understanding the generative AI models. Imagine you are teaching a computer to be creative, like painting a picture, writing a poetry, or designing a dress. That's exactly what generative AI models aim to do. So learn from the data and generate new content that looks, sound, or feels real. But how do this pull off? Let's break it down into the three major families of models. The first one is GANs, that is the Generative Adversarial Networks. Then the second one we have is VAEs, that is the Variational Autoencoders. And the third one, the final one, is transformers like the GPT. So let's understand this in a detailed one. The first one is Generative Adversarial Networks, GANs, the artist versus the critic game. So how it works? Think of GANs like a competition between the two neural networks. The generator is like a rookie artist trying to create a fake art. The discriminator is the tough critic trying to tell the real art from the fake. So the artist creates random images. The critic says fake or real, and the artist learns to get better. So over the time, the fake images become indistinguishable from the real ones. So there's a real world analogy. It's like a student, that is a generator, forging a signature and a teacher, discriminator, spotting it. As both improve, the forgeries become nearly perfect. So there are certain applications. The first application is creating realistic human faces. Then style, the transfer in the art. And then we have fashion design prototypes. And then finally we have deep fakes, that is controversial but technically fascinating. And then let's move on to the challenges. So training instability. The second one is it requires a lot of data and computing. So moving on, we'll understand variational autoencoders, that is the VAs, the data compressor with creativity. So VAs are like the compress and the rebuild systems. They take input data like an image, compress it into a low dimensional space that is called a latent space, and then reconstruct it. But here's the twist. The VAs don't just remember, they imagine. So by sampling different points in the latent space, they can generate new similar looking content. So let's move on and see the applications. First application is anomaly detection. So what doesn't fit in the normal data? Then the second one is generating handwritten digits and faces. And then we have data compression. And then finally we can see drug discovery, that is generating molecular structures. So now let's move on to the strengths. So more stable than the GANs, and it gives a well-structured latent space for the interpolation. So now moving on to the third model, we have transformer models, that is a master of the sequences. So unlike the GANs or the VAs, which focus more on images, transformers shine in handling sequences, especially the text. The core data idea is attention mechanism, a way to let the model focus on the different words when generating a sentence. So for example, when GPT generates a sentence, I like ice cream because it's sweet. It pays attention to the context, understanding how because relates to the ice cream and sweet. So let's now move on to the applications. The first one is chatbots, like the ChatGPT. And then we have code generation, that is the GitHub Copilot. And then thirdly, we have language translation. And finally, we have summarization and content creation. And then let's move on and see why transformers stand out. So the first one is they scale data well. The second one is they can be fine-tuned on specific tasks like the medical summarization or legal drafting. Then finally they handle the long-range dependencies better than the older models like the RNNs or the LSTMs. Then we have a comparison and the use cases. So the first one is GANs, and it is best at image generation. And then we have an example use, that is the face synthesis. And the associated strength is high realism, and the weakness is it is hard to train. Then we are seeing the VAEs, and it is best at data compression, plus it is also good in anomaly detection. So it is used as a latent space exploration. And then coming to the strength, it is very stable training, and then coming to weakness, it has a less sharp outputs. So then coming to the model type, that is the transformers, and it is best at text and language. And then we have an example use, that is a ChatGPT and summarization. And then we have strength, that is powerful with the large data. And then we have certain weakness, that is expensive to train. Now moving on, let's clear something, which to use and when. So if you don't know which generative model to use for what, it can mess things up fast. So let's say you are building an app that needs to write emails, make pictures, answer questions, and turn speech into text. If you use the wrong model for the wrong job, your results will be poor, things will be slow, and you will waste time. So let's understand which models performs what. So for a sharp realistic images, we are using GANs. And then coming to the next, for variation and latent space analysis, we are using VAEs. And then finally, for the language or the text-based task, we are using transformers. So finally, how do these models actually work? So the GAN training process is, the first process is generator makes the fake data. Then the step 2 is the discriminator tries to classify the real versus fake. Then the third step is both get better at their jobs with each round. So the final goal is to fool the discriminator with the realistic outputs. So the transformers under the hood pays attention mechanism. So it helps model understand which words matter more. Then we have self-attention, that is allows the model to look at all the words in a sentence at once. And then we have positional, that is encoding, and it helps track the orders of the words, as transformers don't read left to right like humans. So this is why models like GPT-4 can summarize, translate, and generate in text so well. So understanding the differences between these generative models is like knowing which tool to use for which creative job. So GANs are your digital painters, VAs are the smart compressors with imagination, and transformers are your text wizards. So down the line, we'll see how to create our first generative AI model. In this chapter, we will be creating our first generative AI model. So the objective of this lesson is breaking down the steps of building a generative AI model using a pre-trained model. So we are here not training a model from the scratch. So instead, we will fine-tune or directly use a pre-trained model. So this makes it fast and beginner-friendly. So if I tell the steps in nutshell, it will be, we will be first choosing a pre-trained model. For example, GPT-2 because it is lightweight and good for beginners. The source from which we will be getting the model is Hugging Face's Model Hub, and then we will be setting up the environment in Google Colab, as you can see. Then we will be installing the libraries, the transformers, torch, and then loading the pre-trained model and the tokenizer. Then we will be writing a prompt and generating a text. So here we will be using the pipeline API for simplicity and parameters like max length and temperature. So let's begin. So here I am inside this Google Colab and I have chosen a new notebook to begin with, and then I'll just insert exclamation pip install transformers and shift enter. And it may take some time. and you can see it has actually installing all the required transformers. So pip install means install this package in Colab, and transformers is a library by the Hugging Face. So it gives us access to the powerful AI models like GPT-2, BERT and more. And then we will install from transformers import pipeline, and then we will be using the loading generator GPT-2 text generator. So generator equal to, and you can see pipeline text generation and tab. So we'll execute this, and basically this pipeline is a shortcut tool. It hides all the complex code needed to run the AI models. So here the text generation tells like, hey, I want a model that can write text for me, and GPT-2 is the actual model name. It was trained by the OpenAI to predict what word comes next in a sentence. And then basically you can see that it has model 7 tensors, 100%, has loaded everything, and the storage is also enabled for this repository. And then we'll begin with the prompt. Okay, so let's give the prompt and let's keep it very simple. Prompt equal to, once upon a time in a world full of AI, comma. And then in the next line I will be writing result is equal to generator, and we will be passing the prompt inside it, and then we will be giving the max length, one parameter, and I will be specifying it as 100, and I will be giving the number return sequence, number return sentence is equal to 1, and I don't require this, so I will be directly printing the result. The first one, the first doc will print, and then we will be passing the generated text, and I will run this. And so the prompt I have given, this is a starting sentence you give to the AI, like saying, hey, start a story with this and this and this. So max length is equal to 100. So this particularly means generate up to 100 words or characters after the prompt. And then you can even see I have given this num return sequence is equal to 1. This is asking for just one version of the result. So you can basically ask for 2-3 versions. I have just asked for only one. And then the result you can see. And in the third bracket, I have given a 0 and the generated text. It extracts the generated text from the result. So you will see the AI write a continuation of your prompt basically. So that's your first generative AI output. You can basically see, once upon a time in the world of AI, your only limit was when you could kill monsters, but now you can for the first time ever. The new monsters are in the battle in the blood of elves now, not the usual black and white battles that you have experienced with the past couple of years, and it has created a great one. So you can even see the power of generative AI. It has that power of completing your text, your prompt. So then let's write result equal to generator and if I want to write prompt comma enter, then max length I will again mention equal to 100. Then enter. I want the num return sequence equal to 1, and have to put a comma over here. Okay, so don't forget this, guys. And then temperature is equal to 0.7 comma top k. Don't worry, I'll explain one by one as I write. Equal to 50. Then top p equal to 0.95 comma, then I'll write do samples equal to true, basically a boolean value. So then after this I'll print the result, print result, and in third brackets will be the first one, and then again third brackets will give in generated text, and then I'll basically gonna shift enter. So here basically we have parameters like temperature. So temperature, what it does, it controls the creativity. This the lower is equal to safe and higher is the wild, and creative is 0.7 medium. So this top underscore k is equal to 50. So pick from the top 50 likely next words instead of just the top one. Then we have this top underscore p is equal to 0. It is the nuclear sampling, that is a more natural randomness. Then we have do sample is equal to true, that is enables the randomness. So without this the output is too predictable. So once you run this code, you will see something like, once upon a time in a world full of AI, and with every advancement in AI machines, there has been a change in the way we think about the world, and we need to make sure that we can make sure, and it has repeated it so many times. So every time you run it, you might get a slightly different result. So over here, you have used the Hugging Faces Transformers library to load the GPT-2. Then you wrote a prompt, and then the AI continued it using its training. So you did it without any complex machine learning setup inside the Google Colab. So this is your very first generative AI model. In the next chapter, we will be seeing the real world of impact of generative AI models. So generative AI is not just about another buzzword. It's fundamentally changing how businesses operate, solve problems, and serve customers. From generating product descriptions to designing aircraft parts, generating AI is stepping into roles that once required human creativity and intelligence. So in this session, we will explore how industries across the board are using generative AI in meaningful and practical ways. The first one is healthcare. That is a faster diagnosis and drug discovery. So in healthcare, generative AI is helping doctors and scientists make faster decisions. The first one is medical imaging. So AI can analyze medical images like the X-rays or MRIs and create reports to help doctors quickly identify the problems. For example, a hospital uses AI to write reports for doctors, cutting down the time spent on each patient. Then we have drug discovery. So AI helps scientists discover new medicines faster by predicting how proteins fold, which is important for the creating drugs. For example, a company used AI to discover a new drug in just 18 months, which usually takes much longer time. Then moving on to the next one, we have finance, that is a smarter risk management and report generation. So in finance, AI is making it easier to analyze data and detect the problems. The first one is automated financial reports. So AI can create financial reports based on data, saving time for analysts. For example, a hedge fund uses AI to write the market reports in minutes. Then we have fraud detection. So AI helps banks detect fraud by generating the fake transaction data to test their security systems, making them more reliable. So for instance, MasterCard uses AI to create realistic transaction data to improve their fraud detection system. So now moving on to the third, we have retail, and that is the personalized shopping experience. So retailers use AI to create personalized shopping experiences for customers. The first one we have is product descriptions. So AI writes product descriptions that are customized for different customer groups, such as casual descriptions for young buyers and formal ones for the professionals. For example, a clothing brand uses AI to automatically write descriptions for thousands of products. And then we have virtual try-ons. So AI lets customers try on clothes or makeup virtually to see how it would look on them before buying. So for instance, Sephora's app uses AI to suggest makeup and lets users see how it looks on their face using their phone camera. So now moving on to the fourth one, we have manufacturing. There is a faster design and maintenance. So AI is also making manufacturing more efficient. The first one is AI generated designs. AI helps create lighter, stronger parts for products, reducing waste and material costs. For example, an airplane company used AI to design parts that were 50% lighter but just as strong as the traditional designs. Then moving on, we have predictive maintenance. So AI helps factories predict when machines will need maintenance, reducing downtime and improving efficiency. For example, a factory uses AI to automatically create maintenance schedules for machines based on their performance data. So now moving on to the fifth one, we have education. That is a personalized learning for students. So AI is making education more personalized and accessible. The first one is AI tutors. So AI-powered tutors can help students with the homework by guiding them step by step through problems. For example, a student stuck on a math problem can get hints and explanations from an AI tutor available at any time. Then we have automated feedback. So teachers use AI to create quizzes and provide feedback on assignments, saving them hours each week. For instance, a teacher uses AI to review essays and provide comments in just minutes instead of hours. So now moving on, we have sixth one is entertainment, that is creating content at a scale. So in entertainment, AI is being used to create content faster and cheaper. First one is script writing. AI can help writers come up with ideas, generate dialogues, and even create storyboards before filming. For example, a filmmaker uses AI to plan scenes and create visuals before they start shooting, save time in the pre-production. So then we have virtual characters. So AI can create virtual characters that speak and act, which is useful for movies, games, and social media content. For instance, AI is used to create virtual influencers who interact with their followers on social media. So now moving on down the line, we will see how to create a chatbot in Google Colab. So before we dive into the code, let's first understand what the Hugging Face Transformers library is. So the Hugging Face Transformers library is one of the most popular libraries for the natural language processing, and it provides the pre-trained models that can perform a variety of tasks like the text generation, text classification, named entity recognition, and more. So here In the code, we will be using a model called Dialog GPT Small, which is a variant of GPT-2 designed for conversation generation. So the Dialog GPT was trained on the large conversational datasets, making it a perfect fit for building the chatbots. So let's now setting up the environment. So for this, we will install pip install transformers. So this line basically installs the transformers library. You need this to work with the pre-trained models provided by the Hugging Face. So this will allow you to load the models like the Dialog GPT we will be using here, a conversational AI model, and use it to generate the chat responses. And here we will begin with importing the necessary libraries. From transformers, import the auto model. For the casual LM auto tokenizer, import torch, and then we will run this. So here we are importing the necessary components like the auto model ID for the casual LM. So this class basically loads a pre-trained model for the casual language modeling, which is used for the text generation task. So we will use it to load the Dialog GPT model. And the auto tokenizer, the tokenizer converts the text into tokens which are known as numbers, that the model can process and then converts the model's output back into the human readable text. So the torch is then, PyTorch is the deep learning framework used by the model. It's used for the tensor manipulations as models rely on these tensors for the input and output. So let's begin. Then we will begin with the loading the model and the tokenizer. So here this converts the raw text, that is the user input, into tokens. Into that model understands. So each word or phrase is mapped into the unique ID, making it easier for the model to process and generate a response. So then model is that pre-trained Dialog GPT small model is loaded over here. So this model has been trained on a large corpus of dialogues, which enables it to generate the relevant responses in a conversational manner. So then we will begin with the chat initialization. And before beginning with the chat initialization, we will see that the tokenizer config.json is 100% complete, and the best part of Collab is it will give you all the status of how it is complete and for which particular merges.txt.vocab.json which is completing and what problem is there. So let's just run this and let me explain. So chat history IDs. So this is a variable where we store the history of the conversation. So this helps the model maintain the context across multiple user inputs. Then we have having a print statement that start chatting with your AI, type quit to exit. So this provides a welcoming message to the user to start chatting and gives the exit command. So then we will begin with the chat loop, that is the main logic of the chatbot. So then we'll begin with this chat loop logic. So we have written for step in range 5, user input is equal to input, and then u, and then semicolon, and then a space. And then we have written if user input dot lower is equal to quit, then I have to break it. Break the loop. Break. So then I'll run this. And the section of the code basically uses input to get the user's message and exit condition. If the user types quit, the loop will break and the chat ends. So let's see. And here basically you can see I have written hey and still it doesn't break. So let's write quit over here and let's see what happens. So you can see that it has stopped generating, means it has got out of the logic. So here we have this encoding user input. So encoding, the user input is converted into token IDs using the tokenizer .encode. So the EOS token, that is the end of sequence token, is added at the end of the user input. This tells the model that the input has ended and it prepares for generating a response. Then tensors. So this is the return underscore tensors equal to PT. That part ensures that the encoded input is returned as a PyTorch tensor. This is the format that the model expects. So we will run this. And then we will be moving on to managing the conversation in history. So here we are having this managing conversation history, and it is up to maintaining the context. So we want to keep the track of the conversation history so that the model can respond in context. So if there's previous chat history, that is the chat history IDs, it is concatenated with the new input, allowing the model to consider the entire conversation so far. So if there is no previous history, that is the first user input, the new input IDs are used directly. So then we will be moving on to generating a response. So here we are concentrating on generating a response. Chat history IDs is equal to model generated bot input IDs, max length equal to 1000, and pat token ID is equal to tokenizer.eos token ID. So model response, so this part sends the concatenated input to the model, that is model.generate, and generates a response. The maximum length specifies the maximum length of the generated text. So in this case, it is set to 1000 tokens. Then we have pad token ID, that is ensures the padding tokens are handed correctly. That is, the model needs to know which tokens are just padding. Then we will be moving on to the decoding the response. And here we are seeing response is equal to tokenizer.decode chat history IDs, there is a bot input IDs.shape and everything. So basically decoding this generated token IDs are converted back into the human readable text using the tokenizer.decode. Then we have skipped the special tokens. The skipped special tokens is equal to true. It ensures that any special tokens like the EOS are not included in the final output. So we will run this. And then finally, we are actually printing the response, that is displaying the response. So the print, this generating the response, is displayed to the user. So we'll run this. And you can see, bot, I'm so sorry. So what happens when you run this code? You initiate the chat and the bot welcomes you to start chatting. So every time you input something, the bot takes your message, encodes it, and sends it to the model along with the conversation history. The model generates a response considering the entire conversation so far, and the bot outputs that response. So this loop continues until you type quit, ending the conversation. So building a chatbot is essential because it enhances the user engagement by providing the real-time personalized interactions, making it more dynamic and user-friendly compared to the static content. So chatbots are available 24/7, ensuring the users can get immediate responses at any time. So by automating the repetitive tasks like answering common questions, processing orders, or providing basic customer support, chatbots free up valuable resources, allowing human employees to focus on more complex tasks. So then, additionally, chatbots can improve customer satisfaction by quickly resolving the inquiries, reducing the wait times, and enhancing the overall user experience. So implementing the context management allows the bot to remember the previous interactions, ensuring a continuous and more personalized experience for the user. So finally, enabling the multi-turn conversation handling means the chatbot can engage in back and forth dialogues rather than only answering the isolated questions, so making it feel more conversational and human-like. So these features collectively help create an intelligent, efficient, and engaging chatbot that can significantly improve user interactions and streamline the business operations. So you can even fine-tune your own model. So this could be your own dataset to make it more specific to a particular domain or a use case. You can even make it worth handling the longer conversations so that it remembers the chat history for a long time. So guys, you have made your first chatbot and down the line, let's get improved. So in this lesson, we will understand about the limitations of generative AI models. So the first one is lack of understanding. So AI models generate content by predicting what comes next based on the patterns in data, but they don't truly understand the content. For example, when an AI creates an article or a code, it doesn't know what it's writing. It's just mixing patterns based on the past data. Then moving on to the dependence on the data quality. So the AI's performance is only as good as the data it's trained on. So if it has biased or incomplete data, it can generate biased or inaccurate results. Think about biased hiring algorithms or flawed healthcare recommendations, real issues caused by the bad training data. So now moving on to the third one, we have creativity limitations. So AI can produce impressive creative outputs like artwork or music. So however, it struggles to innovate or produce truly original ideas like a human artist would. It's more about remixing the existing content rather than inventing something groundbreaking. Now moving on to the next, we have ethical concerns. So AI models can sometimes generate harmful content, from offensive language to deep fakes that are hard to distinguish from the real footage. So this poses risk for misinformation and ethical dilemmas, especially in media and entertainment. So now moving on to the next, we have context and nuance. So generative AI can miss the subtle nuance in conservations or emotions. For instance, if you asked a model to help with the sensitive topics like mental health, it might offer advice that's generic and more tailored to the individual's emotional needs. Next, we have cost and resource intensive. So training a generative AI model requires huge amounts of computing power, time, and energy. So these models often run on the powerful servers, consuming a lot of resources, which raises concerns about the sustainability and the environmental impact. So now moving on to the next one, we have limited problem solving capabilities. While generative AI is great at tasks like writing essays or summarizing text, it's not well suited for the task requiring the deeper reasoning or the complex problem solving. It can simulate problem solving, but it doesn't truly understand the solution in the way humans do. Now, moving on to the next one, we have risk of over-reliance. So with AI generating more and more content, there's a risk of becoming too dependent on the technology. So people might rely on AI for the tasks that require human expertise or critical thinking, which could hinder the personal creativity or decision making. So now moving on, we have data privacy issues. So AI models can sometimes generate content based on the personal data, raising concerns about privacy. So this is especially problematic in the areas like healthcare, where sensitive data can be inadvertently shared or misused. So now moving on to the next one, we have generalization challenges. So generative models are great at specific tasks, but struggle with the broader generalization. For instance, a model trained to generate images of the cats may struggle to create the convincing images of a completely different animal, showing that AI is limited in its flexibility. Now moving on down the line, we will understand the future of Gen AI models. The first one is improved understanding and comprehension. So that the future of generative AI will likely see models that can understand the context more deeply, providing more relevant and meaningful outputs. So we might see AI models that can truly comprehend the meaning behind the responses, rather than just spitting out the data. So next, we'll move on to the enhanced creativity. So as AI models evolve, we can expect them to push boundaries and become more innovative. So with advancements in the techniques like the reinforcement learning and neural architecture search, we could see AI producing truly original content, potentially revolutionizing fields like the art, music, and literature. So now moving on, we have more ethical AI. So in the future, we will likely see more regulations around AI usage to prevent the harmful outcomes. So AI companies are already working on improving the transparency, reducing bias, and making their models more ethical and responsible. So now moving on, we have better personalization. So the future holds AI that can offer more tailored, personalized experience. So imagine an AI that truly understands your needs and preferences. So providing you with the content, products or services that feel personalized and relevant. Now moving on to the next one, we have energy efficiency. So as the demand for the generative AI grows, researchers are focusing on creating more energy efficient models. We may see smaller, more powerful models that can run on less computational power, reducing the environmental impact. So next we have human AI collaboration. So rather than replacing humans, the future of generative AI models is likely to be centered on collaboration. So we will see AI helping people be more productive, augmenting creativity and providing insights that humans can use to make better decisions. So now moving on to the next, we have integration with the new technologies. So generative AI will continue to integrate with the new technologies like augmented reality, that is the AR, then the virtual reality, that is the VR, the blockchain, and opening up new possibilities for the immersive experiences and the decentralized applications. So now moving on, we have solving complex real-world problems. So in the near future, we could see AI models working alongside scientists to tackle the big challenges like climate change, pandemics, and global food security. So AI could help analyze data, predict trends, and offer innovative solutions to these pressing problems. So now we'll see the next one, we have more accessible AI. So as technology advances, AI will become more accessible. Tools will be easier to use, and people from all the walks of life, not just the technical experts, will be able to harness the power of AI to create and innovate. So while generative AI models are still evolving, their potential to transform the industries, enhance creativity, and solve the complex problems is undeniable. But it's important to address their limitations and work towards creating more ethical, efficient, and responsible AI systems. So the future is exciting and we are just getting started. So guys, congratulations on completing the Gen AI Models for Beginners course by Simplilearn. You have now built a strong foundation on the generative AI models by learning what generative AI was, how it impacted the real world, then creating chatbots, creating your first Gen AI model, and then finally closing it with the future of Gen AI models. So as you move forward, continue experimenting with your own data sets and refining your own pipeline to unlock the full potential of Gen AI in creating smarter, context-aware Gen AI systems and models.
Now we will begin with the agenda for MCP tutorial for beginners. So firstly, we will have a quick briefing of what exactly is an MCP, or as it is called, Multi-Agent Collaboration Protocol. Followed by that, we will understand some basic protocols and standards in communication. Next, we will try to relate MCP to the understanding of protocols and standards. Followed by that, we will get started with our demonstration on developing a web scraper agent using MCP. And for that, we will be needing Node.js, Cursor AI, and Firecrawl API. So I will be walking you through those demonstration steps one after the other, and this will be a very beginner-friendly tutorial and practical demonstration on MCP. Now that I've made myself clear with the agenda, let's get started with MCP. So what exactly is MCP? As MCP on their webpage says, MCP is a Model Context Protocol or Multi-Agent Collaboration Protocol, is an open source protocol that standardizes how applications supply context to large language models. Similar to how USB-C unifies hardware connections, MCP offers a consistent way to integrate AI models with various data sources and tools. Now let's go to the official documentation of MCP to have a broader overview. So, as they say, MCP is one such tool if you remember N8N and all the AI tools and data sources that you used. For example, if you wanted an AI travel agent, as we have an already existing tutorial on our channel, you can go through it for a brief overview. So you might be needing an email writing agent, and you might be needing an airport code searching AI agent, hotel searching AI agent, flight booking AI agent, and a lot of agents connected to one another through a complex network using an ATN platform, right? Now, in this particular MCP, that will be minimized. So you will have a standardized approach where you just eliminate all those boilerplate coding, agents, manual searching for databases, manual search for knowledge bases, manual search for agents, which are specifically designed for the purpose. You just explain your initiative, attach the API keys, and MCP takes over and gives you a fully furnished and finished product within no time. That's the main approach of MCP. So here you can see an overview image where we have the parts MCP host, clients, servers, local data sources, remote services, and local data sources. If you wanted to go ahead with local data sources or local knowledge base, you can go ahead with that. But in case if you wanted some open source, then you can also go ahead with that. So here we have all the quick starts and guides and example and tutorials to how to begin with that one, and all the explore pages that you want to go ahead with if you wanted to have a deep dive into core architecture, the resources available, prompts, tools, transport samplings, and a lot more. And in case if you wanted to contribute your dedicated resources for the community, you can also go ahead with that, and you can also have some support and feedback for MCP. Now that we have a brief understanding of MCP and still clueless about what exactly is MCP, then let's go ahead with some standards and protocols so that you can get a template and you can relate MCP to that template and understand what's the role or importance of MCP in AI agent development. Now, understanding the standards and protocols. Now, let us imagine that you get a team of people to work on a project, and you are the manager that leads and directs this particular team for a purpose, right? Now, the complex problem. No one is friend of anyone. Everyone is new to everyone on the team. And each and every person in this team belongs to a different country and doesn't have a common language in between. For example, person A speaks Mandarin, person B speaks Hindi, person C speaks French, so on. There is no common language between any one of those. Now imagine each and every one of these team members as an AI agent or a tool working for the purpose. In this scenario, you might have to hard code the ports of communication, instructions on how to do, and you need to go on to each and every single AI agent and explain the stuff in a very dedicated and a specific way. This could take a very long time. In the same way, if you relate this to a person, then you might have to reach to every single person and speak to them in their own tongue and explain them the procedures and the steps to be taken to finish the task. Now, how would you do that? It would be a lot complex. Mandarin, you might not even know French or a different language. And in that particular scenario, you might be stuck. What if there was one single language that everyone knew? For example, English. Now you can get all of them together and explain the stuff in one single call and close it. And what might be so wonderful is that you'll not even waste a lot of time, and there is no hard coding, there is no manual effort there, right? In the same way, if you relate this to a web server, then you are the client, you have the server, and you just, let's say you're working on Facebook or Instagram, you try to post something, you try to write a comment, you try to like something, right? That is the activity. And these particular activities will go through 4 different types of requests. One is the get request, put request, post request, and last is the delete request, right? Now, if you are connected to a single server, this might not be as tough as possible. But if you are getting connected to multiple servers, then you might be requiring different protocols every single time. Now, this can be a combination of two parts, HTTP and the URL that you're trying to get connected to, right? Now, to eliminate the efforts between multiple servers and multiple requests at one go, you have one single tool called as API. And the most popular API is the REST API, which has a standard way of communicating. So here, the REST API works as the language English that we discussed before. In the same way, it has maintained a standard where each and every web client can have his communication to his dedicated server or multiple servers in one go using one single language or medium or standard, that is REST API. Without REST API and the standards and protocols, it might be very confusing and you might end up in a complex situation which might not yield in the type of result you're expecting. Now, if you can relate the development of multiple AI agents for a single purpose to the web communication and a meeting, you also expect if there were a template for development of AI agents which could make the process less complex, just like REST API did in a web service and just like English did in a team meeting, then MCP comes into the picture. MCP is your template for it, right? So just like your REST API and the meetings, you have MCP. Earlier, without MCP, we used to have one tool called NA10, where you had all the tools connected to it and all the LLMs programmed to it, and you had to do this hard code coding for each and every tool that you have included in the network and each and every agent that you have related to it. You had to specifically instruct, write down steps, develop a persona to your AI agent, right? There was a lot of stuff. But if you eliminate this particular complexity with one tool, then that would be your MCP. You just had to include MCP and tell your purpose, and your job would be done. Now that you have a brief understanding or a general overview of what exactly is MCP, now let's go ahead and build one. Now, the steps would include the following. For the project that we are building, which is a web crawler or web scraper, we might need the help of Node.js. So firstly, we will install and set the environment for Node.js. Followed by that, we will be needing an editor. So for that, we will be choosing the Cursor AI editor. And next, we will use an API. So for that, we will be using the Firecrawl API. And lastly, we can get started with building one once we have all the required resources. So let's get started. So as we discussed before, we will get started by installing Node.js into our operating system. So we're working on Windows operating system. So we might have to go ahead with Windows. So I'll choose Windows and the architecture will be the one which I'm working with. So that would be x64. But in case if you are working with a different operating system, say Mac OS, then you might have to select ARM or any suitable architecture that you can be compatible with. For Linux, you'll have to choose with the same and so on. So since we're working with Windows, so Windows it is and x64 architecture, and click on that Windows installer MSI file. So it will be getting started to install, and you'll have to click on that Windows installer.msi file and it'll get downloaded. While it is getting downloaded, let's go to the next web page and download and install the Cursor AI that we will be needing for this demonstration today. You'll have to log in, create an account and log in, and automatically it will give you the version that suits our operating system. Since we are in Windows, it gave me a Windows operating system. Just sign up or log in. So since you have already an account, just log into your account and confirm it's that you, and followed by that, you'll have installed your Cursor AI. Choose your theme. I'll go with the Cursor Dark theme. And here you make sure that you have Cursor tab, Control K agent, and you can also choose the data sharing option. I'll go with the privacy mode. In case if you want the other one, go ahead with that. And here you have a few review settings, and there you go. Now you're on the new window for Cursor AI. And meanwhile, let's check on the Node.js installation. I think the wizard has already started installing the Node.js setup. So this is the window. Let's quickly go through each and every instance that we have gone through so far in this particular window from the beginning. So it started off with some packages that we would be needing. So yeah, chocolatey and KB299. Yeah. Further we have, and the last one is Python 13, right? Version 3.13.3 is approved. So far, so good. I think we can now get started with the next step. So here we are on Cursor AI. So we might have to get started going through the Cursor AI settings to create our new MCP. So there are quite a few methods that you can try out to reach to settings. One is you can go to the file and there you may have to choose the preferences, and then you have the cursor settings. You just can use that particular step, or you can go ahead with the search options as well. So you can use that step, or you can also use the other step where you can just go to the search window and search for settings. Here you can see MCP on the left window. So let me also walk you through a few other steps. So go to the search window and type down cursor AI or cursor settings. I think there has been a discrepancy, but not to worry. We'll go with the regular approach where we go to the file, preferences, and cursor settings. And there you have the options on the left hand side. Go to MCP, and so far you don't have any MCP servers because this is the first time you've logged into Cursor AI. So you just have to add new global MCP server, which is available on the blue color button. Just click on that. And now you'll have a mcp.json file which is completely empty. You'll have to write down a few hard-coded codes here, which are not too complex related to the earlier ones that you have worked on in A10. So you might need a few more tools here. So go to the Firecrawl website. Before that, let's go through some awesome MCP servers GitHub link. So here we have almost all information related to the MCP. So let's open a new window and open all these links. What is MCP, clients, tutorials, community, legend, server implementations, framework, tips and tricks, right? For further information, you can go through all these web pages individually. So back to the home page, here you have everything you needed. The basic information of what exactly is MCP, and further you have some server implementations. Like if you scroll down, so you have awesome MCP services. This is where the beginning is. And next you have server implementations, aggregators, art and culture, coding execution, right? Customer data platforms. So here you have aggregators, art and culture, dedicated web spaces. So, and you have also cloud platforms that you can work along with. And moving further, you have code executions, coding agents, command lines as well, and communication related stuff. So you can go along and perform your operations, customer data or platforms, data platforms, and much more. Let's close all these windows and get started with the next stage where we need an API, right? So for that, the project that we're working on, which is web crawler, we will be needing an API from one of the providers, which is Firecrawl API. Okay, that's the one, Firecrawl MCP. So that's the one. Click on that particular link. Here, to generate an API, first you might have to sign up with Firecrawl. So before we sign up, let's go through the website of Firecrawl from the beginning. So that's the template code that you'll be working on. And also here we have a wide variety of crawl options, media parsing options, smart weight actions, right? Reliability first and all those things. And also we have the pricing details. For now, we'll go ahead with the free plan. And yeah, let me add down my details, my email address, and you might also have to add a password. So let me type down something. Yeah, so the password is not too strong enough. That's a good thing. They have a really strong website. So that's a sign you need to have strong passwords, and also make sure that you don't share your passwords and the API keys that you generate using Firecrawl. Now that my password is a little too longer, I think it should be access. Yeah, it's accessible and is a successful account generation. Now you need to check your email and confirm that login credentials are right and everything. So once you are signed up, Let's go through another website for generating our API keys. So Firecrawl API, scroll a little bit. So API documentation. So here you'll find some documentation related to Firecrawl and all the details that you need to go through for API key generation. So Firecrawl MCP server. Yeah, that's the website that we're looking for. Firecrawl MCP server. That's the one. And here you have overview, content, tools, and other resources that you're looking for. Now, this is the template server configuration that you'll be needing. So make sure that you have an eye on it. And now you will also have the details that you might have to go through. Like basically, it'll have the steps that you need to follow in the content page. Click on content. There you go. So it has all the features and details that you need to go ahead with. And tools, you have the crawling, extraction, scraping tools that you can work along with Firecrawl, and a few comments here. Now, yeah, the email has not been confirmed yet. Let's try to resend and reconfirm the email so that we just sign up or log in and create our API keys as soon as possible. So there you go. I have verified my email in my phone. So I'll just enter the credentials and sign in. Successful, you are signed in. On the left hand side, you can see the overview, playground, extract, activity logs, usage, API keys, and all the settings. So here you can see my API key has been by default hidden, so I'll not visualize it now. So you have two options, either view or copy. So we will be copying it for the first time to be on the safe side. So since we are new to this particular website, so we don't have any activities registered on this particular web page. So now we have the API keys. Now let's go to the content page to verify the steps that we need to follow. So we need to install npm and we need to go to the Cursor AI settings and add a new MCP server, which we already did. So we just need to copy the template code and we just need to place it there. And also, don't worry about where exactly to place your API keys in the template. We have that place. So we are back on the Cursor AI. Now we will replace this template code with the code that we just copied. And remember, if you're using Windows, try cmd/c. Okay. If you're not on Windows, you can eliminate that cmd/c. But if you are working in Windows, then you definitely need that cmd/c. Okay, let's erase this and replace that. So I'll name my tool as Firecrawl. And I'll go to the new line where I'll write down my command, and the command will be the code that I just copied from the Firecrawl window. So let me type down the command in double quotes in the new line, and I'll paste the command here, which is the code that we copied from the Firecrawl window. Control V. There you go. So the white stuff, which is in cmd/c, so that's the one you need to focus on. If you are working on Windows, that you definitely need it. If you're not working on Windows, then you can just omit it. Now, there might be some concerns with the codes, don't worry. Now, to cross-verify, you can just go back to the Firecrawl homepage and cross-verify it with the template for configuration that they have made us available. Let's go back to the Firecrawl window, and at the same time, you can see your API key here. So that's where you need to place your API key. So here we are on the Firecrawl window. You need to copy the API key and place it in the place where they have mentioned your API key. So if you have cross-verified with the configuration code, that's fine. And now you can just check the double quotes. So that's the one you need to focus on. Let me if there is a way to zoom it in, let me try to zoom in. Yeah, that's the one, cmd/c. If you're on Windows, you definitely need this. If you're not on Windows, you can just choose to omit it. Now let me just do one last final check. I think I missed a double quote somewhere. Yeah, I need to remove it from this place and add it to the end. Just a second. Okay, remove the double quote at that place. Now it should be after MCP. And once everything is done, you can just quickly choose to save and close this particular window. Check the distance between the API key and the double ampersand places. That's fine. And saving is really simple. Choose those three dots, close, save. And once that is clicked, it's all done. You get to choose to close this particular mcp.json file and get back to your agent. So once you have closed it, you will have your new server that you've just created in the cursor settings. But in a few times you get no tool connected, no server connected, or there might be some errors. So in that case, you just need to cross verify the npm installation, Node.js installation, and check all the files that are there or not. But even if everything is installed and you can see the versions available, and if you're still seeing this or watching that particular error, then don't worry, just close the cursor AI and restart it, or you can also choose the refresh option, which is right available there. So I've closed and restarted it, and the same procedure, go to File, Preferences, Cursor Settings, and there you'll see the MCP models, and there you'll find it right there, correct? Now close it and go to the window where you'll find the server. Yeah, that's the one. And here you choose the agent. Make sure that you choose the agent instead of anything else. Not manual, not ask. I choose the agent. And now I'll write down a simple prompt. Search for Simplilearn on Google. Now it should give me results which it finds on Google. Maybe it's a home page, maybe it's a social media handle like LinkedIn or YouTube or Instagram, anything that it finds related to Simplilearn. Only the term Simplilearn. So here you can see it has given me 3 different results. First one is Simplilearn website. Second one is Simplilearn YouTube channel, and the third one is LinkedIn page. So let's get started with the official web page. So click on the simplilearn.com. Now, it's asking me permission, open. Now we're on Simplilearn homepage. Similarly, let's go back and select for the YouTube page. So that's the one. Open again, get permissions. So you're on the Simplilearn YouTube page. Now I think it might ask for a login for LinkedIn. But anyways, let's try to check if it can open without logging in to LinkedIn or not. So yeah, you can see I've logged into the YouTube. Yeah, it is asking me to log in. So let's quickly log in. It might take a couple of seconds. So there you go. I've logged into LinkedIn. Now open. So I can see Simplilearn's homepage getting loaded in a second. Yeah, there you go. On LinkedIn, we have opened the Simplilearn's homepage successfully. Hey everyone, welcome to Simplilearn's YouTube channel. In this tutorial, we will learn about OpenAI's Gen AI agents. So generative AI agents are advanced AI-driven systems designed to autonomously perform tasks, generate content, and assist in decision-making by leveraging large language models, or also known as LLMs, and machine learning algorithms. Imagine an AI agent automating repetitive processes, enhancing productivity, and providing personalized recommendations across various domains, including customer support, marketing, and software development. By understanding context and generating human-like responses, they improve user engagement and streamline workflows. Businesses benefit from cost savings, faster problem solution, and improved efficiency. Such are a few out of many use cases of AI agents. Today, we will cover the OpenAI Gen AI agents and their facts, their challenges, and future implications. That's it. If these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Also, just that you know, if you want to upskill yourself, master generative AI and artificial intelligence skills and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various generative AI courses and certifications. Simplilearn offers various certification programs in collaboration with some of the world's leading universities like Purdue, IIT Guwahati, and many more. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Python, machine learning, generative AI, and over a dozen others. That's not all, you also get the opportunity to work on multiple projects and learn from industry experts working in top-tier data and product companies, and also academics from top universities. After completing these courses, thousands of learners have transitioned into an AI and machine learning role as a fresher or moved on to a higher paying job and profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a generative AI program that fits your experience and areas of interest. Now, without further delay, let's get started. OpenAI Gen AI agents. So, first, let's get started with the agenda for today's session. We will have a brief introduction to generative AI agents. Followed by that, we will understand the core components of Gen AI agents, then how generative AI agents work, architectures and deployment, enhancing AI agents with external tools, challenges and limitations of Gen AI agents, future trends and advancements in AI agents will be the last one. So I hope I made myself clear with the agenda. Now let's get started with the first part, which is Introduction to Generative AI Agents. So basically, what exactly do you mean by the term generative AI agents? So an AI agent is just an LLM that can take actions, and it can do so autonomously without any human supervision, and now also reason about the tasks. An AI agent is software entity that autonomously interact with environments, make decisions, and execute tasks. Generative AI agents extend by leveraging large language models like OpenAI GPT to generate intelligent responses and perform tasks beyond rule based automation. Now, we will also look into the evolution of AI agents. Traditional rule based AI agents had limited to predefined rules. Like if you define a process and give the steps, it will just perform them and complete it. It will not take a step beyond it. And machine learning based AI agents can learn from data but need structured inputs. And then comes the generative AI agents, which are capable of understanding, reasoning, and generating human like responses autonomously. Like they understand the environment and learn through it and take their steps based on the principle they have been trained for. And also, they will provide the reason for which they have taken a certain step. Now, moving ahead, why generative AI agents matter a lot. So there are three key points to consider. Firstly, efficiency. They automate repetitive tasks with minimal human intervention. Next is high scalability. They handle large volumes of work, example customer support, content generation, and many more. And finally, intelligence. They can adapt to different use cases dynamically. Nobody has to write rules for them. Now let's focus on OpenAI and its latest release of agents. So OpenAI just released two new groundbreaking agents, the Operator Agent and Deep Research Agent. These two releases are absolutely massive for all AI agent developers. So Operator is the first AI agent released by OpenAI, and what it does is it mimics human actions on your browser. So it means it can scroll, type, click, and navigate Google web pages for you just like any other human would. But more importantly, and what many people have missed out is this agent is actually based on a completely new model called CUA, which stands for Computer Using Agent. So, this agent, unlike standard GPT models, wasn't trained to just output text. You like write a prompt and expect an output in the text format. Instead of that, it can go beyond it. This agent was actually trained to output mouse and keyboard clicks, which is exactly what makes this agent so powerful in your browser. But not only that, it can also reason about every single action. This is also something that we haven't seen before. This agent doesn't just perform actions in your browser, it actually reasons about every single step and what it should do next. Just like we discussed before about the generic overview of generative AI agents, same as the OpenAI operator here. It takes the step based on the environment, and also it will give you a particular reason for which or based on which it took a certain action, and it will also asks you what to do next. Let's say if you want to book a ticket, it'll navigate to all the websites. It can go through some better flight options for you. Let's say the low cost ones, the low hours of flight ones, and best timings, and then finally selects the best one for you based on your recommendations and asks you if it should proceed with booking or not. So that's how it works. Now, of course, there are some limitations as well. The first limitation is it has still a lower bit of accuracy. It's really high compared to other projects that we have seen in the past where people just prompt GPT models to perform actions in the browser that can browse web using GPT-4o vision capabilities, but it often struggles with other models. So whenever there was a model on a web page, like some other random model available working readily on a web page, it would just accidentally pop up and it would not be able to do anything because it would just get confused. It would not be able to close it, and then basically you would have to get involved yourself and close this model manually. And the second limitation is high cost. Right now, this particular operator agent is only available on $200 plus plan. So we can probably guess it's going to be pretty expensive in the API. Also, I do think that if you are focusing on the right thing, then costs are not going to be an issue. Now, let's talk about the second agent that OpenAI deployed. Now, the second agent which was deployed by OpenAI is called as Deep Research. So, this second agent released by OpenAI was trained to perform comprehensive research. It can search the web, it can pull up the necessary resources, and then it can compile all that information into a really comprehensive document or maybe a report as well. The groundbreaking thing about this agent is it's powered by the new O3 model. So again, similar to the operator agent, but it doesn't just search the web and provide you with the results. It actually reasons about every single source and then it thinks about what other information it needs to find out next, and it's really incredibly powerful. Deep research doesn't just output the most average thing on the internet just like some other standard GPT models. It would compile novel insights. Now, let's move on to the real world applications. There are a wide variety of real world applications. First one is customer support AI agents, which helps you in automating help desk responses. Next, powerful AI assistants like copilots for professionals. Third one is research and analysis agents for data summarization, literature reviews, and many more. Fourth one is creative writing and content generation, automating social media posts, emails, etc. And lastly, AI-driven code assistants like GitHub Copilot, OpenAI Codex, and many more. Now, let's go through the next part, which is core components of these generative AI agents. Let's begin with the foundation models. So the foundation models are GPT-4, Dolly, and Whisper. GPT-4 for natural language processing, Dolly for image generation, and Whisper for speech to text conversion. The next one would be prompt engineering and context handling. So here, designing effective prompts for AI agents to generate relevant responses using few shot and zero shot learning for adaptability, and lastly, implementing context-aware AI agents that remember past interactions from the user. Now, next would be the memory and long-term context storage. AI agents typically process short-term prompts, but memory-based approaches, for example, LangChain's memory module, enable long-term reasoning as well. Now, storing and retrieving user-specific data for personal responses is also one of the priority. Next will be the tool use and API integrations. Using external API to fetch real-time data, for example, weather, stock prices, news, etc., and integrating databases for structured information retrieval. And proceeding further, we have autonomous decision making. AI agents evaluate multiple options before making a decision. Planning and reasoning techniques to enhance responses is a priority for them. Proceeding ahead, we will discuss how generative AI agents work. Starting with the first step, input processing and context awareness. AI agents analyze user input, detect intent, and extract entities. For example, in a travel booking AI agent, it identifies destination, date, and budget from user queries. Just like the example we discussed before, right? You provide the point A and point B, the best time for you to fly, and the best number of hours that you focus on flying, and lastly, the destination, right? All these things will be evaluated in real time. The cost, the number of hours, the flight, the options provided, the amenities provided on the flight, and all those things, and also budget as well. And based on that, they take a decision. Now proceeding ahead, generating intelligent responses. So here, RAG, or also known as Retrieval Augmented Generation. AI searches external databases for responding. Next, we have chain of thoughts reasoning, or also known as COT reasoning, and AI breaks down problems into fine steps. And last step is fine-tuning the models, custom trained AI for specific industries. For example, if you're preparing an AI agent for a dedicated sector like healthcare, legal, customer support, based on that, you will fine-tune your AI agent or model. Now, next is decision trees and multi-step reasoning. AI can simulate a thought process, breaking down complex questions into manageable steps. For example, whenever you open DeepSeek or whenever you open OpenAI ChatGPT for the most premium version, you will write a prompt and there will be an option called Think, right? If you just click on that, it will explain you the thought process it is going through and how is it planning on giving a reason for you, right? And followed by that, we have handling uncertainty and error correction. AI self-corrects through confidence scoring and human feedback loops. Last step in this particular stage is fine-tuning and reinforcement learning, or also known as RLHF. Human in the loop training to improve responses, and AI learns from real world interactions and adapts over time. So it's basically called overtime learning, where it adapts to the real world environment and learns things and provides the best feasible solution. Now, the next stage is architecture and deployment of AI agents. So, in the first one, we have standalone versus multi agent systems. So, firstly, the standalone AI agents. They perform tasks independently. For example, ChatGPT. Multi-agent systems, on the other hand, work together to achieve complex tasks. For example, one agent for summarization, another for execution. Now, next in this particular stage is agent orchestrator model. A central AI agent coordinates multiple AI sub-agents. For example, in an AI-powered research assistant, one agent gathers all the data that is required, the second agent summarizes all the information collected, and the third agent formats the output. Followed by that, we have cloud-based AI agents and edge-based AI agents. Cloud-based AI agents compute, for example, OpenAI API, Azure AI, and edge-based AI agents run on local devices for faster processing. For example, Tesla's AI in self-driving cars. Followed by that, we have using APIs to build AI agents. OpenAI's API for GPT-4 powered by AI agents, LangChain framework for AI agent orchestration, and Llama Index for document-based AI agents. The next stage, we will discuss about enhancing AI agents with external tools. In that, the first step is integrating with databases. AI agents can query SQL and non-SQL query databases for structured data retrieval. Proceeding ahead, we have connecting with web scrapers and APIs. AI agents can fetch real-time data using tools like Beautiful Soup, Scrappy, and OpenAI plugins. Next ahead, using vector databases for context recall. FAISS ChromaDB store long-term memory for AI agents. For example, legal AI agents retrieve case law from vector embeddings. Lastly, we have autonomous agents and workflows. AutoGPT and Baby AGI are best examples. These AI agents that self-improve by learning from previous tasks, and True AI, which is a set of multiple AI agents collaborating to solve a complex problem. Now, the main part, challenges and limitations of generative AI agents. In that, the first one will be the ethical considerations. AI bias and fairness concerns are the primary ones. Addressing AI hallucinations, which is false information generation, and then we have computational cost and efficiency, which is a major concern amongst all the industries. Large AI models require significant computational power. Strategies to optimize AI agent efficiency will also considered to be expensive to hire many training models or also human programmers. Followed by that, we have security risks and data privacy. Risk of data leaks or data breaches and AI jailbreaking is one of the highest security threat. Implementing secure AI architecture is one of the primary solutions that you need to focus on. And lastly, we have legal and compliance issues. This would majorly be concerned from the enterprise level. GDPR, HIPAA, and AI regulations compliance is mandatory, and AI liability in decision making is also important. And now, the last stage of today's discussion, which is future trends and advancements in AI agents. Starting with the first one, AI agents with emotional intelligence are also known as affective AI. AI is capable of detecting emotions and adapting responses accordingly. For example, if you have designed a therapeutic AI chatbot for mental health. Now, the next one, self-improving AI systems. So meta learning and auto ML are a few examples. AI agents that learn from new data autonomously, for example, AI adjusting marketing campaigns based on customer responses. And now the next one, AGI and roadmap to superintelligence. Well, this always ends up with question. Will AI agents evolve into AGI, or also known as artificial general intelligence? And are the implications of self-learning AI real? This is the major question. And lastly, the role of AI agents in the future of work. Now we can see there are a lot of AI agents like Copilot which will assist humans in their day-to-day tasks, whether it is business, healthcare, or education. And also, you have a lot of automation and transformation happening in the IT industry, which will reduce the work hours and stress on the employees by automating all those mundane tasks by the help of Copilots, also the generative AI agents. LLM chatbots are powered by large language models like GPT, Gemini, and these are intelligent virtual agents capable of understanding and generating human-like responses. These AI-driven assistants can streamline a wide range of tasks like answering questions, summarizing data, generating content, automating workflows, and even writing code. These make them indispensable in today's digital landscape. Building your own LLM chatbot can boost your productivity and innovation. In this hands-on tutorial, we'll guide you step by step through the entire process. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Also, for your information, if you want to upskill yourself, master generative AI and artificial intelligence skills and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various generative AI courses and certifications. Simplilearn offers various certification programs in collaboration with some of the world's leading universities. Through our courses, you will gain knowledge and work-ready expertise in skills like advanced Python, machine learning, generative AI, and over a dozen others. That's not all. You also get the chance to work on multiple projects and learn from industry experts working in top-tier data and product companies, and also academics from top universities. After completing these courses, thousands of learners have transitioned into an AI and machine learning role as a fresher or moved on to a higher-paying job and profile. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box below to find a generative AI program that fits your experience and areas of interest. Now, without further delay, let's go through the agenda for today's session. We will get started by a brief introduction to LLMs and chatbots. Later, we will dive into setting up the development environment. Then, we will understand data collection and preparation. Followed by that, we will understand the implementation of LLMs. Later, we will check into chunking and embedding for vector search or RAG. Followed by that, we will learn implementing query processing and recommendations. Next, we have zero-shot text classification, and lastly, the sentiment analysis with LLMs. Hope I made myself clear with the agenda. Now handing over the session to our experts.
Hi, welcome all. Welcome to Simplilearn session on how to create LLM chatbot. In this course, we are going to talk about what is LLM, what are chatbots. We'll try to see how do we start developing a chatbot using large language models, where we'll try to understand how do we set up the environment. Then we talk about how do we collect and prepare the data for LLMs to understand. Then how do we implement LLMs, chunk and embedding vectors that is required for retrieval augmentation. So that is embeddings of the data chunks. I will talk about those things. We'll further talk about how do we implement query processing and recommendation systems. We'll give an understanding on prompt engineering of zero-shot text classification, which is a type of prompt engineering. And we talk about finally with the sentiment analysis with LLMs. So we can create multiple types of LLMs and we can create sentiment analysis LLM. At the end of the session, we'll try to develop or go through with a piece of code using LangChain to create a chat model using OpenAI APIs, and we will work on that and try to put that into production environment using Streamlit. That would be the agenda for the day. So, how do we create LLM chatbots? And we'll start with what is an LLM. LLMs are nothing but large language models which are trained on very huge amount of text, and they have the capability of generating human-like text. So they are slightly enhanced version of the natural language processing tools that we have seen before in the deep neural network architectures, wherein those architectures using LSTM models or GRU models or similar models with respect to or the RNN models, these models were able to understand the text and give an understanding of those texts, that what exactly is the inherent meaning about those text messages. However, the large language models are a step ahead of the previous versions, and they are able to not only understand the text, but they are able to generate the text based upon the information given to them. So that is what we call as a large language models. These are primarily trained on a very huge amount of data. They do not have any kind of predefined resources. They are trained on a very humongous amount of data. Now, how it works? If I talk about how LLM works, LLM typically takes up the huge amount of text and breaks it down into the pieces. We call them as the tokens. Now, what is the tokens? As a very small level, a very basic level, I can say that tokens are nothing but the words. At a very broader perspective, you can understand tokens as words. So words in any context, in any paragraph, let's say you have 10 words or 20 words or 1000, each word can be considered as one token. At times, we can also consider an entire sentence as a word, as a token. So that is dependent upon which kind of modeling technique being used. We are using sentence tokens or we are using word tokens. But yes, at a very basic level, at a very grassroots level, you can think of tokens as simple words which are lemmatized or stemmed. So stemmed or words. Stemming and lemmatization are the basic concepts which are coming from the natural language processing part, where we try to cut down the words to a basic root level, grassroots level words. So that is the idea behind stemming, so that we get similar words for every problem. So just for an example, you can think of a simple example. If I write down few words for you, I can write down a word break. So we were talking about how LLM works. So in general terms, if we talk about how LLM works, LLM will be trying to process my entire text data and create tokens out of it. So out of those tokens, the tokens can be considered as single words or sentences at times, depending upon the mechanism that is being used. But you can, at a very broader level, we can consider tokens as the piece of words which are at a root level words. For example, breaking will become break, or into will remain into, or breaks will also become break. So depending which are the root words which generates other words, we'll try to contextualize all words into a single entity which are of similar nature. The word transformer might become a transform, architectures might become just an architect. So depending upon different kind of words, we might have some basic root words that will come to the picture. That is what we call as a tokenization, stemming, and natural language processing. So that's what we're trying to do. After tokenization, we get smaller words, as I've mentioned, U words or subwords, and we try to convert them into a vector representation, and we call them as numerical representation of those words. Let's say every single word in my entire word dictionary, I will give them a particular number. Let's say A is at number 1, B is at 2, lamb is at 3, so on and so forth. So each particular word out of my entire contextual words will have a number associated with them. I'm giving a random example. And with that, we can assume that those numbers I can represent in different form, maybe in hex code form or in a binary coded form or some other form. I can represent them, and we can use that numerical representation of each word in order to understand those words in numerical form, because it would be the numerical representation of the data that will help in making things clearer and understandable, right? After this, LLMs, once we got the relevant tokens, then it uses the attention mechanism. Now, what is an attention mechanism? There's a famous research paper on this, which is Attention is All You Need, published in 2017 from Google Brain team. That paper talks about a self-attention mechanism, which is the primary source of all transformer models. LLMs also use transformer modeling approach. So that is where it contains of a self-attention layer and masked multi-attention layers. So that's the basic underlying principle behind all the LLMs. So we have an encoder block and we have a decoder block, and we work on those two blocks together in order to understand what is the input being given and what could be the potential text that could be generated for the given input. That is what attention mechanism allows us to do. We can discuss the self-attention mechanism in detail in another separate video. That's what transformer talks about. So these are very different deep learning architectures which actually does not use a neuron kind of thing. If you have studied about deep learning architectures, you would have seen that every deep learning architecture at the hidden level has certain neurons at the center, which takes the input and processes it and gives the output. In LLMs, we use a self-attention mechanism module where we replace those neurons by self-attention blocks. The self-attention blocks has two important portions. One is an encoder, other one is a decoder. And again, certain LLMs may be just coder module, certain LLMs might be just a decoder module, certain would be a combination of both. All the generative ones are the models that are combination of both encoding and decoding part. If I talk about types of chatbots, the chatbots is another example of using large language model. What does chatbot do for us? We ask a question, we put up a prompt, we put up a query in front of a machine, and then machine is able to respond back based upon the query being put up. And there can be two classifications of the chatbot based upon these two versions. The first is a rule-based chatbot, and the second one is AI-based chatbot. What are the rule-based chatbots? So rule-based chatbots are those where they have a defined set of rules and pre-written scripts for a particular question. Let's say, how are you? So if I have mentioned already or defined, if someone asks you, how are you? It will give me a particular answer. If that question is not into the vocabulary, it will say that, sorry, I'm not able to answer that question. I'm not trained onto that part. So those are called as rule-based chatbot or rule-based LLMs. Typically, these kind of rule-based LLMs use decision algorithms or random forest or based algorithms in order to understand and create rules and then give the answers. Typically, that's the underlying logic that goes behind the rule-based chatbots. Typically, not into practice too much these days. We have AI-powered chatbots which are much more responsive and much more better. So we'll use in this class as well. We will work on AI-based chatbots. The rule-based chatbots, which are very simple to implement and very easy to put up through. They will not be able to handle very complex wordings because you will not be able to give sufficient amount of examples. Right? Then you have AI-based chatbots. You can put up any kind of queries. I'm pretty much sure most of us would have used AI-based chatbots like ChatGPT or Anthropic, right, or Gemini. You would have used, some of you might have used those, some common names that I've taken up. So all these are AI-based chatbots, right? Depending upon my requirement, what requirement that we have, what kind of chatbot should I use is very much important because I need to look at many factors like how much customization is required, what is the cost involved, how do I'm on a deployment, what is my deployment requirements, how much open source do I want it make it to be the open source availability for this. Last and most important factor is how much is a private data. That means a data which is not available publicly for OpenAI models or open source models to learn from. So do I want to include that data or not? That is also an important factor. If I have to include the data, the type of AI-based chatbots will also vary because there will be two types of AI-based chatbot. One that we use with the pre-trained models, which will work in this class, and the other one that uses pre-trained models. Along with that, it also takes up a chunk of data, or it can also get trained from some other data as well. That is what we call as RAG approach, retrieval augmented approach. All right. So this is what we have seen so far. Now, setting up the development environment. In order to create a development environment, we can choose many things. There are multiple APIs which are available, but in this particular section, we will use OpenAI API. It is easily and freely available. Right. So we require a coding environment. I'm going to use Jupyter Lab for it. Some institutional libraries. To name few of them, I'm going to use Streamlit. We are going to use LangChain. What else? That would be more than sufficient. NumPy and Matplotlib would also be required. That's it. So these will be few libraries. Whether I want to do a cloud-based deployment or on-premises deployment depends. That dependency needs to be understood because cloud-based deployments would require a little more resources. We need to ensure about the correct API access. The API access that I'm going to use is my own personal OpenAI access. So I would mention OpenAI key at the place of the code where it is required to put up the OpenAI key. All right. Thank you. We'll require understanding of basic Python understanding. How do we write Python scripts? How do we integrate APIs with the Python scripts? Two important things. We'll use Jupyter Notebook in this case and VS Code, or either you can use any technology because we are going to write down a .py file. So whatever you're comfortable with, Jupyter Notebook, VS Code, or just Python working environment, I'm okay with that Python editor. So API access can be requested from OpenAI, Cohere, or Hugging Face. I'm going to use OpenAI in this class. So I'll show you how to gain OpenAI access. You can go to platform.openai.com, register yourself, and you can generate your OpenAI API key. Right. So transformers, I can use LangChain, which will require me to develop the chatbot logic, and that's what we're going to do. We can use Llama Index for data retrieval, or you can use Fast API, Grad.io. That can apply. Fast API and Grad.io will allow me to put the deployment part, but we're not going to use that. You can use cloud-based services like AWS, Azure, or Cloud. We're not going to cover that too as well because it's not within the scope. So data collection and preparation part. So we need to collect the data in the form of either CSV, JSON, or web scraping data. Go to NumPy, Pandas, create the data, and refine the data. But in this particular section, we are not going to deal with NLTK or Spacy library. We are not going to train the model as of now. We're going to use pre-trained models from OpenAI API. So how do we create LLM chatbots? So that will be little practical parts that we'll try to understand how we can create LLM chatbots. What we require is few understanding. If I'm going to train up a model, for example, I'm going to train up an LLM model, we need a model architecture which can be implemented, which can be downloaded from transfer learning methodologies. You can get all those models either from Hugging Face or directly from Transformers library or directly from TensorFlow or PyTorch, whichever way you're trying to implement. We can get it then from there. Apart from that, what kind of model is required? That is also an important thing. Because if I'm doing a sentiment analysis, I'll require a sentiment analysis. If I'm looking at a question answering approach, I would require a question and answering approach. If I'm requiring general question answers, generic models, I can use generic model like ChatGPT. So depending upon my requirement, I would have to choose the correct model and correct APIs accordingly. That is the first important task that we need to, right? That's we have talked about. If I'm trying to use different LLMs, I require different kind of things. For general versatility, GPT is good. Open source customization, Llamas are good. Mistral for efficiency, Falcon for scalability. So right model will depend on many factors like performance, cost, and deployment needs. We can get right models, whatever models that you want from Hugging Face or API-based models. API-based models would include like I have OpenAPI access, and on OpenAPI we have the ChatGPT's 4.0 mini version, which is available for access with me. So I'll use that. Now, how to create an LLM chatbot? For this, we need to understand what is retrieval augmented generation. So what is that? Retrieval augmented generation. Suppose I'm trying to do a search. For example, I typed in a query. What is the role of Python? Just a simple word. What is the role of Python? In this scenario, it will try to find out of my entire context that I've given, what is the role of Python. It will try to find out what are the most relevant words with respect to the question being asked, the meaning that it has, and based upon that, it creates a architecture of most important keywords, and that keyword is called as RAG, or retrieval augmented generation. So after that, it finds out what are the most important keywords, and based upon that, it performs the extensive search through the data that it has and finds out the correct responses, matching keywords from different resources. Then from all different resources, it will learn everything and then come back with my solution. So that is what it is going to do for us. What it allows us to do is the RAG approaches. my model or my LLM is not going to give me random vague answers. It's not going to create or generate answers without any context. We'll always try to find out some semantic information and give good contextual answers. Same thing happens with the chunking and embedding in vector search. It tries to break down the entire text into smaller manageable pieces. We call them tokens. Again, converted to numbers are called as vectors. Again, it can be done through many other libraries, like chunking and embedding can be done by LangChain's character text splitter. We can do through NLTK, or we can do it from TikToken. TikToken is not to be misunderstood with TikTok. It's a different entity altogether. Token is a library that allows us to tokenize my text. Then we have transformers, like sentence transformers available, which allows me to create the vectors. Vectors means again numerical representation of my text. Then we store that in the database. Any simple database can work for us. Then we look for the similarity scores, like cosine similarity, Euclidean similarity scores, or product similarity scores, to find out what kind of matching architectures. As I've told you, RAG uses this approach, finds out similar context words. So from there, it will try to get me those similarity words and find out similar contextual information. Then we talk about the implementation of query processing and recommendation. In query processing, the idea again changes nothing but you ask a question, LLM works around with that, again breaks it down into a text form. From text, it converts vectors. And since it's a question, so it becomes a question answer kind of approach. So it will find out 10 answers and try to filter out the best suitable answer for any query that is being done. Now, what is zero-shot text classification? In a zero-shot text classification, I do not train my model explicitly, right? So what that is zero-shot classification, where I'm not putting up any additional resource. What is that meaning is, I have a pre-trained model like GPT that is being trained on very generic knowledge that may not be very specific about the context that I'm asking. Say, for example, I have ChatGPT, which is trained on almost everything in the world, but it might not be trained on my organization's specific issues. But I can still ask this question about my organization. It may not be able to give me a very specific answer, but it will be able to give me a generic answer. That is what we call a zero-shot text classification, where I'm not training a LLM on a specific data. Rather, I'm just creating an LLM from a pre-trained model and asking it for new data installation, right? How can you find out some classification models? There are lots and lots of available. I can just show you very quickly. Pre-trained classification model, you can go on to huggingface.co. That would be a place you can find a lot of pre-trained classification models available. You can find out models based upon your requirement. You can go to the models and you can click for the task, whatever task that you're looking. Let's say I'm trying to do some text natural language processing. That's a zero-shot classification. I have many models here. But just for zero-shot classification, these are the models available. I have BART large MNLI from Facebook. That's one of the zero-shot classification model. You can look at that. Go to files and versions. This is the entire model. You can see that you can read out this readme.md file and find out the information about it. So there are a lot of models which are available, which you can use. Again, it's a GitHub, so you can clone this entire part and you can clone it from directly from Hugging Face, clone the repository and use it locally. Okay. So any model can be used. So BART large mini MNLI, that's one classification model that can be used out. There can be a lot of things that can be done in zero-shot classification. Apart from that, you can create transformer pipelines, wherein I'm trying to do one transformation followed by another one, and so on. So that can be created up. We can use a scikit-learn matrix like precision, recall, or F1 scores to find out we have correct classification. We can implement those too. Finally, we'll talk about the sentiment analysis with LLMs. LLMs can also be very much useful in doing the sentiment analysis part. So in sentiment analysis, we try to look at how we can determine the emotional tone of any text, allowing or enabling chatbots to understand the user sentiment. So we try to train the chatbots on emotional content, on data which contains emotional aspects. We can define it whether it's a positive or emotion or a negative emotion or sad emotion or a happy emotion. We can train the LLMs on that, and based upon that training, my LLMs would be able to tell me whether any particular emotions being reflected is what kind of emotion it is. It may not be able to mimic that emotion, but it will be able to tell me what emotion has been reflected in the context. It can be with the audio, it can be with the video, or it can be text as well. That is the sentiment analysis. Again, DistilBERT is one of the very good classification model for sentiment analysis. That is what we can use. Sentiment analyzer is available with many other sentiment analyzer is available with DistilBERT, Robert, Llama. Everywhere we have a sentiment analyzer available. It's one of the class in a pre-trained model which is available to analyze the sentiments. So this is what we will talk about through the entire understanding of your LLMs theoretically. Let's try to practically look at how do we implement that. So I will open up. Let me open up my Anaconda Navigator. So I'm going to open up Anaconda Navigator here. I have a pre-written script. I'll walk you through that and I'll explain you each line what it is doing. Hopefully that helps. So here it is. I have just got my Anaconda Navigator opened up. I'm going to open up my Jupyter Lab environment from here. Wait for that to open up. Should be up and running in a moment from now. So once that opens up, we will be able to start doing the coding part of creating a chat GPT kind of approach, where that would be in the implementation of chat GPT through chat GPT open API that we can use at our own local servers or at our own particular end. Essentially, that is a replica of chat GPT that you can put up. Okay, I already have this piece of code written down for you. So what are we going to do here? So I'll put down certain piece of codes here. This file will be made available in the description too, or you can copy it from here. Okay. So what is each of these things that we're going to do? So I have named that as I have created a Python script here. For that, I've gone to File, New, and I've used a Python file. I went to that option and I create a Python file. First line I wrote down is import Streamline LST. So this will allow, I'll put up certain libraries to be done. Libraries. Import. Prior to that, you might be wondering if I don't have those libraries. So you need to install these. I'm putting that as a comment, pip install. Or if you're using an environment, you need to put that into your environment. So I'll put up that pip install. You need to put up LangChain. I'm using LangChain here. Space. You would require Streamlit, OpenAI. That should be good. And just these two will be good enough. Okay, you need to install these two libraries, LangChain and Streamlit. What I'm using Streamlit for? It's LangChain. I'm just putting these notes. LangChain supports or LangChain for the purpose of building chatbot logic. Okay. And Streamlit for designing UI. So I'm not going to give too much into designing part. I will take a simple UI as of now. Idea is not to do the designing part, designing the user interface. Okay, so a web-based user interface, I'll say that designing a web-based user interface. A separate session on Streamlit can be taken up to design all that part. So Streamlit is a separate library altogether. So we will import Streamlit as ST. That allows me to import Streamlit from LangChain.chat models. Now this submodule allows me to open or connect or call up the keys or open API keys from the OpenAI servers. Okay. So that is a class that is available, Chat OpenAI, that will allow me to create or contain my OpenAI tools. Then another thing that I need to put up LangChain.chains. Now, conversation. Now, what does that do? It allows me to create a chain of conversations. That means, suppose if I ask one question, there's an answer given. Then I can ask up a probing question further. So that allows me to remember the previous past as well in context with the current conversation. It allows me to create a conversation chain rather than one question, one answer and stops. Instead of that, allows me to repeat things on a simultaneous basis. LangChain.memory, that allows me to remember the buffer memory. It allows me to remember my previous conversation. Suppose I have started with one conversation and then I want to continue with another conversation. So my previous conversation can be saved and used. It can be reloaded. OS I'm using for very generic purpose to create environment variables. If you want to create environment variables, otherwise it's your choice. If you can avoid OS as well if you're not using environment variables. So first thing is to set up your OpenAI API key securely. So for that, I'm creating a variable OpenAI API key and I'm putting that into my Streamlit secrets. Now, where are these Streamlit secrets? So these are typically stored in a TOML file. I'll just show that. So that will be in your default folder where your Anaconda is installed. You will have a .streamlit folder. You need to go into that and install will be in default user account. Inside that, you will find a under Streamlit folder. You can find there is a file by the name secrets.toml. If it is there, you can put it up. If it is not there, you need to create a new text document like this. Inside this, I've just opened it up. You need to write down anything. I have used the word OpenAI underscore API underscore key is equal to, and you need to mention within quotes your API key, whatever you are using. Put it up here and save this document. Save as. And you go to this place, select all files and save this document as secrets.toml. So that allows you to take your key into or transmit it into your network or transmit it to your model with encryption. So that can be saved up. So you can just need to save that file. I have already done that, secrets.toml. This file contains my API key, right? I already have that file here. So that allows me to tell it, Streamlit, go to the secrets and find Open API key. If it is available in Open Secrets, if it is available in there, else you can get it from the environment variable. Or else otherwise you can create up here os.environment. Those who do not want to use that, you can put up os.environ and create up the same variable by the name open. This is an optional thing. So open underscore API underscore key, and you can mention is equal to quotes your API key, whatever you want to use, your OpenAI API key. That should work. So I'll put a comment. This is an optional thing, right? We'll get this thing work. I have put this again in statement. This is for the purpose of else os.get environment open API key. So if we do not have a key available in secrets, it will try to fetch it from the environment. All right. Now we need to initialize our LLM model. How do we initialize my LLM model? My LLM is equal to chat OpenAI. That's the name of the function that will connect me to OpenAI servers. OpenAI.API key is equal to OpenAI.API key. I have kept my API key. If you do not have anything else available, just write down your OpenAI key directly here. You don't have to create anything at all. Right? You can paste it up directly here as well. That will expose your OpenAI key and you may not want to expose that securely. Then the temperature, it's the amount of randomness that we want. Now what does that mean? It means how much randomly generic answers I want to create, the temperature part. Higher the number, more is the randomness I'm trying to bring into my answers. The bigger the temperature value is, the better your answers would be. Lastly, the model name. Based upon your access to OpenAI API, you would be able to access either some of the models. I am able to access GPT-4 or mini model. I have mentioned that model. If you're able to access GPT-4, you can just mention GPT-4 or whichever model you have an access, or 3.5 turbo, depending upon your access. You can use that particular model. After we have initialized the LLM part, we will move on to the next part where I'll set up the memory part. Now, what is that memory part? In this, on my Streamlit platform, I just wanted to make sure if there is any previous memory available, it should be able to bring that memory for me. If it is not available, I'll start my conversation from a new piece. So I've created a variable memory if memory not in session state, right? st.session state. A session state is a variable that creates my value, and I'm looking for memory part. If there would be any memory, this flag will be true, whether it will be false. So if memory not in session state, if it is not present, I want to create a memory that I can assign a memory value to it using conversation buffer memory. So whatever memory that we have, I'll start with that memory. So that will be blank at the moment. Okay, I'll start my conversation now. This function conversation chain, it actually allows me to create the chain of conversation. The model that I'm going to use is LLM model. The memory is the current memory state, that is blank, currently blank. So as soon as we keep on moving, the memory states gets on updated. Verbose will try to make sure that if there is any kind of warnings or something in between, these are not being displayed. So the verbose false, that ensures that part. So we do not see any warnings or anything. Apart from that, now we need to design the interface. That's the model LLM model part done. We will design our interface. st.setPageConfig. So whatever the web browser page that I'm going to design, I want to put the title as LLM Chatbot. Page icon, if you want to put something, let's say put up anything. You can put up a GIF image or whatsoever you want. If I can have, okay, you can leave it. I'm writing down one Simplilearn. I do not have that small images right now. So you can put a page icon like this. Then title. Now this title will appear up in the center of your page, right on the first page on your screen. The LangChain Chatbot by Simplilearn. Okay. So that will appear up in there. Now we will now use the same place that will create my interface. That means I'll get a web page whose title will be LLM Chatbot. Page icon will look like Simplilearn's name written onto that. Title would be LangChain Chatbot by Simplilearn. That will appear up somewhere in the center of my screen. Then I'll put up a blank box to receive user input. So user input is equal to, the name of the function is st text input. St is my Streamlit library. In text input, I'm asking this part to display. Asking you to display the word u followed by key is equal to input. So it will display up a box and the key input will be displayed up within the box. So you get to know that here I have to put in the input value. Then, if I get a user input, my response is conversation, which is my conversation chain model that we have created here. Conversation.predict the user input. So based upon the input that I gave, it will create up a response. Once it gets the response, I will add to the memory, to the chat memory. So session state memory dot chat memory dot add user message, predefined function. So I'll put up user input and add AI message as response. I have added two functions there, and then I'm writing up the response. So I'm putting up now on my screen st.write is going to put my response. So I'm writing down a formatted string with a markdown language of bot that will appear in bold and the response. So what are the response from LLM model that has came up, that will be printed up here. At the last, I'm putting up, this is an optional thing, completely optional, wherein I'm trying to tell you, if you want to see the previous histories, you can put that up by doing this. How? So there is a checkbox I'm creating. If st.checkbox show chat history, that will be displayed in front of it. There will be checkbox. So if I select it, this becomes true. If I do not select it, that remains false. For message in st state memory, chat memory messages, I will try to see. See, I have added user messages and AI messages. So that is available in my session state memory, chat memory, right? So I'll go to session state memory, chat memory, and I want to recollect all messages. So I'll retrieve all messages from there, and I'll put up what the role this particular u, if message dot type is human, else bot, and I'll put down the entire content. So that's what will be printed out on my screen. That completes your entire LLM creation part. Let's try to work around this. Now for this, you need to save this file as chatbot.py. Once you have done this, open up your terminal. I'll open up a terminal that is nothing but my Windows terminal, PowerShell terminal, and I'll run this command by putting up streamlit space run space name of my Python script. So it's chatbot.py. That is my Python script. When I execute this, I press enter key on my keyboard and say that you can now see your Streamlit app. I'll just show you this. You can now view your Streamlit app. It's starting up the app on the back end, but I'll just show you here on your browser. So that has already opened up an app on my browser. I'll show you that. But it says that local URL HTTP localhost 8505 and my network URL is this. So it has got me an IP address URL as well. I can use either one of those. But if I go to my web browser and see, it says that my window title of, I'll show you. You see that LLM Chatbot here. That's my title on the top. Put up. I had an emoji to come up, but that did not come up, alas. But you can see here, LangChain Chatbot by Simplilearn. That's what I put up here. That's the name, and it has a context box of you, and I have a box to write down. I have a show chat history option. Let's try to search. What is, or let's say today's news, I'll win Champions League 2025. Now that's a very generic question. I'm pressing enter to apply. If everything is good, my API is running, I would get an answer. It says, I cannot predict the future, so I don't know who will win the Champions League 2025. The tournament is filled with so many talented teams and anything can happen in football. So you can ask me any question, you can put up any questions. If you don't like, you can put up a new question here. Tell me the names depending upon how much availability of all participating. So depending upon your prompt, you can create up. So it tells me does not know the top teams from various European leagues, including Premier League, La Liga, Serie A, Bundesliga, and League One, along with some lesser known leagues compete for a spot. So we can see some team names that can be there. Essentially, you can also see below, so show chart history. If I put that on, you can look at all the things that has been done in this particular. You can see my chart history is available. So that can be viewed. I removed that show chart history. This chart history will be pardon now. Again, depending upon the machine that you're using, it is running on my local server. So depending upon hardware, it might be slow or fast. That is how you can do it. The next option that we can do is to deploy this. In order to deploy this, you need to go on to deploy option. You have multiple choices available. Like you can go Streamlit Community Cloud, you can go Snowflake, or you can deploy on your custom platforms. If I want to go on Community Cloud, I can click on deploy now. I need to access to my GitHub account. I need to put this code onto GitHub and then I can deploy. That can be discussed in a separate session altogether. So that would be it, everyone. And I would really like you to think of questions and answers. If you have something, put them up into your comment section and we'll definitely respond back. Thank you very much.
Are you feeling like every other video, article, or tweet you see these days is about generative AI? You're not wrong. It's the tech world's current obsession. But instead of just nodding along, wondering what it all means, what if we could actually master it? In this video, we are cutting through the hype, giving you a practical step you need to truly understand. I will be breaking down the entire journey into manageable phases from fundamental knowledge to building your own Gen AI projects. Before we begin, let me tell you what generative AI or Gen AI means. As the name suggests, it is generating data. It's a technology where it uses existing data for creating new ones. It might be in the form of text, images, audio, video, code, or even 3D models. For better understanding, I will be dividing the entire roadmap into 4 phases plus one additional phase as a bonus phase for you to excel in this field. Phase 1 is all about laying the foundation, which includes the basics of AI and machine learning. Think of artificial intelligence as making computers smart enough to do things which people can do. Machine learning is just one of the way to do it, allowing computers to learn from example instead of being told exactly what to do. It's a learning by seeing and doing it, not just by a rule book. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is where the computers learn with correct answers, whereas unsupervised learning involves finding patterns on its own, and reinforcement learning is about learning through rewards. You will need Python too. Key tools include NumPy for numerical operations, Pandas for organizing data, and Matplotlib and Seaborn for data visualization. These help you to work with and understand data. You need to understand data preparation, which involves cleaning and organizing data. Also, learn about the feature engineering, which is the process of selecting important parts of the data of the model. Gen AI uses deep learning. You can think of deep learning as a computer network with many layers. Understand the basic idea of how these networks learn from data. This is a key for understanding more complex Gen AI models. Moving on to phase 2, where you can start exploring the Gen AI models. Some of Gen AI models include GANs, which are two networks competing, one making fake data and other tries to spot it. This model works well for creating realistic outputs. The second model is VAEs. This model learns a hidden representation of data to create new or similar data. The next model is transformers, which are excellent at understanding context in sequence like text, audio, and even images using attention. The last model is diffusion model, which can create high quality data by reversing a noising process. This model is very popular for images. Apart from Gen AI models, you need to cover text generation model, which falls under natural language processing, which is NLP. These models power text creation from writing articles to translating languages. And lastly, you will cover image generation using GANs and diffusion models. In phase 3, we will focus on developing our practical skills. You can start with small projects such as generating basic images or text with small datasets. Do experiment and learn the workflow. Join platforms like Hugging Face, Reddit, Stack Overflow, and Kaggle forums to ask questions and learn from others. To showcase your work, you can use GitHub to share your projects and code. Phase 4 is truly about staying ahead. Gen AI is always changing, so you need to be aware of it. New architectures are constantly being built, so briefly be aware that more advanced models are continuously being developed beyond the basics that we have covered. I would also recommend learning about deploying models on cloud platforms like AWS, Google Cloud, or Azure, which will be useful for larger projects. Additionally, you can read research papers, follow tech experts online, whether on Twitter or LinkedIn, and stay curious about this field. Continuous learning is the key in this field. Now that you have built a strong foundation in generative AI, phase 5 is all about mastering the future of technology. A certification course provides formal validation of specialized knowledge and skills, making individuals stand out to employees and demonstrating a commitment to professional development. This recognition often leads to enhanced credibility that improves career opportunities with specific field. Wondering which certification to go with? Don't worry, I've got you covered here as well. There are so many certificate courses available, but I would strongly suggest you to check on Applied Generative AI Specialization course by Simplilearn in partnership with Purdue University and Microsoft. This will be a 16-week course which will give you hands-on learning experience on building AI and Agentic AI apps through hands-on industry-relevant projects. You will also learn popular Gen AI tools, which includes gaining in exposure to Copilot, LangChain, Hugging Face, Azure AI Studio, OpenAI, and other tools. Additionally to this, you will provide a certificate from Purdue University and course completion certificate from Microsoft. Hurry and enroll now.
Find the course link in the description box and pinned comments. That's your roadmap to understanding generative AI. Start with the basics and get practical experience and never stop learning. The power of Gen AI is within your reach.
We've looked at a lot of examples of machine learning, so let's see if we can give a little bit more of a concrete definition. What is machine learning? Machine learning is the science of making computers learn and act like humans by feeding data and information without being explicitly programmed. And we see here we have a nice little diagram where we have our ordinary system. Your computer, nowadays you can even run a lot of this stuff on a cell phone because cell phones have advanced so much. And then with artificial intelligence and machine learning, it now takes the data and it learns from what happened before. And then it predicts what's going to come next. And then really the biggest part right now in machine learning that's going on is it improves on that. How do we find a new solution? So we go from descriptive, where it's learning about stuff and understanding how it fits together, to predicting what it's going to do, to post-scripting, coming up with a new solution. And when we're working on machine learning, there's a number of different diagrams that people have posted for what steps to go through. A lot of it might be very domain specific. So if you're working on photo identification versus language versus medical or physics, some of these are switched around a little bit or new things are put in. They're very specific to the domain. This is kind of a very general diagram. First, you want to define your objective. Very important to know what it is you're wanting to predict. Then you're going to be collecting the data. So once you've defined an objective, you need to collect the data that matches. You spend a lot of time in data science collecting data, and the next step, preparing the data. You got to make sure that your data is clean going in. There's the old saying, bad data in, bad answer out, or bad data out. And then once you've gone through and we've cleaned all this stuff coming in, then you're going to select the algorithm. Which algorithm are you going to use? You're going to train that algorithm. In this case, I think we're going to be working with SVM, the support vector machine. Then you have to test the model. Does this model work? Is this a valid model for what we're doing? And then once you've tested it, you want to run your prediction. You want to run your prediction or your choice or whatever output it's going to come up with. And then once everything is set and you've done lots of testing, then you want to go ahead and deploy the model. And remember I said domain specific. This is very general as far as the scope of doing something. A lot of models, you get halfway through and you realize that your data is missing something and you have to go collect new data because you've run a test in here someplace along the line. You're saying, hey, I'm not really getting the answers I need. So there's a lot of things that are domain specific that become part of this model. This is a very general model, but it's a very good model to start with. And we do have some basic divisions of what machine learning does that's important to know. For instance, do you want to predict a category? Well, if you're categorizing things, that's classification. For instance, whether the stock price will increase or decrease. So in other words, I'm looking for a yes-no answer. Is it going up or is it going down? And in that case, we'd actually say, is it going up? True. If it's not going up, it's false, meaning it's going down. This way, it's a yes-no, 0, 1. Do you want to predict a quantity? That's regression. So remember, we just did classification. Now we're looking at regression. These are the two major divisions in what data is doing. For instance, predicting the age of a person based on the height, weight, health, and other factors. So based on these different factors, you might guess how old a person is. And then there are a lot of domain-specific things, like do you want to detect an anomaly? That's anomaly detection. This is actually very popular right now. For instance, you want to detect money withdrawal anomalies. You want to know when someone's making a withdrawal that might not be their own account. We've actually brought this up because this is really big right now. If you're predicting the stock, whether to buy stock or not, you want to be able to know if what's going on in the stock market is an anomaly. Use a different prediction model because something else is going on. You got to pull out new information in there. Or is this just the norm? I'm going to get my normal return on my money invested. So being able to detect anomalies is very big in data science these days. Another question that comes up, which is on what we call untrained data, is do you want to discover structure in unexplored data? And that's called clustering. For instance, finding groups of customers with similar behavior given a large database of customer data containing their demographics and past buying records. And in this case, we might notice that anybody who's wearing a certain set of shoes goes shopping at certain stores, or whatever it is, they're going to make certain purchases. By having that information, it helps us to market or group people together so that we can now explore that group and find out what it is we want to market to them if you're in the marketing world. And that might also work in just about any arena. You might want to group people together, whether They're based on their different areas and investments and financial background, whether you're going to give them a loan or not. Before you even start looking at whether they're a valid customer for the bank, you might want to look at all these different areas and group them together based on unknown data. So you don't know what the data is going to tell you, but you want to cluster people together that come together. Let's take a quick detour for quiz time. Oh, my favorite. So we're going to have a couple questions here under our quiz time. And we'll be posting the answers in the part 2 of this tutorial. So let's go ahead and take a look at these quiz times questions, and hopefully you'll get them all right, and it'll get you thinking about how to process data and what's going on. Can you tell what's happening in the following cases? Of course, you're sitting there with your cup of coffee and you have your checkbox and your pen trying to figure out what's your next step in your data science analysis. So the first one is grouping documents into different categories based on the topic and content of each document. Very big these days. You have legal documents, you have maybe it's a sports group documents, maybe you're analyzing newspaper postings, but certainly having that automated is a huge thing in today's world. B, identifying handwritten digits in images correctly. So we want to know whether they're writing an A or capital A, B, C. What are they writing out in their handwriting? C, behavior of a website indicating that the site is not working as designed. D, predicting salary of an individual based on his or her years of experience. Boy, HR hiring setup there. So stay tuned for part 2. We'll go ahead and answer these questions when we get to the part 2 of this tutorial. Or you can just simply write at the bottom and send a note to Simplilearn, and they'll follow up with you on it. Back to our regular content. And these last few bring us into the next topic, which is another way of dividing our types of machine learning, and that is with supervised, unsupervised, and reinforcement learning. Supervised learning is a method used to enable machines to classify, predict objects, problems, or situations based on labeled data fed to the machine. And in here you see we have a jumble of data with circles, triangles, and squares, and then we label them. We have what's a circle, what's a triangle, what's a square. And we have our model training, and it trains it so we know the answer. Very important, when you're doing supervised learning, you already know the answer to a lot of your information coming in. So you have a huge group of data coming in, and then you have new data coming in. So we've trained our model. The model now knows the difference between a circle, a square, a triangle. And now that we've trained it, we can send in this case, a square and a circle goes in, and it predicts that the top one's a square and the next one's a circle. And you can see that this is being able to predict whether someone's going to default on a loan, because I was talking about banks earlier. Supervised learning on stock market, whether you're going to make money or not. That's always important. And if you are looking to make a fortune in the stock market, keep in mind it is very difficult to get all the data correct on the stock market. It is it fluctuates in ways really hard to predict. So it's quite a roller coaster ride. If you're running machine learning on the stock market, you start realizing you really have to dig for new data. So we have supervised learning, and if you have supervised, we should need unsupervised learning. In unsupervised learning, machine learning model finds the hidden pattern in an unlabeled data. So in this case, instead of telling it what the circle is, and what a triangle is, and what a square is, it goes in there, looks at them, and says, for whatever reason, it groups them together. Maybe it'll group it by the number of corners. And it notices that a number of them all have 3 corners, a number of them all have 4 corners, and a number of them all have no corners. And it's able to filter those through and group them together. We talked about that earlier with looking at a group of people who are out shopping. We want to group them together to find out what they have in common. And of course, once you understand what people have in common, maybe you have one of them who's a customer at your store, or you have 5 of them are customer at your store, and they have a lot in common with 5 others who are not customers at your store. How do you market to those 5 who aren't customers at your store yet? They fit the demographics of who's going to shop there, and you'd like them to shop at your store, not the one next door. Of course, this is a simplified version. You can see very easily the difference between a triangle and a circle, which might not be so easy in marketing. Reinforcement learning. Reinforcement learning is an important type of machine learning where an agent learns how to behave in an environment by performing actions and seeing the result. And we have here where in this case, a baby. It's actually great that they used an infant for this slide, because the reinforcement learning is very much in its infant stages. But it's also probably the biggest machine learning demand out there right now, or in the future, it's going to be coming up over the next few years, is reinforcement learning and how to make that work for us. And you can see here where we have our action. In the action in this one, it goes into the fire. Hopefully the baby didn't, it was just a little candle, not a giant fire pit like it looks like here. When the baby comes out, and the new state is the baby is sad and crying because they got burned on the fire. And then maybe they take another action. The baby's called the agent because it's the one taking the actions. And in this case, they didn't go into the fire. They went a different direction, and now the baby's happy and laughing and playing. Reinforcement learning is very easy to understand because that's how, as humans, that's one of the ways we learn. We learn whether it is, you burn yourself on the stove, don't do that anymore. Don't touch the stove. In the big picture, being able to have a machine learning program or an AI be able to do this is huge because now we're starting to learn how to learn. That's a big jump in the world of computer and machine learning. And we're going to go back and just kind of go back over supervised versus unsupervised learning. Understanding this is huge because this is going to come up in any project you're working on. We have in supervised learning, we have labeled data, we have direct feedback. So someone's already gone in there and said, yes, that's a triangle. No, that's not a triangle. And then you predict an outcome. So you have a nice prediction. This new set of data is coming in and we know what it's going to be. And then with unsupervised training, it's not labeled. So we really don't know what it is. There's no feedback. So we're not telling it whether it's right or wrong. We're not telling it whether it's a triangle or a square. We're not telling it to go left or right. All we do is we're finding hidden structure in the data, grouping the data together to find out what connects to each other. And then you can use these together. So imagine you have an image and you're not sure what you're looking for. So you go in and you have the unstructured data, find all these things that are connected together. And then somebody looks at those and labels them. Now you can take that labeled data and program something to predict what's in the picture. So you can see how they go back and forth, and you can start connecting all these different tools together to make a bigger picture. There are many interesting machine learning algorithms. Let's have a look at a few of them. Hopefully this gives you a little flavor of what's out there. And these are some of the most important ones that are currently being used. We'll take a look at linear regression, decision tree, and the support vector machine. Let's start with a closer look at linear regression. Linear regression is perhaps one of the most well-known and well-understood algorithms in statistics and machine learning. Linear regression is a linear model. For example, a model that assumes a linear relationship between the input variables x and the single output variable y. And you'll see this if you remember from your algebra classes, y equals mx plus c. Imagine we are predicting distance traveled y from speed x. Our linear regression model representation for this problem would be y equals m times x plus c, or distance equals m times speed plus c, where m is the coefficient and c is the y-intercept. And we're going to look at two different variations of this. First, we're going to start with time is constant. And you can see we have a bicyclist. He's got his safety gear on, thank goodness. Speed equals 10 meters per second. And so over a certain amount of time, his distance equals 36 kilometers. We have a second bicyclist who's going twice the speed, or 20 meters per second. And you can guess if he's going twice the speed and time is a constant, then he's going to go twice the distance. And that's easily to compute. 36 times 2, you get 72 kilometers. And so if you had the question of how fast would somebody who's going 3 times that speed, or 30 meters per second is, you can easily compute the distance. In our head, we can do that without needing a computer. But we want to do this for more complicated data. So it's kind of nice to compare the two, but let's just take a look at that and what that looks like in a graph. So in a linear regression model, we have our distance to the speed, and we have our m equals the VE slope of the line. And we'll notice that the line has a plus slope. And as the speed increases, distance also increases, hence the variables have a positive relationship. And so your speed of the person, which equals y equals mx plus c, distance traveled in a fixed interval of time. And we could very easily compute, either following the line or just knowing it's 3 times 10 meters per second, that this is roughly 102 kilometers distance that this third bicyclist has traveled. One of the key definitions on here is positive relationship. So the slope of the line is positive. As distance increase, so does speed increase. Let's take a look at our second example where we put distance is a constant. So we have speed equals 10 meters per second. They have a certain distance to go, and it takes them 100 seconds to travel that distance. And we have our second bicyclist who's still doing 20 meters per second. Since he's going twice the speed, we can guess that he'll cover the distance in about half the time. 50 seconds. And of course you could probably guess on the third one, 100 divided by 30, since he's going 3 times the speed, you could easily guess that this is 33.333 seconds time. When we put that into a linear regression model or a graph, if the distance is assumed to be constant, let's see the relationship between speed and time. And as time goes up, the amount of speed to go that same distance goes down. So now your m equals a minus VE slope of the line. As the speed increases, time decreases, hence the variable has a negative relationship. Again, there's our definition, positive relationship and negative relationship dependent on the slope of the line. And with a simple formula like this, and even a significant amount of data, let's see with the mathematical implementation of linear regression. And we'll take this data, so suppose we have this data set where we have x, y, x equals 1, 2, 3, 4, 5, standard series, and the y value is 3, 2, 2, 4, 3. When we take that and we go ahead and plot these points on a graph, you can see there's kind of a nice scattering, and you could probably eyeball a line through the middle of it. But we're going to calculate that exact line for linear regression. And the first thing we do is we come up here and we have the mean of xi. And remember, mean is basically the average. So we added 5 plus 4 plus 3 plus 2 plus 1 and divide by 5. And that simply comes out as 3. And then we'll do the same for y. We'll go ahead and add up all those numbers and divide by 5. And we end up with a mean value of y of I equals 2.8, where the xi references it's an average or means value, and the yi also equals a means value of y. And when we plot that, you'll see that we can put in the y equals 2.8 and the x equals 3 in there on our graph. We kind of gave it a little different color so you could sort it out with the dashed lines on it. And it's important to note that when we do the linear regression model should go through that dot. Now let's find our regression equation to find the best fit line. Remember, we go ahead and take our y equals mx plus c, so we're looking for m and c. So to find this equation for our data, we need to find our slope of m and our coefficient of c. And we have y equals mx plus c, where m equals the sum of x minus x average times y minus y average, or y means and x means, over the sum of x minus x means squared. That's how we get the slope of the value of the line. And we can easily do that by creating some columns here where we have x, y. Computers are really good about iterating through data, and so we can easily compute this and fill in a graph of data. And in our graph, you can easily see that if we have our x value of 1, and if you remember the xi, or the means value, is 3, 1 minus 3 equals a negative 2, and 2 minus 3 equals a negative 1, so on and so forth. And we can easily fill in the column of x minus xi, y minus yi, and then from those we can compute x minus xi squared and x minus xi times y minus yi. And you can guess it that the next step is to go ahead and sum the different columns for the answers we need. So we get a total of 10 for our x minus xi squared, and a total of 2 for x minus xi times y minus yi. And we plug those in, we get 2/10, which equals 0.2. So now we know the slope of our line equals 0.2. So we can calculate the value of c. That'd be the next step, is we need to know where it crosses the y-axis. And if you remember, I mentioned earlier that the linear regression line has to pass through the means value, the one that we showed earlier. We can just flip back up there to that graph, and you can see right here there's our means value, which is 3, x equals 3 and y equals 2.8. And since we know that value, we can simply plug that into our formula, y equals 0.2x plus c. So we plug that in and we get 2.8 equals 0.2 times 3 plus c, and you can just solve for c. So now we know that our coefficient equals 2.2. And once we have all that, we can go ahead and plot our regression line. Y equals 0.2 times x plus 2.2. And then from this equation, we can compute new values. So let's predict the values of y using x equals 1, 2, 3, 4, 5 and plot the points. Remember, the 1, 2, 3, 4, 5 was our original x values. So now we're going to see what y thinks they are, not what they actually are. And when we plug those in, we get y of designated with y of p. You can see that x equals 1 equals 2.4, x equals 2 equals 2.6, and so on and so on. So we have our y predicted values of what we think it's going to be when we plug those numbers in. And when we plot the predicted values along with the actual values, we can see the difference. And this is one of the things that's very important with linear regression in any of these models, is to understand the error. And so we can calculate the error on all of our different values. And you can see over here we plotted x and y predict. And we draw in a little line so you can sort of see what the error looks like there between the different points. So our goal is to reduce this error. We want to minimize that error value on our linear regression model. Minimizing the distance. There are lots of ways to minimize the distance between the line and the data points, like sum of squared errors, sum of absolute errors, root mean square error, etc. We keep moving this line through the data points to make sure the best fit line has the least square distance between the data points and the regression line. So to recap with a very simple linear regression model, we first figure out the formula of our line through the middle, and then we slowly adjust the line to minimize the error. Keep in mind this is a very simple formula. The math gets, even though the math is very much the same, it gets much more complex as we add in different dimensions. So this is only 2 dimensions, y equals mx plus c, but you can take that out to x, z, ijq, all the different features in there, and they can plot a linear regression model on all of those using the different formulas to minimize the error. Let's go ahead and take a look at decision trees, a very different way to solve problems in the linear regression model. Decision tree is a tree-shaped algorithm used to determine a course of action. Each branch of a tree represents a possible decision, occurrence, or reaction. We have data which tells us if it is a good day to play golf. And if we were to open this data up in a general spreadsheet, you can see we have the outlook, whether it's rainy, overcast, sunny, temperature, hot, mild, cool, humidity, windy, and did I like to play golf that day, yes or no? So we're taking a census. And certainly I wouldn't want a computer telling me when I should go play golf or not. But you can imagine if you got up in the night before, you're trying to plan your day, and it comes up and says tomorrow would be a good day for golf for you in the morning, and not a good day in the afternoon, or something like that. This becomes very beneficial, and we see this in a lot of applications coming out now where it gives you suggestions and lets you know what would fit the match for you for the next day or the next purchase or the next whatever, next meal out. In this case, is tomorrow a good day for playing golf based on the weather coming in? And so we come up and let's determine if you should play golf when the day is sunny and windy. So we found out the forecast tomorrow is going to be sunny and windy. And suppose we draw our tree like this. We're going to have our humidity, and then we have our normal, which is if you have a normal humidity, you're going to go play golf. And if the humidity is really high, then we look at the outlook. And if the outlook is sunny, overcast, or rainy, it's going to change what you choose to do. So if you know that it's a very high humidity and it's sunny, you're probably not going to play golf because you're going to be out there miserable, fighting off the mosquitoes that are out joining you to play golf with you. Maybe if it's rainy, you probably don't want to play in the rain. But if it's slightly overcast and you get just the right shadow, that's a good day to play golf and be outside, out on the green. Now in this example, you can probably make your own tree pretty easily because it's a very simple set of data going in. But the question is, how do you know what to split? Where do you split your data? What if this is much more complicated data where it's not something that you would particularly understand? Like studying cancer, they take about 36 measurements of the cancerous cells, and then each one of those measurements represents how bulbous it is, how extended it is, how sharp the edges are. Something that as a human we would have no understanding of. So how do we decide how to split that data up? And is that the right decision tree? So that's a question that's going to come up. Is this the right decision tree? For that, we should calculate entropy and information gain. 2 important vocabulary words there are the entropy and the information gain. Entropy. Entropy is a measure of randomness or impurity in the data set. Entropy should be low. So we want the chaos to be as low as possible. We don't want to look at it and be confused by the images or what's going on there with mixed data. And the information gain. It is a measure of decrease in entropy after the data set is split, also known as entropy reduction. Information gain should be high, so we want our information that we get out of the split to be as high as possible. Let's take a look at entropy from the mathematical side. In this case, we're going to denote entropy as I of P of n, where P is the probability that you're going to play a game of golf, and n is the probability where you're not going to play the game of golf. Now, you don't really have to memorize these formulas. There's a few of them out there depending on what you're working with. But it's important to note that this is where this formula is coming from, so when you see it, you're not lost when you're running your programming, unless you're building your own decision tree code in the back. And we simply have a log squared of p over p plus n minus n over p plus n times the log squared of n of p plus n. But let's break that down and see what it actually looks like when we're computing that from the computer script side. Entropy of a target class of the data set is the whole entropy. So we have entropy play golf. And when we look at this, if we go back to the data, you can simply count how many yeses and no in our complete data set for playing golf days. In our complete set, we find we have 5 days we did play golf and 9 days we did not play golf. And so our I equals, if you add those together, 9 plus 5 is 14. And so our I equals 5 over 14 and 9 over 14. That's our P and N values that we plug into that formula. And you can go 5 over 14 equals 0.36, 9 over 14 equals 0.64. And when you do the whole equation, you get the minus 0.36 log root squared of 0.36 minus 0.64 log squared root of 0.64. And we get a set value. We get 0.94. So we now have a full entropy value for the whole set of data that we're working with. And we want to make that entropy go down. And just like we calculated the entropy out for the whole set, we can also calculate entropy for playing golf and the outlook. Is it going to be overcast or rainy or sunny? And so when we look at the entropy, we have P of sunny times E of 3 of 2. And that just comes out how many sunny days yes and how many sunny days no over the total, which is 5. Don't forget to put we'll divide that 5 out later on. Equals P overcast equals 4 comma 0 plus rainy equals 2 comma 3. And then when you do the whole setup, we have 5 over 14. Remember I said there was a total of 5? 5 over 14 times the I of 3 of 2 plus 4 over 14 times the 4 comma 0 and 514 over I of 2, 3. And so we can now compute the entropy of just the part that has to do with the forecast. And we get 0.693. Similarly, we can calculate the entropy of other predictors like temperature, humidity, and wind. And so we look at the gain outlook. How much are we going to gain from this? Entropy play golf minus entropy play golf outlook. And we can take the original 0.94 for the whole set minus the entropy of just the rainy day and temperature, and we end up with a gain of 0.247. So this is our information gain. Remember, we define entropy and we define information gain. The higher the information gain, the lower the entropy, the better. The information gain of the other 3 attributes can be calculated in the same way. So we have our gain for temperature equals 0.029. We have our gain for humidity equals 0.152, and our gain for a windy day equals 0.048. And if you do a quick comparison, you'll see the 0.247 is the greatest gain of information, so that's the split we want. Now let's build the decision tree. So we have the outlook. Is it going to be sunny, overcast, or rainy? That's our first split because that gives us the most information gain. And we can continue to go down the tree using the different information gains with the largest information. We can continue down the nodes of the tree where we choose the attribute with the largest information gain as the root node and then continue to split each subnode with the largest information gain that we can compute. And although it's a little bit of a tongue twister to say all that, you can see that it's a very easy to view visual model. We have our outlook, we split it 3 different directions. If the outlook is overcast, we're going to play. And then we can split those further down if we want. So if the outlook is sunny, but then it's also windy, if it's windy, we're not going to play. If it's not windy, we'll play. So we can easily build a nice decision tree to guess what we would like to do tomorrow and give us a nice recommendation for the day. So we want to know if it's a good day to play golf when it's sunny and windy. Remember the original question that came out? Tomorrow's weather report is sunny and windy. You can see by going down the tree, we go outlook sunny, outlook windy. We're not going to play golf tomorrow. So our little smartwatch pops up and says, I'm sorry, tomorrow's not a good day for golf. It's going to be sunny and windy. And if you're a huge golf fan, you might go, uh-oh, it's not a good day to play golf. We can go in and watch a golf game at home. So we'll sit in front of the TV instead of being out playing golf in the wind. Now that we looked at our decision tree, let's look at the third one of our algorithms we're investigating. Support vector machine. Support vector machine is a widely used classification algorithm. The idea of support vector machine is simple. The algorithm creates a separation line which divides the classes in the best possible manner. For example, dog or cat, disease or no disease. Suppose we have a labeled sample data which tells height and weight of males and females. A new data point arrives and we want to know whether it's going to be a male or a female. So we start by drawing a line. We draw decision lines, but if we consider decision line 1, then we will classify the individual as a male. And if we consider decision line 2, then it will be a female. So you can see this person kind of lies in the middle of the two groups, so it's a little confusing trying to figure out which line they should be under. We need to know which line divides the classes correctly, but how? The goal is to choose a hyperplane, and that is one of the key words they use when we talk about support vector machines. Choose a hyperplane with the greatest possible margin between the decision line and the nearest point within the training set. So you can see here we have our support vector, we have the two nearest points to it, and we draw a line between those 2 points. And the distance margin is the distance between the hyperplane and the nearest data point from either set. So we actually have a value, and it should be equally distant between the 2 points that we're comparing it to. When we draw the hyperplanes, we observe that line 1 has a maximum distance. So we observe that line 1 has a maximum distance margin, so we'll classify the new data point correctly. And our result on this one is going to be that the new data point is male. One of the reasons we call it a hyperplane versus a line is that a lot of times we're not looking at just weight and height. We might be looking at 36 different features or dimensions. And so when we cut it with a hyperplane, it's more of a three-dimensional cut in the data, or multi-dimensional. It cuts the data a certain way. And each plane continues to cut it down until we get the best fit or match. Let's understand this with the help of an example. Problem statement. I always start with a problem statement when you're going to put some code together. We're going to do some coding now. Classifying muffin and cupcake recipes using support vector machines. So the cupcake versus the muffin. Let's have a look at our data set. And we have the different recipes here. We have a muffin recipe that has so much flour. I'm not sure what measurement 55 is in, but it has 55, maybe it's ounces? But it has a certain amount of flour, a certain amount of milk, sugar, butter, egg, baking powder, vanilla, and salt. And so based on these measurements, we want to guess whether we're making a muffin or a cupcake. And you can see in this one, we don't have just 2 features. We don't just have height and weight as we did before between the male and female. In here, we have a number of features. In fact, in this, we're looking at 8 different features to guess whether it's a muffin or a cupcake. What's the difference between a muffin and a cupcake? Turns out muffins have more flour, while cupcakes have more butter and sugar. So basically the cupcake's a little bit more of a dessert, where the muffin's a little bit more of a fancy bread. But how do we do that in Python? How do we code that to go through recipes and figure out what the recipe is? And I really just want to say cupcakes versus muffins, like some big professional wrestling thing. Before we start in our cupcakes versus muffins, we are going to be working in Python. There's many versions of Python, many different editors. That is one of the strengths and weaknesses of Python, is it just has so much stuff attached to it, and it's one of the more popular data science programming packages you can use. In this case, we're going to go ahead and use Anaconda and Jupyter Notebook. The Anaconda Navigator has all kinds of fun tools. Once you're into the Anaconda Navigator, you can change environments. I actually have a number of environments on here. We'll be using Python 3.6 environment. So this is in Python version 3.6. Although it doesn't matter too much which version you use. I usually try to stay with the 3x because they're current, unless you have a project that's very specifically in version 2x. 2.7 I think is usually what most people use in the version 2. And then once we're in our Jupyter Notebook editor, I can go up and create a new file. And we'll just jump in here. In this case, we're doing SVM muffin versus cupcake. And then let's start with our packages for data analysis. And we almost always use there's a few very standard packages we use. We use import numpy. That's for number Python. They usually denote it as NP. That's very common. And then we're going to import pandas as PD. And numpy deals with number arrays. There's a lot of cool things you can do with the numpy setup as far as multiplying all the values in an array, in a numpy array, data array. Pandas, I can't remember if we're using it actually in this data set. I think we do as an import. It makes a nice data frame. And the difference between a data frame and a numpy array is that a data frame is more like your Excel spreadsheet. You have columns, you have indexes, so you have different ways of referencing it, easily viewing it. and there's additional features you can run on a data frame. And Pandas kind of sits on NumPy, so you need them both in there. And then finally, we're working with the support vector machine. So from sklearn, we're going to use the sklearn model, import svm, support vector machine. And then as a data scientist, you should always try to visualize your data. Some data obviously is too complicated or doesn't make any sense to the human, but if it's possible, it's good to take a second look at it so that you can actually see what you're doing. Now for that, we're going to use two packages. We're going to import matplotlibary.pyplot as PLT, again very common, and we're going to import Seaborn as SNS. And we'll go ahead and set the font scale in the SNS right in our import line. That's what this semicolon followed by a line of data. We're going to set the SNS. And these are great because the Seaborn sits on top of matplotlibary, just like Pandas sits on NumPy. So it adds a lot more features and uses and control. We're obviously not going to get into matplotlibary and Seaborn. That'd be its own tutorial. We're really just focusing on the SVM, the support vector machine from sklearn. And since we're in Jupyter Notebook, we have to add a special line in here for our matplotlibary. And that's your percentage sign or ampersand matplotlibary in line. Now, if you're doing this in just a straight code project, a lot of times I use like Notepad++, and I'll run it from there. You don't have to have that line in there because it'll just pop up as its own window on your computer, depending on how your computer's set up. Because we're running this in the Jupyter Notebook as a browser setup, this tells it to display all of our graphics right below on the page. So that's what that line is for. I remember the first time I ran this, I didn't know that, and I had to go look that up years ago. It was quite a headache. So matplotlibary inline is just because we're running this on the web setup. And we can go ahead and run this, make sure all our modules are in. They're all imported, which is great. If you don't have them import, you'll need to go ahead and pip, use the PIP or however you do it. There's a lot of other install packages out there, although pip is the most common. And you have to make sure these are all installed on your Python setup. The next step, of course, is we got to look at the data. You can't run a model for predicting data if you don't have actual data. So to do that, let me go ahead and open this up and take a look. And we have our cupcakes versus muffins. And it's a CSV file, or .csv, meaning that it's comma-separated variable. And it's going to open it up in a nice spreadsheet for me. And you can see up here we have the type. We have muffin, 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 cupcake, cupcake, cupcake. And then it's broken up into flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. So what we can do is we can go ahead and look at this data also in our Python. Let us create a variable recipes equals, we're going to use our pandas module, .read CSV. Remember, it was a comma-separated variable. And the file name happened to be cupcakes versus muffins. Oops, I got double brackets there. Do it this way. There we go. Cupcakes versus muffins. Because the program I loaded, or the place I saved this particular Python program is in the same folder, we can get by with just the file name. But remember, if you're storing it in a different location, you have to also put down the full path on there. And then because we're in pandas, we're going to go ahead and you can actually, inline you can do this, but let me do the full print. You can just type in recipes.head in the Jupyter Notebook. But if you're running in code in a different script, you need to go ahead and type out the whole print recipes.head. And Pandas knows that that's going to do the first 5 lines of data. And if we flip back on over to the spreadsheet where we opened up our CSV file, you can see where it starts on line 2. This one calls it 0, and then 2, 3, 4, 5, 6 is going to match. Go and close that out because we don't need that anymore. And it always starts at 0. And it automatically indexes it since we didn't tell it to use an index in here. So that's the index number for the left-hand side. And it automatically took the top row as labels. So Pandas using it to read a CSV is just really slick and fast. One of the reasons we love our pandas. Not just because they're cute and cuddly teddy bears. And let's go ahead and plot our data. And I'm not going to plot all of it. I'm just going to plot the sugar and flour. Now, obviously, you can see where they get really complicated if we have tons of different features. And so you'll break them up and maybe look at just 2 of them at a time to see how they connect. And to plot them, we're going to go ahead and use Seaborn. So that's our SNS. And the command for that is sns.lmplot. And then the 2 different variables I'm going to plot is flour and sugar. Data equals recipes. The hue equals type. And this is a lot of fun because it knows that this is pandas coming in. So this is one of the powerful things about pandas mixed with Seaborn and doing graphing. And then we're going to use a palette set 1. There's a lot of different sets in there. You can go look them up for Seaborn. We'll do a fit regular equals false, so we're not really trying to fit anything. And it's a scatter, KWS. A lot of these settings you can look up in Seaborn. Half of these you could probably leave off when you run them. Somebody played with this and found out that these were the best settings for doing a Seaborn plot. And let's go ahead and run that. And because it does it inline, it just puts it right on the page. And you can see right here that just based on sugar and flour alone, there's a definite split. And we use these models because you can actually look at it and say, hey, if I drew a line right between the middle of the blue dots and the red dots, we'd be able to do an SVM and a hyperplane right there in the middle. Then the next step is to format or pre-process our data. And we're going to break that up into 2 parts. We need a type label, and remember, we're going to decide whether it's a muffin or a cupcake. Well, a computer doesn't know muffin or cupcake. It knows 0 and 1. So what we're going to do is we're going to create a type label. And from this, we'll create a numpy array, np, where, and this is where we can do some logic. We take our recipes from our panda, and wherever type equals muffin, it's going to be 0. And then if it doesn't equal muffin, which is cupcakes, it's going to be 1. So we create our type label. This is the answer. So when we're doing our training model, remember we have to have a training data. This is what we're going to train it with, is that it's 0 or 1. It's a muffin or it's not. And then we're going to create our recipe features. And if you remember correctly from right up here, the first column is type. So we really don't need the type column because that's our muffin or cupcake. And in pandas, we can easily sort that out. We take our value recipes dot columns. That's a pandas function built into pandas. Dot values, converting them to values. So it's just the column titles going across the top. And we don't want the first one. So what we do is, since it always starts at 0, we want 1 colon till the end. And then we want to go ahead and make this a list, and this converts it to a list of strings. And then we can go ahead and just take a look and see what we're looking at for the features, make sure it looks right. Let me go ahead and run that. And I forgot the S on recipes, so we'll go ahead and add the S in there and then run that. And we can see we have flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. And that matches what we have up here, right where we printed out everything but the type. So we have our features and we have our label. Now, the recipe features is just the titles of the columns, and we actually need the ingredients. And at this point, we have a couple options. One, we could run it over all the ingredients. And when you're doing this, usually you do, but for our example, we want to limit it so you can easily see what's going on. Because if we did all the ingredients, we have, that's what, 7, 8 different hyperplanes that would be built into it. We only want to look at one so you can see what the SVM is doing. And so we'll take our recipes and we'll do just flour and sugar. Again, you can replace that with your recipe features and do all of them, but we're going to do just flour and sugar, and we're going to convert that to values. We don't need to make a list out of it because it's not string values. These are actual values on there. And we can go ahead and just print ingredients, and you can see what that looks like. And so we have just the amount of flour and sugar, just the two sets of plots. And just for fun, let's go ahead and take this over here and take our recipe features. And so if we decided to use all the recipe features, you'll see that it makes a nice column of different data. So it just strips out all the labels and everything, and we just have just the values. But because we want to be able to view this easily in a plot later on, we'll go ahead and take that and just do flour and sugar. And we'll run that, and you'll see it's just the two columns. So the next step is to go ahead and fit our model. We'll go ahead and just call it model. And it's a SVM. We're using a package called SVC. In this case, we're going to go ahead and set the kernel equals linear. So it's using a specific setup on there. And if we go to the reference on their website for the SVM, you'll see that there's 8 of them here. 3 of them are for regression. 3 are for classification. The SVC, support vector classification, is probably one of the most commonly used. And then there's also one for detecting outliers, and another one that has to do with something a little bit more specific on the model. But SVC and SVR are the 2 most commonly used, standing for support vector classifier and support vector regression. Remember, regression is an actual value, a float value, or whatever you're trying to work on. And SVC is a classifier, so it's a yes, no, true, false. But for this, we want to know 0, 1, muffin, cupcake. We go ahead and create our model. And once we have our model created, we're going to do model.fit. And this is very common, especially in the sklearn. All their models are followed with the fit command. And what we put into the fit, what we're training with it, is we're putting in the ingredients, which in this case we limited to just flour and sugar. And the type label, is it a muffin or a cupcake? Now, in more complicated data science series, you'd want to split into, we won't get into that today, we split it into training data and test data. And they even do something where they split it into thirds, where a third is used for, where you switch between which one's training and test. There's all kinds of things that go into that. It gets very complicated when you get to the higher end. Not overly complicated, just an extra step which we're not going to do today because this is a very simple set of data. And let's go ahead and run this, and now we have our model fit. And I got an error here, so let me fix that real quick. It's capital SVC, it turns out. I did it lowercase. Support vector classifier. There we go. Let's go ahead and run that. And you'll see it comes up with all this information that it prints out automatically. These are the defaults of the model. You notice that we changed the kernel to linear, and there's our kernel linear on the printout. And there's other different settings you can mess with. We're going to just leave that alone for right now. For this, we don't really need to mess with any of those. So next, we're going to dig a little bit into our newly trained model. And we're going to do this so we can show you on a graph. And let's go ahead and get the separating. And we're going to say we're going to use a W for our variable on here. And we're going to do model.coefficient _0. So what the heck is that? Again, we're digging into the model. So we've already got a prediction and a train. This is the math behind it that we're looking at right now. And so the W is going to represent 2 different coefficients. And if you remember, we had y equals mx plus c. So these coefficients are connected to that, but in 2-dimensional. It's a plane. We don't want to spend too much time on this because you can get lost in the confusion of the math. So if you're a math whiz, this is great. You can go through here and you'll see that we have a equals minus w of 0 over w of 1. Remember, there's 2 different values there. And that's basically the slope that we're generating. And then we're going to build an XX. What is XX? We're going to set it up to a numpy array. There's our np dot line space. So we're creating a line of values between 30 and 60. So it just creates a set of numbers for x. And then if you remember correctly, we have our formula, y equals the slope times x plus the intercept. Well, to make this work, we can do this as yy equals the slope times each value in that array. That's the neat thing about NumPy. So when I do a times xx, which is a whole NumPy array of values, it multiplies a across all of them. And then it takes those same values and we subtract the model intercept. That's your, remember we had mx plus c, so that'd be the c from the formula, y equals mx plus c. And that's where all these numbers come from. A little bit confusing because it's digging out of these different arrays. And then what we want to do is we're going to take this and we're going to go ahead and plot it. So plot the parallels to separating hyperplane that pass through the support vectors. And so we're going to create B equals a model support vectors, pulling our support vectors out there. Here's our YY, which we now know is a set of data. And we have we're going to create YY down equals A times XX plus B1 minus A times B0. And then model support vector B is going to be set that to a new value, the -1 setup, and YY up equals A times XX plus B1 minus A times B0. And we can go ahead and just run this to load these variables up. If you wanted to understand a little bit more of what's going on, you can see if we print YY, we just run that, you can see it's an array. This is a line. It's going to have, in this case, between 30 and 60, so it's going to be 30 variables in here. And the same thing with YY up, YY down. And we'll plot those in just a minute on a graph so you can see what those look like. You just go ahead and delete that out of here and run that so it loads up the variables. Nice clean slate. I'm just going to copy this from before. Remember this, our SNS, our seaborn plot, LM plot, flour, sugar. And I'll just go ahead and run that real quick so you can see remember what that looks like. It's just a straight graph on there. And then one of the neat things is because seaborn sits on top of pyplot, we can do the pyplot for the line going through. And that is simply plt.plot. And that's our XX and YY, our two corresponding values, XY. And then somebody played with this to figure out that the line width equals 2 and the color black would look nice. So let's go ahead and run this whole thing with the pyplot on there. And you can see when we do this, it's just doing flour and sugar on here. Corresponding line between the sugar and the flour and the muffin versus cupcake. And then we generated the support vectors, the YY down and YY up. So let's take a look and see what that looks like. So we'll do our PL plot. And again, this is all against XX, our X value. But this time we have YY down. And let's do something a little fun with this. We can put in a K dash dash. That just tells it to make it a dotted line. And if we're going to do the down one, we also want to do the up one. So here's our YY up. And when we run that, it adds both sets of line. And so here's our support, and this is what you expect. You expect these two lines to go through the nearest data point. So the dashed lines go through the nearest muffin and the nearest cupcake when it's plotting it. And then your SVM goes right down the middle. So it gives it a nice split in our data. And you can see how easy it is to see, based just on sugar and flour, which one's a muffin or a cupcake. Let's go ahead and create a function to predict muffin or cupcake. I've got my recipes I pulled off the internet, and I want to see the difference between a muffin or a cupcake. And so we need a function to push that through. And we'll create a function with def. And let's call it muffin or cupcake. And remember, we're just doing flour and sugar today. We're not doing all the ingredients. And that actually is a pretty good split. You really don't need all the ingredients to know it's flour and sugar. And let's go ahead and do an if-else statement. So if model predict is of flour and sugar equals 0. So we take our model and we run a predict. It's very common in sklearn where you have a dot predict. You put the data in and it's going to return a value. In this case, if it equals 0, then print you're looking at a muffin recipe. Else, if it's not 0, that means it's 1, then you're looking at a cupcake recipe. That's pretty straightforward for a function, or def for definition. DEF is how you do that in Python. And of course, if you're going to create a function, you should run something in it. And so let's run a cupcake, and we're going to send it values 50 and 20, a muffin or a cupcake. I don't know what it is. And let's run this and just see what it gives us. And it says, oh, it's a muffin. You're looking at a muffin recipe. So it very easily predicts whether we're looking at a muffin or a cupcake recipe. Let's plot this. Oops, there we go. Plot this on the graph so we can see what that actually looks like. And I'm just going to copy it and paste it from below, where we're plotting all the points in there. So this is nothing different than what we did before. If I run it, you'll see it has all the points and the lines on there. And what we want to do is we want to add another point. And we'll do PLT plot. And if you remember correctly, we did, for our test, we did 50 and 20. And then somebody went in here and decided we'll do YO for yellow, or it's kind of an orangish yellow color is going to come out. Marker size 9. Those are settings you can play with. Somebody else played with them to come up with the right setup so it looks good. And you can see there it is graphed, clearly a muffin. In this case, in cupcakes versus muffins, the muffin has won. And if you'd like to do your own muffin cupcake contender series, you certainly can send a note down below, and the team at Simplilearn will send you over the data they use for the muffin and cupcake. And that's true of any of the data. We didn't actually run a plot on it earlier. We had men versus women. You can also request that information to run it on your data setup so you can test that out. So to go back over our setup, we went ahead for our support vector machine code. We did a predict 40 parts flour, 20 parts sugar. I think it was different than the one we did, whether it's a muffin or a cupcake. Hence, we have built a classifier using SVM, which is able to classify if a recipe is of a cupcake or a muffin, which wraps up our cupcake versus muffin. We're going to cover clustering. What is clustering? K-means clustering, which is one of the most common used clustering tools out there, including a flowchart to understand K-means clustering and how it functions. And then we'll do an actual Python live demo on clustering of cars based on brands. Then we're going to cover logistic regression. What is logistic regression? Logistic regression curve and sigmoid function. And then we'll do another Python code demo to classify a tumor as malignant or benign based on features. And let's start with clustering. Suppose we have a pile of books of different genres. Now we divide them into different groups like fiction, horror, education, and as we can see from this young lady, she definitely is into heavy horror. You can just tell by those eyes and the maple Canadian leaf on her shirt. But we have fiction, horror, and education, and we want to go ahead and divide our books up. Well, organizing objects into groups based on similarity is clustering. And in this case, as we're looking at the books, we're talking about clustering things with known categories. But you can also use it to explore data. So you might not know the categories, you just know that you need to divide it up in some way to conquer the data and to organize it better. But in this case, we're going to be looking at clustering in specific categories. And let's just take a deeper look at that. We're going to use K-means clustering. K-means clustering is probably the most commonly used clustering tool in the machine learning library. K-means clustering is an example of unsupervised learning. If you remember from our previous thing, it is used when you have unlabeled data. So we don't know the answer yet. We have a bunch of data that we want to cluster into different groups. Define clusters in the data based on feature similarity. So we've introduced a couple terms here. We've already talked about unsupervised learning and unlabeled data. So we don't know the answer yet. We're just going to group stuff together and see if we can find an answer of how things connect. We've also introduced feature similarity. Features being different features of the data. Now with books, we can easily see fiction and horror and history books. But a lot of times with data, some of that information isn't so easy to see right when we first look at it. And so K-means is one of those tools where we can start finding things that connect, that match with each other. Suppose we have these data points and want to assign them into a cluster. Now when I look at these data points, I would probably group them into two clusters just by looking at them. I'd say two of these group of data kind of come together. But in K-means, we pick K clusters and assign random centroids to clusters, where the K clusters represents two different clusters. We pick k clusters and assign random centroids to the clusters, then we compute distance from objects to the centroids. Now we form new clusters based on minimum distances and calculate the centroids. So we figure out what the best distance is for the centroid, then we move the centroid and recalculate those distances. Repeat previous two steps iteratively till the cluster centroids stop changing their positions and become static. Repeat previous two steps iteratively till the cluster centroids stop changing and the positions become static. Once the clusters become static, then k-means clustering algorithm is said to be converged. And there's another term we see throughout machine learning is converged. That means whatever math we're using to figure out the answer has come to a solution, or it's converged on an answer. Shall we see the flow chart to understand? Make a little bit more sense by putting it into a nice easy step-by-step. So we start, we choose k, we'll look at the elbow method in just a moment. We assign random centroids to clusters, and sometimes you pick the centroids, because you might look at the data in a graph and say, oh, these are probably the central points. Then we compute the distance from the objects to the centroids. We take that and we form new clusters based on minimum distance and calculate their centroids. Then we compute the distance from objects to the new centroids. And then we go back and repeat those last two steps. We calculate the distances. So as we're doing it, it brings into the new centroid, and then we move the centroid around and we figure out which objects are closest to each centroid. So the objects can switch from one centroid to the other as the centroids are moved around. And we continue that until it is converged. Let's see an example of this. Suppose we have this data set of 7 individuals and their score on 2 topics, A and B. So here's our subject, in this case referring to the person taking the test. And then we have subject A where we see what they've scored on their first subject, and we have subject B and we can see what they score on the second subject. Now let's take 2 farthest apart points as initial cluster centroids. Now remember, we talked about selecting them randomly, or we can also just put them in different points and pick the furthest one apart so they move together. Either one works okay, depending on what kind of data you're working on and what you know about it. So we took the 2 furthest points, 1 and 1, and 5 and 7. And now let's take the 2 farthest apart points as initial cluster centroids. Each point is then assigned to the closest cluster with respect to the distance from the centroids. So we take each one of these points in there and we measure that distance, and you can see that if we measured each of those distances, and you use the Pythagorean theorem for a triangle in this case, because you know the x and the y, and you can figure out the diagonal line from that. Or you can just take a ruler and put it on your monitor. That'd be kind of silly, but it would work if you're just eyeballing it. You can see how they naturally come together in certain areas. Now we again calculate the centroids of each cluster. So cluster 1 and then cluster 2, and we look at each individual dot. There's 1, 2, 3, we're in one cluster. The centroid then moves over. It becomes 1.8, 2.3. So remember, it was at 1 and 1. Well, the very center of the data we're looking at would put it at the roughly 2, 2, but 1.8 and 2.3. And the second one, if we wanted to make the overall mean vector, the average vector of all the different distances to that centroid, we come up with 4, 1 and 5, 4. So we've now moved the centroids. We compare each individual's distance to its own cluster, mean, and to that of the opposite cluster, and we find, we can build a nice chart on here, that as we move that centroid around, we now have a new different kind of clustering of groups, and using Euclidean distance between the points and the mean, we get the same formula. You see new formulas coming up. So we have our individual dots, distance to the mean centroid of the cluster, and distance to the mean centroid of the cluster. Only individual 3 is nearer to the mean of the opposite cluster, cluster 2, than its own cluster 1. And you can see here in the diagram where we've kind of circled that 1 in the middle. So when we've moved the centroids of the clusters over, one of the points shifted to the other cluster because it's closer to that group of individuals. Thus, individual 3 is relocated to cluster 2, resulting in a new partition. And we regenerate all those numbers of how close they are to the different clusters. For the new clusters, we will find the actual cluster centroids. So now we move the centroids over. And you can see that we've now formed 2 very distinct clusters on here. On comparing the distance of each individual's distance to its own cluster mean and to that of the opposite cluster, we find that the data points are stable. Hence, we have our final clusters. Now, if you remember, I brought up a concept earlier, on the k-means algorithm. Choosing the right value of k will help in less number of iterations. And to find the appropriate number of clusters in a data set, we use the elbow method. And within sum of squares, WSS, is defined as the sum of the squared distance between each member of the cluster and its centroid. And so you see what we've done here is we have the number of clusters. And as you do the same k-means algorithm over the different clusters, and you calculate what that centroid looks like, and you find the optimal, you can actually find the optimal number of clusters using the elbow of the graph, is called as the elbow method. And in this, we guessed at 2 just by looking at the data. But as you can see, the slope, you actually just look for right there where the elbow is in the slope, and you have a clear answer that we want 2 different, to start with k-means equals 2. A lot of times people end up computing k-means equals 2, 3, 4, 5 until they find the value which fits on the elbow joint. Sometimes you can just look at the data, and if you're really good with that specific domain, remember domain, I mentioned that last time, you'll know that where to pick those numbers or where to start guessing at what that k value is. So let's take this, and we're going to use a use case using k-means clustering to cluster cars into brands using parameters such as horsepower, cubic inches, make, year, etc. So we're going to use the dataset cars data, having information about 3 brands of cars: Toyota, Honda, and Nissan. We'll go back to my favorite tool, the Anaconda Navigator with the Jupyter Notebook. And let's go ahead and flip over to our Jupyter Notebook. And in our Jupyter Notebook, I'm going to go ahead and just paste the basic code that we usually start a lot of these off with. We're not going to go too much into this code because we've already discussed NumPy, we've already discussed Matplot library, and pandas. NumPy being the number array, pandas being the pandas data frame, and Matplot for the graphing. And don't forget, since if you're using the Jupyter Notebook, you do need the Matplot library inline so that it plots everything on the screen. If you're using a different Python editor, then you probably don't need that because it'll have a pop-up window on your computer. And we'll go ahead and run this just to load our libraries and our setup into here. The next step is, of course, to look at our data, which I've already opened up in a spreadsheet. And you can see here we have the miles per gallon, cylinders, cubic inches, horsepower, weight pounds, how heavy it is, time it takes to get to 60. My card is probably on this one at about 80 or 90. What year it is. So this is, you can actually see this is kind of older cars, and then the brand, Toyota, Honda, Nissan. So the different cars are coming from all the way from 1971, if we scroll down, to the 80s. We have between the 70s and 80s a number of cars that they've put out. And let's, when we come back here, we're going to do importing the data. So we'll go ahead and do dataset equals, and we'll use pandas to read this in, and it's from a CSV file. Remember, you can always post this in the comments and request the data files for these, either in the comments here on the YouTube video or go to Simplilearn.com and request that. The cars CSV, I put it in the same folder as the code that I've stored. So my Python code is stored in the same folder, so I don't have to put the full path. If you store them in different folders, you do have to change this and double check your name variables. And we'll go ahead and run this, and we've chosen dataset arbitrarily because it's a dataset we're importing. And we've now imported our cars CSV into the dataset. As you know, you have to prep the data. So we're going to create the X data. This is the one that we're going to try to figure out what's going on with. And then there's a number of ways to do this, but we'll do it in a simple loop so you can actually see what's going on. So we'll do for I in x.columns. So we're going to go through each of the columns, and a lot of times it's important. I'll make lists of the columns and do this because I might remove certain columns, or there might be columns that I want to be processed differently. But for this, we can go ahead and take x of I, and we want to go fill NA, and that's a pandas command. But the question is, what are we going to fill the missing data with? We definitely don't want to just put in a number that doesn't actually mean something. And so one of the tricks you can do with this is we can take x of I, and then in addition to that, we want to go ahead and turn this into an integer, because a lot of these are integers. So we'll go ahead and keep it integers. And we add the bracket here. And a lot of editors will do this. They'll think that you're closing one bracket. Make sure you get that second bracket in there if it's a double bracket. That's always something that happens regularly. So once we have our integer of x of I, this is going to fill in any missing data with the average. And I was so busy closing one set of brackets, I forgot that the mean also has brackets in there for the pandas. So we can see here we're going to fill in all the data with the average value for that column. So if there's missing data, it's in the average of the data it does have. And then once we've done that, we'll go ahead and loop through it again and just check and see. to make sure everything is filled in correctly. And we'll print, and then we take x is null, and this returns a set of the null value, or the how many lines are null, and we'll just sum that up to see what that looks like. And so when I run this, and so with the x, what we want to do is we want to remove the last column because that had the models. That's what we're trying to see, if we can cluster these things and figure out the models. There is so many different ways to sort the x out. For one, we could take the x and we could go data set, our variable we're using, and use the iLocation, one of the features that's in pandas. And we could take that and then take all the rows and all but the last column of the data set. And at this time we could do values. We just convert it to values. So that's one way to do this. And if let me just put this down here and print x, it's a capital X we chose, and I run this, you can see it's just the values. We could also take out the values and it's not going to return anything because there's no values connected to it. What I like to do with this is, instead of doing the iLocation, which does integers, more common is to come in here and we have our data set, and we're going to do dataset dot columns. And remember, that lists all the columns. So if I come in here, let me just mark that as red, and I print dataset dot columns, you can see that I have my index here. I have my MPG, cylinders, everything, including the brand, which we don't want. So the way to get rid of the brand would be to do data columns of everything but the last one, -1. So now if I print this, you'll see the brand disappears. And so I can actually just take dataset columns -1, and I'll put it right in here for the columns we're going to look at. And let's unmark this and unmark this. And now if I do an x.head, I now have a new data frame, and you can see right here we have all the different columns except for the brand at the end of the year. And it turns out when you start playing with the data set, you're going to get an error later on, and it'll say cannot convert string to float value. And that's because for some reason these things, the way they recorded them, must have been recorded as strings. So we have a neat feature in here on pandas to convert. And it is simply convert objects. And for this we're going to do convert underscore numeric equals true. And yes, I did have to go look that up. I don't have it memorized, the convert numeric in there. If I'm working with a lot of these things, I remember them, but depending on where I'm at, what I'm doing, I usually have to look it up. And we run that. Oops, I must have missed something in here. Let me double check my spelling. And when I double check my spelling, you'll see I missed the first underscore in the convert objects. And when I run this, it now has everything converted into a numeric value, because that's what we're going to be working with, is numeric values down here. And the next part is that we need to go through the data and eliminate null values. Most people, when they're doing small amounts, working with small data pools, discover afterwards that they have a null value and they have to go back and do this. So, be aware, whenever we're formatting this data, things are going to pop up, and sometimes you go backwards to fix it. And that's fine. That's just part of exploring the data and understanding what you have. And I should have done this earlier, but let me go ahead and increase the size of my window one notch. There we go. Easier to see. So we'll do for I in working with x dot columns. We'll page through all the columns. And we want to take x of I, and we're going to change that, and we're going to alter it. And so with this, we want to go ahead and fill in x of I. Pandas has the fill in a, and that just fills in any non-existent missing data. And we'll put my brackets up, and there's a lot of different ways to fill this data. If you have a really large data set, some people just void out that data and then look at it later in a separate exploration of data. One of the tricks we can do is we can take our column and we can find the means. And the means is in our quotation marks. So when we take the columns, we're going to fill in the non-existing one with the means. The problem is that returns a decimal float. So some of these aren't decimals. Certainly You need to be a little careful of doing this, but for this example, we're just going to fill it in with the integer version of this. It keeps it on par with the other data that isn't a decimal point. And then what we also want to do is we want to double check. A lot of times you do this first part first to double check, then you do the fill, and then you do it again just to make sure you did it right. So we're going to go through and test for missing data. And one of the ways you can do that is simply go in here and take our x of I column. So it's going to go through the x of I column. It says is null. So it's going to return any place there's a null value. It actually goes through all the rows of each column is null, and then we want to go ahead and sum that. So we take that and we add the sum value, and these are all pandas. So is null is a panda command, and so is sum. And if we go through that and we go ahead and run it, and we go ahead and take and run that, you'll see that all the columns have 0 null values. So we've now tested and double checked, and our data is nice and clean. We have no null values. Everything is now a number value. We turned it into numeric. And we've removed the last column in our data. And at this point, we're actually going to start using the elbow method to find the optimal number of clusters. So we're now actually getting into the sklearn part, the k-means clustering on here. I guess we'll go ahead and zoom it up one more notch so you can see what I'm typing in here. And then from sklearn, we're going to our sklearn cluster, we're going to import k-means. I always forget to capitalize the k and the m when I do this. So it's capital K, capital M, k-means. And we'll go ahead and create a array, WCSS equals, we'll make it an empty array. If you remember from the elbow method from our slide, within the sum of squares, WSS is defined as the sum of square distance between each member of the cluster and its centroid. So we're looking at that change in differences as far as a square distance. And we're going to run this over a number of k-mean values. In fact, let's go for I in range, we'll do 11 of them. Range 0 of 11. And the first thing we're going to do is we're going to create the actual, we'll do it all lowercase. And so we're going to create this object from the k-means that we just imported. And the variable that we want to put into this is in clusters. And we're going to set that equals to I. That's the most important one because we're looking at how increasing the number of clusters changes our answer. There are a lot of settings to the k-means. Our guys in the back did a great job just kind of playing with some of them. The most common ones that you see in a lot of stuff is how you init your k-means. So we have k-means plus plus. This is just a tool to let the model itself be smart how it picks its centroids to start with, its initial centroids. We only want to iterate no more than 300 times. We have a max iteration we put in there. We have the nth init, the random state equals 0. You really don't need to worry too much about these when you're first learning this. As you start digging in deeper, you start finding that these are shortcuts that will speed up the process as far as the setup. But the big one that we're working with is the in clusters equals I. So we're going to literally train our k-means 11 times. We're going to do this process 11 times. And if you're working with big data, you know the first thing you do is you run a small sample of the data so you can test all your stuff on it. And you can already see the problem that if I'm going to iterate through a terabyte of data 11 times, and then the k-means itself is iterating through the data multiple times, that's a heck of a process. So you got to be a little careful with this. A lot of times, though, you can find your elbow, using the elbow method, find your optimal number on a sample of data, especially if you're working with larger data sources. So we want to go ahead and take our k-means, and we're just going to fit it. If you're looking at any of the sklearn, very common, you fit your model. And if you remember correctly, our variable we're using is the capital X. And once we fit this value, we go back to the array we made, and we want to go ahead and just append that value on the end. And it's not the actual fit we're pinning in there, it's when it generates the value you're looking for is inertia. So k-means.inertia will pull that specific value out that we need. And let's get a visual on this. We'll do our PLT plot, and what we're plotting here is first the x-axis, which is range 0, 11, so that will generate a nice little plot there, and the WCSS for our y-axis. It's always nice to give our plot a title, and let's see, we'll just give it the elbow method for the title, and let's get some labels. So let's go ahead and do PLT X label, and what we'll do number of clusters for that, and PLT Y label, and for that we can do, oops, there we go, WCSS, since that's what we're doing on the plot on there. And finally we want to go ahead and display our graph, which is simply PLT dot show. There we go. And because we have it set to inline, it'll appear inline. Hopefully I didn't make a type error on there. And you can see we get a very nice graph. You can see a very nice elbow joint there at 2, and again right around 3 and 4, and then after that there's not very much. Now, as a data scientist, if I was looking at this, I would do either 3 or 4, and I'd actually try both of them to see what the output looked like. And they've already tried this in the back, so we're just going to use 3 as a setup on here. And let's go ahead and see what that looks like when we actually use this to show the different kinds of cars. And so let's go ahead and apply the k-means to the cars data set. And basically we're going to copy the code that we looped through up above, where k-means equals k-means number of clusters, and we're just going to set the number of clusters to 3, since that's what we're going to look for. And you could do 3 and 4 on this and graph them just to see how they come up differently. It'd be kind of curious to look at that. But for this, we're just going to set it to 3. Go ahead and create our own variable, y k-means, for our answers. And we're going to set that equal to, whoops, a double equal there, to k-means. But we're not going to do a fit. We're going to do a fit predict is the setup you want to use. And when you're using untrained models, you'll see a slightly different, because usually you see fit and then you see just the predict. But we want to both fit and predict the k-means on this. And that's fit underscore predict, and then our capital X is the data we're working with. And before we plot this data, we're going to do a little pandas trick. We're going to take our x value and we're going to set x as matrix. So we're converting this into a nice rows and columns kind of setup, but we're going to have columns equals none, so it's just going to be a matrix of data in here. And let's go ahead and run that. A little warning. You'll see these warnings pop up because things are always being updated. So there's like minor changes in the versions and future versions. Instead of matrix, now it's more common to set it at .values instead of doing as matrix. But as matrix works just fine for right now, and you'll want to update that later on. But let's go ahead and dive in and plot this and see what that looks like. And before we dive into plotting this data, I always like to take a look and see what I am plotting. So let's take a look at y k-means, and I'm just going to print that out down here. And we see we have an array of answers. We have 2, 1, 0, 2, 1, 2. So it's clustering these different rows of data based on the 3 different spaces it thinks it's going to be. And then let's go ahead and print x and see what we have for x. And we'll see that x is an array, it's a matrix, so we have our different values in the array. And what we're going to do, it's very hard to plot all the different values in the array. So we're only going to be looking at the first 2, or positions 0 and 1. And if you were doing a full presentation in front of the board meeting, you might actually do a little different and dig a little deeper into the different aspects, because this is all the different columns we looked at. But we'll only look at columns 1 and 2 for this to make it easy. So let's go ahead and clear this data out of here, and let's bring up our plot. And we're going to do a scatter plot here. So PLT scatter, and this looks a little complicated, so let's explain what's going on with this. We're going to take the x values, and we're only interested in y of k-means equals 0, the first cluster. Okay? And then we're going to take value 0 for the x-axis, and then we're going to do the same thing here. We're only interested in k-means equals 0, but we're going to take the second column. So we're only looking at the first 2 columns in our answer, or in the data. And then the guys in the back played with this a little bit to make it pretty. And they discovered that it looks good if it has a size equals 100. That's the size of the dots. We're going to use red for this one. And when they were looking at the data and what came out, it was definitely the Toyota on this. We're just going to go ahead and label it Toyota. Again, that's something you really have to explore in here as far as playing with those numbers and see what looks good. We'll go ahead and hit enter in there. And I'm just going to paste in the next 2 lines, which is the next 2 cars. And this is our Nissan and Honda. And you'll see with our scatter plot, we're now looking at where y underscore k means equals 1. And we want the 0 column and yk means equals 2. Again, we're looking at just the first 2 columns, 0 and 1. And each of these rows then corresponds to Nissan and Honda. And I'll go ahead and hit enter on there. And finally, let's take a look and put the centroids on there. Again, we're going to do a scatter plot. And on the centroids, you can just pull that from our k-means, the model we created, dot cluster centers, and we're going to just do all of them in the first number and all of them in the second number, which is 0, 1, because you always start with 0 and 1. And then they were playing with the size and everything to make it look good. We'll do a size of 300. We're going to make the color yellow, and we'll label them. It's always good to have some good labels, centroids. And then we do want to do a title, PLT title, and pop up there. PLT title, because you always want to make your graphs look pretty, and we'll call it clusters of car make. And one of the features of the plot library is you can add a legend. It'll automatically bring in it since we've already labeled the different aspects of the legend with Toyota, Nissan, and Honda. And finally, we want to go ahead and show, so we can actually see it. And remember, it's inline, so if you're using a different editor that's not the Jupyter Notebook, you'll get a pop-up of this. And you should have a nice set of clusters here. So we can look at this, and we have clusters of Honda in green, Toyota in red, Nissan in purple. And you can see where they put the centroids to separate them. Now, when we're looking at this, we can also plot a lot of other different data on here as far, because we only looked at the first 2 columns. This is just column 1 and 2, or 0, 1 as you label them in computer scripting. But you can see here we have nice clusters of car make, and we were able to pull out the data, and you can see how just these 2 columns form very distinct clusters of data. So if you were exploring new data, you might take a look and say, well, what makes these different? Almost going in reverse, you start looking at the data and pulling apart the columns to find out why is the first group set up the way it is. Maybe you're doing loans, and you want to go, well, why is this group not defaulting on their loans? And why is the last group defaulting on their loans? And why is the middle group 50% defaulting on their bank loans? And you start finding ways to manipulate the data and pull out the answers you want. So now that you've seen how to use k-mean for clustering, let's move on to the next topic. Now let's look into logistic regression. The logistic regression algorithm is the simplest classification algorithm used for binary or multi-classification problems. And we can see we have our little girl from Canada who's into horror books is back. That's actually really scary when you think about that with those big eyes. In the previous tutorial, we learned about linear regression, dependent and independent variables. So, to brush up, y equals mx plus c. Very basic algebraic function of y and x. The dependent variable is the target class variable we are going to predict. The independent variables, x1 all the way up to xn, are the features or attributes we're going to use to predict the target class. We know what a linear regression looks like, but using the graph, we cannot divide the outcome into categories. It's really hard to categorize 1.5, 3.6, 9.8. For example, a linear regression graph can tell us that with increase in number of hours studied, the marks of a student will increase, but it will not tell us whether the student will pass or not. In such cases where we need the output as categorical value, we will use logistic regression. And for that, we're going to use the sigmoid function. So you can see here we have our marks, 0 to 100, number of hours studied. That's going to be what they're comparing it to in this example. And we usually form a line that says y equals mx plus c. And when we use the sigmoid function, we have p equals 1 over 1 plus e to the minus y. It generates a sigmoid curve. And so you can see right here when you take the ln, which is the natural logarithm. I always thought it should be nl, not ln. That's just the inverse of e, or e to the minus y. And so when we do this, we get ln of p over 1 minus p equals m times x plus c. That's the sigmoid curve function we're looking for. Now we can zoom in on the function, and you'll see that the function, as it derives, goes to 1 or to 0, depending on what your x value is. And the probability, if it's greater than 0.5, the value is automatically rounded off to 1, indicating that the student will pass. So if they're doing a certain amount of studying, they will probably pass. Then you have a threshold value at the 0.5. It automatically puts that right in the middle usually. And your probability, if it's less than 0.5, the value rounded off to 0, indicating the student will fail. So if they're not studying very hard, they're probably going to fail. This, of course, is ignoring the outliers of that one student who's just a natural genius and doesn't need any studying to memorize everything. That's not me, unfortunately. I have to study hard to learn new stuff. Problem statement: to classify whether a tumor is malignant or benign. And this is actually one of my favorite data sets to play with because it has so many features, and when you look at them, you really are hard to understand. You can't just look at them and know the answer. So it gives you a chance to kind of dive into what data looks like when you aren't able to understand the specific domain of the data. But I also want you to remind you that in the domain of medicine, if I told you that my probability was really good at classified things at, say, 90% or 95%, and I'm classifying whether you're going to have a malignant or a benign tumor, I'm guessing that you're going to go get it tested anyways. So you got to remember the domain we're working with. So why would you want to do that if you know you're just going to go get a biopsy because, you know, it's that serious? This is like an all or nothing. Just referencing the domain, it's important. It might help the doctor know where to look just by understanding what kind of tumor it is. So it might help them or aid them in something they missed from before. So let's go ahead and dive into the code, and I'll come back to the domain part of it in just a minute. So use case, and we're going to do our normal imports here, where we're importing NumPy, Pandas, Seaborn, the Matplot library, and we're going to do Matplot library inline since I'm going to switch over to Anaconda. So let's go ahead and flip over there and get this started. So I've opened up a new window in my Anaconda Jupyter Notebook. And by the way, Jupyter Notebook, you don't have to use Anaconda for the Jupyter Notebook. I just love the interface and all the tools that Anaconda brings. So we got our import NumPy as in P for our NumPy number array. We have our Pandas PD. We're going to bring in Seaborn to help us with our graphs as SNS. So many really nice tools in both Seaborn and Matplot library. Then we'll do our Matplot library.pyplot as PLT. And then, of course, we want to let it know to do it in line. And let's go ahead and just run that so it's all set up. And we're just going to call our data, not creative today, equals PD. And this happens to be in a CSV file. So we'll use the pd.read_CSV. And I happen to name the file, I renamed it, data for p2.csv. You can, of course, write in the comments below the YouTube and request for the data set itself, or go to the Simplilearn website, and we'll be happy to supply that for you. And let's just open up the data before we go any further, and let's just see what it looks like in a spreadsheet. So when I pop it open in a local spreadsheet, and this is just a CSV file, comma separated variables, we have an ID, so I guess they categorize this for reference, or what ID, which test was done. The diagnosis, M for malignant, B for benign, so there's two different options on there. And that's what we're going to try to predict, is the M and B, and test it. And then we have like the radius mean or average, the texture average, perimeter mean, area mean, smoothness. I don't know about you, but unless you're a doctor in the field, most of the stuff, I mean, you can guess what concave means just by the term concave, but I really wouldn't know what that means in the measurements they're taking. So they have all kinds of stuff like how smooth it is, the symmetry, and these are all float values. We can just page through them real quick, and you'll see there's, I believe, 36 if I remember correctly in this one. So there's a lot of different values they take and all these measurements they take when they go in there and they take a look at the different growth, the tumorous growth. So back in our data, and I put this in the same folder as the code. So I saved this code in that folder. Obviously, if you have it in a different location, you want to put the full path in there. And we'll just do Pandas first 5 lines of data with the data.head. When we run that, we can see that we have pretty much what we just looked at. We have an ID, we have a diagnosis. If we go all the way across, you'll see all the different columns coming across displayed nicely for our data. And while we're exploring the data, our Seaborn, which we referenced as SNS, makes it very easy to go in here and do a joint plot. You'll notice very similar to, because it is sitting on top of the plot library, so the joint plot does a lot of work for us. And we're just going to look at the first two columns that we're interested in, the radius mean and the texture mean. We'll just look at those two columns. And data equals data. So that tells it which two columns we're plotting and that we're going to use the data that we pulled in. And let's just run that. And it generates a really nice graph on here. And there's all kinds of cool things on this graph to look at. I mean, we have the texture mean and the radius mean, obviously the axes. You can also see, and one of the cool things on here is you can also see the histogram. They show that for the radius mean. Where is the most common radius mean come up and where the most common texture is. So we're looking at on each growth its average texture, and on each radius its average radius on there. It gets a little confusing because we're talking about the individual object's average, and then we can also look over here and see the histogram showing us the median, or how common each measurement is. And that's only two columns, so let's dig a little deeper into Seaborn. They also have a heat map. And if you're not familiar with heat maps, a heat map just means it's in color. That's all that means. Heat map. I guess the original ones were plotting heat density on something, and so ever since then it's just called a heat map. And we're going to take our data and get our corresponding numbers to put that into the heat map. And that's simply data.corr. For that, that's a pandas expression. So remember, we're working in a pandas data frame, so that's one of the cool tools in pandas for our data. And let's just pull that information into a heat map and see what that looks like. And you'll see that we're now looking at all the different features. We have our ID, we have our texture, we have our area, our compactness, concave points. And if you look down the middle of this chart, diagonal, going from the upper left to bottom right, it's all white. That's because when you compare texture to texture, they're identical. So they're 100%, or in this case, a perfect 1 in their correspondence. And you'll see that when you look at, say, area, or right below it, it has almost a black on there when you compare it to texture. So these have almost no corresponding data. They don't really form a linear graph or something that you can look at and say how connected they are. They're very scattered data. This is really just a really nice graph to get a quick look at your data. It doesn't so much change what you do, but it changes verifying. So when you get an answer or something like that, or you start looking at some of these individual pieces, you might go, hey, that doesn't match. According to showing our heat map, this should not correlate with each other. And if it is, you're going to have to start asking, well, why? What's going on? What else is coming in there? But it does show some really cool information on here. I mean, we can see from the ID, there's no real one feature that just says, if you go across the top line, that lights up. There's no one feature that says, hey, if the area is a certain size, then it's going to be benign or malignant. It says there's some that sort of add up. And that's a big hint in the data that we're trying to ID this, whether it's malignant or benign. That's a big hint to us as data scientists to go, okay, we can't solve this with any one feature. It's going to be something that includes all the features, or many of the different features, to come up with a solution for it. And while we're exploring the data, let's explore one more area, and let's look at data.isNull. We want to check for null values in our data. And if you remember from earlier in this tutorial, we did it a little differently where we added stuff up and summed them up. You can actually, with pandas, do it really quickly, data.isNull, and sum it, and it's going to go across all the columns. So when I run this, you're going to see all the columns come up with no null data. So we've just to rehash these last few steps, we've done a lot of exploration. We have looked at the first two columns and seen how they plot with the Seaborn, with a joint plot, which shows both the histogram and the data plotted on the XY coordinates. And obviously, you can do that more in detail with different columns and see how they plot together. And then we took and did the Seaborn heat map, the SNS heat map of the data. And you can see right here where it did a nice job showing us some bright spots where stuff correlates with each other and forms a very nice combination or points of scattering points. And you can also see areas that don't. And then finally, we went ahead and checked the data. Is the data null value? Do we have any missing data in there? Very important step because it'll crash later on. If you forget to do this step, it will remind you when you get that nice error code that says null values. Okay, so not a big deal if you miss it, but it's no fun having to go back when you're in a huge process and you've missed this step, and now you're 10 steps later and you got to go remember where you were pulling the data in. So we need to go ahead and pull out our x and our y. So we just put that down here, and we'll set the x equal to, and there's a lot of different options here. Certainly we could do x equals all the columns except for the first two, because if you remember the first two is the ID and the diagnosis. So that certainly would be an option. But what we're going to do is we're actually going to focus on the worst radius, the worst texture, parameter, area, smoothness, compactness, and so on. One of the reasons to start dividing your data up when you're looking at this information is sometimes the data will be the same data coming in. So if I have two measurements coming into my model, it might overweigh them. It might overpower the other measurements because it's basically taking that information in twice. That's a little bit past the scope of this tutorial. What I want you to take away from this, though, is that we are dividing the data up into pieces, and our team in the back went ahead and said, hey, let's just look at the worst. So I'm going to create an array, and you'll see this array, radius worst, texture worst, perimeter worst. We've just taken the worst of the worst, and I'm just going to put that in my X. So this X is still a pandas data frame, but it's just those columns. And our Y, if you remember correctly, is going to be, oops, hold on one second. It's not X, it's data. There we go. So X equals data, and then it's a list of the different columns, the worst of the worst. And if we're going to take that, then we have to have our answer for our Y, for the stuff we know. And if you remember correctly, we're just going to be looking at the diagnosis. That's all we care about is what is it diagnosed? Is it benign or malignant? And since it's a single column, we can just do diagnosis. Oh, I forgot to put the brackets. There we go. Okay. So it's just diagnosis on there. And we can also real quickly do like x.head if you want to see what that looks like. And y.head. And run this. And you'll see it only does the last one. I forgot about that if you don't do print. You can see that the y.head is just MMM because the first ones are all malignant. And if I run this, the x.head is just the first 5 values of radius worst, texture worst, parameter worst, area worst, and so on. I'll go ahead and take that out. So moving down to the next step, we've built our two data sets, our answer and then the features we want to look at. In data science, it's very important to test your model. So we do that by splitting the data. And from sklearn model selection, we're going to import train test split. So we're going to split it into 2 groups. There are so many ways to do this. I noticed in one of the more modern ways, they actually split it into 3 groups, and then you model each group and test it against the other groups. So you have all kinds of, and there's reasons for that, which is past the scope of this, and for this particular example isn't necessary. For this, we're just going to split it into 2 groups, one to train our data and one to test our data. And the sklearn model selection, we have train test split. You could write your own quick code to do this where you just randomly divide the data up into 2 groups, but they do it for us nicely. And we can actually do it in one statement with this, where we're going to generate 4 variables, capital X train, capital X test. So we have our training data we're going to use to fit the model, and then we need something to test it. And then we have our Y train, so we're going to train the answer, and then we have our test. So this is the stuff we want to see how good it did on our model. And we'll go ahead and take our train test split that we just imported, and we're going to do X and our Y, our 2 different data that's going in for our split. And then the guys in the back came up and wanted us to go ahead and use a test size equals 0.3. That's test underscore size. Random state, it's always nice to kind of switch your random state around, but not that important. What this means is that the test size is we're going to take 30% of the data and we're going to put that into our test variables, our y test and our x test. And we're going to do 70% into the x train and the y train. So we're going to use 70% of the data to train our model and 30% to test it. Let's go ahead and run that and load those up. So now we have all our stuff split up and all our data ready to go. And now we get to the actual logistics part. We're actually going to create our model. So let's go ahead and bring that in from sklearn. We're going to bring in our linear model, and we're going to import logistic regression. That's the actual model we're using. And this, we'll call it log model. Oops, there we go, model. And let's just set this equal to our logistic regression that we just imported. So now we have a variable log model set to that class for us to use. And with most of the models in the sklearn, we just need to go ahead and do a fit on there. And we use our x train that we separated out with our y train. Now let's go ahead and run this. So once we've run this, we'll have a model that fits this data, that 70% of our training data. And of course it prints this out that tells us all the different variables that you can set on there. There's a lot of different choices you can make. But for what we're doing, we're just going to let all the defaults sit. We don't really need to mess with those on this particular example. And there's nothing in here that really stands out as super important until you start fine-tuning it. But for what we're doing, the basics will work just fine. And then we need to go ahead and test out our model. Is it working? So let's create a variable yPredict. And this is going to be equal to our log model. And we want to do a predict. Again, very standard format for the sklearn library is taking your model and doing a predict on it. And we're going to test yPredict against the y test. So we want to know what the model thinks it's going to be. That's what our yPredict is. And with that, we want the capital X test. So we have our train set and our test set, and now we're going to do our yPredict. And let's go ahead and run that. And if we print yPredict, let me go ahead and run that, you'll see it comes up and it prints a nice array of B and M for benign and malignant for all the different test data we put in there. So it does pretty good. We're not sure exactly how good it does, but we can see that it actually works and is functional. It was very easy to create. You'll always discover with our data science that as you explore this, you spend a significant amount of time prepping your data and making sure your data coming in is good. There's a saying, good data in, good answers out. Bad data in, bad answers out. That's only half the thing. That's only half of it. Selecting your models becomes the next part as far as how good your models are. And then, of course, fine-tuning it depending on what model you're using. So we come in here, we want to know how good this came out. So we have our yPredict here, logModel.predictXtest. So for deciding how good our model is, we're going to go from the sklearn.metrics, we're going to import classification report. And that just reports how good our model is doing. And then we're going to feed it the model data. And let's just print this out. And we'll take our classification report. And we're going to put into there our test, our actual data. So this is what we actually know is true. And our prediction, what our model predicted for that data on the test side. And let's run that and see what that does. So we pull that up, you'll see that we have a precision for benign and malignant, B and M. And we have a precision of 93 and 91, a total of 92. So it's kind of the average between these two, 92. There's all kinds of different information on here. Your F1 score, your recall, your support coming through on this. And for this, I'll go ahead and just flip back to our slides that they put together for describing it. And so here we're going to look at the precision using the classification report. And you see this is the same printout I had up above. Some of the numbers might be different because it does randomly pick out which data we're using. So this model is able to predict the type of tumor with 91% accuracy. So we look back here, you'll see where we have benign and malignant. It actually is 92 coming up here. But we're looking at about a 92, 91% precision. And remember, I reminded you about domains. So when we're talking about the domain of a medical domain with a very catastrophic outcome, at 91 or 92% precision, you're still going to go in there and have somebody do a biopsy on it. Very different than if you're investing money and there's a 92% chance you're going to earn 10% and 8% chance you're going to lose 8%. You're probably going to bet the money, because at that odds it's pretty good that you'll make some money, and in the long run, you do that enough, you definitely will make money. And also with this domain, I've actually seen them use this to identify different forms of cancer. That's one of the things that they're starting to use these models for, because then it helps the doctor know what to investigate. So that wraps up this section. We're going to go in there and let's discuss the answer to the quiz asked in Machine Learning Tutorial Part 1. Can you tell what's happening in the following cases? Grouping documents into different categories based on the topic and content of each document. This is an example of clustering where k-means clustering can be used to group the documents by topics using bag of words approach. So if you've gotten in there that you're looking for clustering, and hopefully you had at least one or two examples like k-means that are used for clustering different things, then give yourself a 2 thumbs up. B. Identifying handwritten digits in images correctly. This is an example of classification. The traditional approach to solving this would be to extract digit-dependent features like curvature of different digits, etc., and then use a classifier like SVM to distinguish between images. Again, if you got the fact that it's a classification example, give yourself a thumb up, and if you're able to go, hey, let's use SVM or another model for this, give yourself those 2 thumbs up on it. C. Behavior of a website indicating that the site is not working as designed. This is an example of anomaly detection. In this case, the algorithm learns what is normal and what is not normal, usually by observing the logs of the website. Give yourself a thumbs up if you got that one. And just for a bonus, can you think of another example of anomaly detection? One of the ones I use it for in my own business is detecting anomalies in stock markets. Stock markets are very fickle and they behave very erratic. So finding those erratic areas and then finding ways to track down why they're erratic. Was something released in social media? Was something released? You can see where knowing where that anomaly is can help you to figure out what the answer is to it in another area. D. Predicting salary of an individual based on his or her years of experience. This is an example of regression. This problem can be mathematically defined as a function between independent, years of experience, and dependent variables, salary of an individual. And if you guessed that this was a regression model, give yourself a thumbs up. And if you're able to remember that it is between independent and dependent variables and that terms, give yourself 2 thumbs up. Summary. So to wrap it up, we went over what is k-means. And we went through also the chart of choosing your elbow method and assigning a random centroid to the clusters, computing the distance, and then going in there and figuring out what the minimum centroids is and computing the distance and going through that loop until it gets the perfect centroid. And we looked into the elbow method to choose k based on running our clusters across a number of variables and finding the best location for that. We did a nice example of clustering cars with k-means, even though we only looked at the first 2 columns to make it simple and easy to graph. You can easily extrapolate that and look at all the different columns and see how they all fit together. And we looked at what is logistic regression. We discussed the sigmoid function, what is logistic regression, and then we went into an example of classifying tumors with logistics.
Welcome to LLM Prompting with Gemini. From fundamentals to application. In today's rapidly evolving landscape of artificial intelligence, large language models, which is LLM, like Google Gemini, are revolutionizing how we interact with the technology and create content. But merely having access to these powerful models isn't enough to truly unlock their potential. You need to master the art of science of prompt engineering. This comprehensive course is designed to guide you from the foundational concepts of LLMs and Gemini's unique capabilities to advanced prompting techniques and real-world application. Whether you're a developer looking to integrate AI into your projects, a content creator aiming to streamline your workflow, or are simply curious about how to get most out of Gemini, this course will equip you with all the essential skills. We'll explore everything from basic prompt structures and controlling output parameters to sophisticated techniques like chain of thought prompting and fine-tuning for specific use cases. Get ready to transform your understanding and practically application of LLM prompting with Gemini. Now let's take a quick look at what we'll be covering today. Firstly, we'll start by introduction to Gemini. We'll cover what is it, core architecture, and key features. Next, we'll be diving into the practical side with basic prompt technologies for Gemini. These sections will lay the foundation for crafting effective prompts to get the desired outputs. Building on that, we'll explore advanced prompting techniques. Here we'll discuss more sophisticated strategies to unlock Gemini's full potential for complex tasks. Then we will see Gemini's in action for text generation and summarization. We'll explore how it can be used to create compelling content and distill information effectively. Following that, we'll delve into Gemini's for question answering and code generation. You will see how Gemini can serve as a powerful tool for retrieving information and even assisting in software development. After understanding these applications, we'll move into a crucial topic, which is evaluating and improving prompts. Because getting a great result often involves refining your approach. We'll discuss strategies to assess and enhance your prompting techniques. And finally, we'll touch upon Gemini API fine-tuning, development, and security. This will provide an overview for those looking to integrate Gemini into their applications, customize its behavior, and ensure secure implementation. Alright, let's begin. Before we can write an effective prompt, we need to understand the tools that we are working with it. The first module is all about building that foundation. Will demystify what large language models are, explore how they work under the hood, and get introduced to the capabilities of Gemini family of models. This context is a key to understanding why certain prompting techniques work the way they do. So let's just dive in. Let's start with absolute basics of what are these LLMs we hear so much about. The name large language models tells a lot. Large refers to the truly massive scale of data that they have been trained on, essentially. A significant portion of the entire internet, countless books, or millions of lines of code. Think of it as a research assistant who has read every book in the world's biggest library. Because of the vast training, their language models, meaning they can understand the intricate patterns, context, and even subtle unwritten rules of human language. They don't just process words, they grasp the intent and meaning behind them. So now, how do they perform this seemingly magical feat? At the core, the process is surprisingly simple to understand. An LLM is a powerful prediction engine. When you give it a text, it calculates the most statistically likely word to come next. It's like your phone's autocomplete, but on a superhuman scale. The real breakthrough is the transformer architecture. This is the neural network design that allows model to look upon the entire prompt and decide which word are most important to the context. That's why if you ask a long complex question, it remembers the crucial details from the beginning of your prompt to formulate a coherent and relevant answer at the end. Now let's begin with an introduction to Google's Gemini. Gemini is Google's family of advanced AI models designed to handle a wide range of complex tasks. What sets Gemini apart is that it's natively multilingual, meaning it can understand reason across different types of data, not just text but also images, audio, and video. This makes it incredibly versatile for a variety of real-world applications. Gemini also demonstrates advanced reasoning capabilities, allowing it to solve problems that require logical thinking, such as mathematical calculation and scientific analysis. These strengths make it highly effective for more demanding and knowledge-intensive tasks. In terms of use cases, Gemini is well suited for content creation, code generation, data analysis, building intelligent chatbots, and even creating brainstorming. Its a powerful, flexible nature allows users across industries to unlock new possibilities with AI. Now let's go through the Gemini models one by one. First, we have Gemini 2.5 Pro, which is Google's most powerful and advanced model. It offers top-level accuracy and performance, make it ideal for complex tasks such as coding, logical reasoning, and understanding multiple types of inputs, including both text and images. This model is designed for users who need the highest capabilities for demanding application. Next, we have Gemini 2.5 Flash, which provides a balanced mix of performance and affordability. It's well suited for high volume, low latency tasks that require some level of reasoning. This makes it great choice for business handling a lot of queries or generating large amounts of content quickly. Finally, there is Gemini 2.5 Flash Lite, which is most lightweighted and cost-efficient version. It's optimized for real-time use cases and high throughput application where fast responses times are critical. But the tasks are relatively simple. Examples include real-time chat support or basic automation. Together, these modules offer flexibility, allowing users to choose the right version based on their performance, needs, and budget. Now, let's look on how Gemini can generate photos and videos. Gemini uses Google's Imagine 2 technology for visual content creation. To generate an image, users simply needs to provide a detailed descriptive text prompt that clearly explains the desired scene or subject. You can also specify the style, for example, whether you want photorealistic image, a watercolor painting, or any other artistic effect. In addition to this style, you can mention aspects like composition, lighting, and the mood or get more accurate results while image generation is already well developed. Video generation is still emerging capability and it's being built on the same foundation principle of descriptive prompting and style control. This technology opens up exciting possibilities for creators, marketers, and educators who needs visual content tailored exactly to their needs. Now let's explore some fundamentals of prompt engineering. Prompt engineering is the art and science of the crafting effectively inputs for a large language models like Gemini. The goal is to design prompts that guide the model to produce accurate, useful, and relevant outputs. One of the key principles is to clarity and specificity. You should always direct and unambiguous in your request. Vague or confusing prompts often lead to unsatisfactory results. It's also important to provide context, which means including any relevant background information the model needs to understand the task properly. And finally, don't forget to guide the output. You can tell the model exactly what format, tone, or style you want, or even assign it as a persona to roleplay. By following these best practices, you can significantly improve the quality and reliability of AI generated content. Now let's talk about how to set up your environment to start working with Gemini. One of the easiest way is to begin by using Google's AI Studio, which is web-based tool designed for rapid prototyping and prompt experimentation. Think of it as a playground where you can test Gemini's capability in real time without needing to write any code. It's ideal for exploring different prompts, styles, text outputs, and learning how models respond. If you want to go further and integrate Gemini into your own application, you will need API access. This allows you to connect Gemini model to your software, automate tasks, or build intelligent tools. To get started with the API, you simply need to request an API key from the Google's AI developers website. Once you have that key, you can start building powerful AI-driven experiences using the Gemini. Let's walk through the first hands-on example of using a Gemini prompt. The goal here is to generate a simple 3-bullet point summary of a topic. In this course, our example prompt asks Gemini to summarize a concept of photosynthesis in 3 concise bullet points, specially tailored for a middle school student. This is great starting exercise because it helps you understand how to structure a clear, specific, and focused prompt. Once the model gives you a response, the next step is to analyze the result. Check whether the output is clearly accurate and easy to understand, and make sure it follows the requested bullet points format. Exercise like these helps you build prompt engineering skills and give you a better sense of how to control and guide Gemini's outputs. So we'll see how to generate a similar prompt here and give an introduction to the interface of Google Gemini. So to start with your journey of Google Gemini, you just need to search for Google AI Studio and click on the first link that appears. So here, as you can see, we have multiple things, but first they're going to ask you to accept few terms and conditions. You can just accept that. And here in your left side, you can see we have chatting, streaming, generating media, building history, and enabling saving. These are the options you get in your left side. You can generate any high scavenger hunt. There are few examples, URX context fields and other examples. And here you can see we have get API key. This is for developers who want to develop an app. They can easily just by one click get the API access, and we have a studio dashboard and the documentation regarding this Gemini. And here you can set to what version you prefer, and the costs are also being displayed here, and the features are also given, so you can choose accordingly whichever is appropriate for you. And we have token count, and you can set the temperature as discussed, and we have media revolution, which is low, medium, or by default, and we have thinking mode also set thinking budget and structured output and other options that you can use it. Now let's start with the chat prompt. So as discussed, we want photosynthesis to be explained with 3 bullet points. So let's give the same prompt and see the answer. So as mentioned, I've given the prompt of summarize the concept of photosynthesis in 3 concise bullet points specifically tailored for a middle school student. So let's see how this gives us. So here you go, here's the summary of concept of photosynthesis in 3 concise bullet points, and it actually has given me the entire answer in 3 points, making sure each has a heading to it. So we have plants make their own food to survive, and the meaning of the entire paragraph, and then similarly the next 2 points. And if you come here, the sources from where this information was also given, and if there are any other suggestions that you can give, you can go ahead. Next, we have to generate media. You can also stream, where you can talk. It's a voice generated architecture, and then we can generate media. Suppose let's give an example of creating media. Here are some examples which they have already created. Video is an ongoing process in Gemini, but photos, it's a fully fledged one. So it uses Imagen 2, which we'll be discussing in the later one. So let's say give me an image of, say, basic mountains with a river during the sunset or sunrise. So let's see what kind of a image it will generate. So as you can see, it has given me a beautiful picture which looks so natural with mountains and the road. If you want to specify a specific style, like give me in the retro format or a black and white image, you can mention that in the prompt and get most beautiful painting as the desired output that you want. Now that we have a solid understanding of what Gemini AI and the environment will be working in, it's the time to start communicating with it. This module is where the rubber meets the road. Will cover the fundamental everyday prompting techniques that will inform the basics of everything else we do. We'll learn about zero shot and few shot prompting, how to structure our request, and how to use parameters to control the AI output. Mastering these basics is the first step to getting predictable, high quality results. Let us understand what zero shot prompting means. Zero shot prompting is when you give the model a direct instruction without showing any prior examples of what you are expecting. It relies entirely on model pre-existing knowledge and training to understand and compute the task. This approach is useful when you want a quick and straightforward response. For instance, if you ask translate the phrase "Hello, how are you?" into Spanish, the model can handle that request even without being any given examples. While zero-shot prompting is fast and simple, it works best for tasks the model is already familiar with and doesn't require much context for customization. Now let's take a look into few-shot prompting. In this approach, you will provide the model with a few examples or shots of the task you want to be performed. These examples are included directly in the prompt and help the model understand the desired format, tone, and logic. By seeing how the task is done, the model can better mimic the pattern when generating its own response. For instance, if you are providing example, a movie was brilliant, sentiment is positive, and I didn't like the food, sentiment is negative. The model learns how to label sentiment of statement. Few short prompting is especially useful when the task is a bit more nuanced or when you want to influence the style and structure of the output. To effectively interact with AI models, it's crucial to understand prompt structure, which typically comprises three key elements. The instruction, which is you clear command on your specific task you want the model to perform like. Write an email, the context providing essential background information that helps the model understand the bigger picture, such as to the team about the new project deadline. And finally, the input data, which is specific text or items to be processed. For example, the old deadline was July 20th and the new is July 27th. By combining these precious instructions with the relevant context and necessary input data, you guide the model to generate the accurate and tailored responses. To fine-tune Gemini's response, we control its output using three key parameters. Temperature ranging from 0 to 1 direct manages the randomness of the output, making it more predictable and factual at lower values. Top P, also from 0 to 1, controls the selection of words by considering a smaller pool of most probable words, serving as an alternative way to influence the diversity of the output. And max output tokens, which sets a strict limit on the length of the generated response, allowing you to manage verbosity. By adjusting these parameters, you gain significant length of Gemini's generated content. For this practical exercise, we'll begin by providing Gemini with a block of text which will serve you as a context, effectively giving the model the background information it needs. Following this context, your next step is to add clear instructions and a specific question which tells the Gemini exactly what you want it to do with the provided text. And illustrated in the example prompt structure, you will present your text document as a context as the following user question to the elite and answer from the model, allowing you to observe how efficiently context and clear instruction leads to precise responses. To make this concrete, let's look up one example on how this combined prompt structure. Imagine you have a short piece of text like displaying the following context. Now, as you can see, I've given a prompt which goes like the new product launch is scheduled for September 15 with an internal meeting set for August 20th to finalize marketing material. Customer feedback on the beta version has been overwhelmingly positive, particularly regarding its user-friendly and robust security features, which will be highlighted in all promotional campaigns. This is the context that we'll be giving. Now, based on this context, we need to provide a clear instruction and a question. For instance, if you want to know about the product's key strengths for marketing purposes, you can go and write the same. So now I would want to know the main selling points of a new product. So I'll give a question and answer format. So we have, based on the text above, identify the main selling points of a new product that should be highlighted in promotional campaigns. Now here we have given a brief context and a question answer basis followed by it. So we'll see how Gemini recreates it or gives the answer. So here you can see we have, based on the text provided, the main selling point of a new product that should be highlighted in promotional campaigns are its user-friendly interface and robust security features. This demonstrates how providing clear context and specific instructions allow Gemini to extract preciously the information you need. Now you can try with different types of context and a question answer basis and get the answers for whatever is required. Okay, now we have covered the basics and can now get a reliable response for straightforward tasks. In this next module, we are going to level up these advanced techniques. These advanced techniques are what separates a casual user from a true prompt engineer. We'll explore methods like chain of thought or encourage reasoning, self-consistency to improve reliability, and also power using templates for scalable solution. This is where we unlock Gemini's ability to solve true complex problems. Chain of COT prompting is a powerful technique that encourages the model to break down a problem into logical intermediate steps rather than just providing a direct answer. This is simply triggered by adding phrases like think step by step or show your work to prompt. The remarkable results in dramatic improvements in the model's performance on complex reasoning, logic, and mathematical problems as it forces the AI process information sequentially. A significant added benefit is that it exposes the model's underlying reasoning process, making its decision making transparent and much easier to debug or understand its failures. Self-consistency is advanced prompting technique designed to improve the readability of answer and complex questioning by leveraging the model's own capacity for diverse reasoning. This achieved by first asking the same question multiple times, typically using higher temperature to encourage varied responses and different chain of thought paths. Subsequently, from these wire-generated outputs, you then select the most frequent or consistent answer, thereby increasing confidence in the final result by effectively having the model cross-verify its own reasoning across multiple. Knowledge generation prompting is technique that goes beyond simple information retrieval, focusing instead on synthesizing and structuring information onto comprehensive new content. You would see use it to create detailed guides, explanation, or study notes from scratch, asking the model to generate and organize information for a given topic. For example, a prompt like generate detailed study guide on cause of World War I include key figures, alliance, and pivotal events, structures with heading and bullet points. This prompt demonstrates how to guide the model to produce well-organized, in-depth knowledge rather than just a brief answer. To ensure consistent and high-quality outputs, particularly when scaling operation, we employ prompt templates. This involves creating reusable structure prompts that incorporate placeholders, variables, guaranteeing that every prompt adheres to the same high-quality format. This method is ideal for tasks like summarizing numerous customers' reviews or generating repetitive reports as it significantly minimizes human error in the prompt. For instance, a template should look like summarize the following customer review into the problem and resolution section, which is reviewing the customer's review text, where the placeholder is dynamically replaced, ensuring a standardized approach every time. Let's apply some of these concepts in real-world scenario through case study. Consider a common problem, a chatbot that frequently gives generic or incorrect answers to complex users to issue. To address this, we can strategically combine the prompting techniques we have discussed. Chain of thought prompting can be used for troubleshooting steps, guiding the chatbot to think logically. For example, first check out the power of a few short prompting is ideal for ensuring the chatbot handles sentiment and tone correctly by providing examples of desired conversational style. Lastly, prompt templates are invaluable for standardizing response to common repetitive queries like what are your business hours, ensuring consistent and accurate information for routine interactions. We have built a powerful toolkit of prompting techniques from basic to advanced. Now let's put that toolkit to work. In this module, we'll focus on two of the most common and valuable applications for Gemini: creating text generation and summarization. We'll look at how to prompt for different styles and tones, from poems to blog posts, and explore the different strategies of considering large amounts of information effectively. This is all about turning technical skills into practical content. Beyond factual tasks, can also be an excellent creative partner for brainstorming, writing, and helping you generate ideas and build narratives. To effectively leverage its abilities, you need to provide clear parameters. Repeat. Start by defining the genre, whether it's fantasy or mystery, to set up the world. Next, the desired tone, such as humorous, suspensive, or to shape the emotional landscape of your writing. Crucially, provide a brief description for your characters and setting, giving Gemini concrete elements to work with. Finally, offer some plot points like starting the scene or core conflict to resolve to give AI clean direction for the stories. By structuring these input with these elements, you guide Gemini to produce creative outputs that align with your vision. When it comes to summarization, there are two primary techniques: extractive summarization and abstractive summarization. Extractive summarization directly pulls key substances and phrases from the source text, ensuring high factual accuracy with no new information introduced, making it ideal for precision critical documents like legal texts and technical papers. In this contrast, we have abstractive summarization, which generates entirely new sentences to capture main ideas of the source, resulting in more fluent and human-like summary that is the best suited for articles, reports, and conversations where consciousness and natural language flow are prioritized over direct quotation. A key aspect of guiding AI for writing is to explicitly instruct the model to adopt a specific persona or style, allowing you to control the output's characters. This means you can go just beyond telling it what to write and also tell it how to write. For example, you can tell it, write in the style of 19th century naturalist, or explain this concept in the way 5-year-old would understand. You can also guide its overall feel by asking it to adopt a formal academical tone or conversely rewrite this to be more casual and friendly. By providing these specific stylist and tonal cues, you ensure the generated text perfectly matches the intent, audience, and purpose. Gemini can streamline your content creating process by serving you as a partner through the entire workflow. This is typically begins with ideation, where you can brainstorm blog posts, titles, and outlines directly with Gemini to kickstart your creative processes. Next comes drafting, where you can utilize a detailed prompt to generate a comprehensive first draft of your content, saving significant time. Following, Gemini can be leveraged to rewrite section, meticulously check for grammar, and fine-tune the tone to perfection. Finally, for repurposing, you can effectively ask Gemini to transfer your finished article into various formats like social media posts, emails, newsletters, or concise summaries, maximizing your content's reach and impact across different platforms. For our next practical exercise, we are challenging Gemini to generate a 500-word blog post demonstrating its ability to create a structured content. To achieve this, we will provide a specific guidelines, which is the topic will be the benefit of remote work. The target audience is small business owners, guiding the perspective and language. The desired structure includes an introduction, 3 main benefits with examples, and conclusion, ensuring a logical flow. And finally, the tone should be professional but approachable. To set the overall style, by giving Gemini these precise parameters, we can expect a high tailored and useful output for our specific content need. So let's check what Gemini AI will answer us. So as you can see here, I'm copying and pasting the exact prompt that we had to execute. It's generate a 500-word blog post demonstrating its ability to create structure and content. To achieve this, we'll provide specific guidelines, and we have all the instructions regarding the tone and whose audience are targeted, etc. So we'll just see how it generates. So here you can see there is a heading for the essay, and it is given point by point of all the information that we needed to note down, and the tone will be for professionals and a little bit casual as according to the prompt. Having just explored Gemini's creativity and linguistic capabilities, we now pivot to the more analytical and logical side. This module focuses on two transformative use cases: building robust question and answering system and generating code. Learn how to make Gemini answer questions based on specific documents and how to prompt it to become a powerful coding assistant. These applications have a potential to dramatically boost productivity and automate complex information retrieval tasks. Building a robust question answering system with Gemini goes beyond simple Q&A by explicit providing context, often referred to as retrieval augmented generation or RAG. This process first involves three key steps. First, retrieve relevant documents that contain the necessary information to answer the user's query. Second, provide these retrieved documents as context within the prompt to Gemini. And finally, ask Gemini to answer the user's questions strictly based only that provide context, ensuring the response grounded in your specific data rather than models generation training knowledge. Gemini can handle a wide array of question types, and understanding how to frame your prompt for each yield the best results. Question, repeat. For factual question, you ask simple for direct piece of information like what is the capital of Australia. When seeking understanding, use explanatory prompts such as explain the concepts of black holes in simple terms. For comparative analysis, instruct the model to compare and contrast Python and Java for web development. Lastly, contextual question always refer back to provided information. For example, based on provided article, what is the author's main argument, ensuring the answer is grounded to your specific data. Gemini is highly capable of generating code in dozens of languages, including Python, JavaScript, C++, SQL, making it a powerful tool for developers. To effectively use it code for generation, you should describe the function or program you want to execute in plain English, clearly outlining its purpose and expected behavior. It's also crucial to specify the programming language and any libraries you intend to use, providing the model with necessary context for accurate code. For instance, a clear prompt would be write a Python function that takes a list of numbers and returns the average, which is directly guided by Gemini to produce a desired code. Beyond generating new code, Gemini can be valuably debugging pattern, significant speeding up your deployment process. When faced with any issue, you can simply paste the code that has no error, then describe the error message or an unexpected behavior you're observing. Subsequently, you clearly ask Gemini to find the bug in this code or explain error message in the plain terms of leveraging its understanding of programming language. Furthermore, you're not limited to just fixing errors. You also request code optimization to make it more efficient or ask for addition of comments to improve readability and maintainability. Let's look at the practical application, a case study. Studying involved deploying a code assistant tool, especially to create a VS Code extension that helps deployers. This powerful tool integrates Gemini to provide several key features for code generation. Users can type comment and Gemini generates a corresponding code. For explanation, deployers can highlight code and Gemini explain what it does. And for debugging, users provide their code and an error and Gemini suggests to fix it. Crucially, all these intelligent features are implemented by effectively calling the Gemini API with carefully crafted prompts, showcasing how targeted prompting can build complex real-world AI applications. So far, we have learned how to build a wide variety of things with Gemini, but a critical question remains: how do we know if our prompts are any good? This module is arguably one of the most important. We'll shift our focus on creating prompts to refining them. We'll discuss how to define a clear matrices for success, how to A/B test different prompts version, and how to analyze failures to create a continuous cycle of improvement. This is how we go from writing good prompts to engineering great ones. When evaluating the quality of AI's response, especially in the context of a prompt, we consider several components to determine if a prompt is good. These key criteria include accuracy, where we assess if the answer is factually correct, and for system if it aligns perfectly with the source material. Fluency checks if the language used natural, grammatically correct and easy to read, ensuring a smooth user experience. And relevance, determining if the response directly addresses the user prompt, adheres to all given instruction, thereby fulfilling the user's intent effectively. To systematically optimize your prompts and ensure the best performance for a given task, we employ A/B testing prompts. This creates a four-step process. First, create two prompts A and B designed for exact same task. Second, run the identical set of inputs through both prompts to ensure a fair comparison. Third, compare the output matrices using your predefined such as accuracy, fluency, or relevance to objectively assess their quality. And finally, choose the prompt that consistently performs better based on your evaluation, allowing for data-driven prompt refinements. To continuously improve your interactions with Gemini, it's crucial to analyze its response, particularly by looking for patterns and failures. There are several common issues to watch for: hallucinations, where the model makes up facts that are not true; following problems indicating Gemini ignored a part of your prompt, such as specific format requirements; verbose brevity issues, meaning the output was either too talkative or too for your needs; and tones mismatch, where they generated text inappropriate style or voice. By recognizing these patterns, you can refine your prompts and patterns to guide Gemini towards more accurate and useful outputs. Understanding that prompt engineering is a continuous cycle, not one-time task, is fundamental for achieving optimal results with AI models. This iterative prompt refinement process involves a systematic loop. First, you write an initial prompt, then you test it with various inputs to see how it performs across different scenarios. Next is to analyze the failures or areas where the response didn't meet exceptions. Based on the analysis, you'll refine the prompt to address those shortcomings, and finally you repeat this entire process until the prompt consistently yields the desired high quality outputs. To efficiently manage and scale your prompt engineering efforts, especially in professional environments and platforms, are essential. These specialized tools are designed to help you manage, test, and deploy prompts systematically. Their key features include prompt versioning and history, allowing you to track changes and revert to previous iteration; robust A or B testing, and evaluation frameworks for empirical comparing prompts performance; capabilities for seamless collaboration with team members on prompt development; and crucial functionalities for monitoring prompt performance directly in production, ensuring ongoing optimization and reliability. We have reached our final module, which covers the crucial last mile of taking a great prompt from the prototype to the real world product. We'll discuss the technical details of using the Gemini API, when to consider fine-tuning, and how to deploy your application using cloud technologies. Crucially, we'll also cover the non-negotiable topics of prompt security to prevent misuse and ethical principles of responsible AI development. This section is all about bringing your ideas to life safely and effectively. To integrate Gemini's powerful capabilities into your own application, you will utilize the Gemini API, which serves as a direct communication channel with the Gemini models. This interaction begins with authentication, typically using API keys to securely identify your project and control access. For usage, you send a structured request comprising your prompt and any desired parameters like temperature or maximum output tokens, and in return you will receive a structured response from the model. To simplify this integration process, SDKs are readily available for popular programming languages such as Python, Go, and Node.js, abstracting away much of all the complexity of direct API calls. Beyond advanced prompting techniques, fine-tuning Gemini represents the process of further training the model on your own specific curated data, thereby adapting it to particular domain, writing style, or specialized tasks. While effective prompting goes a long way, fine-tuning can lead a significant higher quality results for very specialized use cases where generic knowledge isn't sufficient. This powerful technique, however, requires a meticulously curated dataset of high quality examples that truly represents the desired output and domain, as a quality of the fine tuning heavily depends on the data provided. Once you have developed your Gemini powered application, the next crucial step is deploying Gemini to make your application available to users. This primarily involves leveraging cloud platforms such as Google Cloud, which provides a robust infrastructure necessary for hosting your application and managing its backend. Alternatively, for a more cost-effective approach to running the background code that can call Gemini API, you can utilize serverless functions like Cloud Functions, where you can only incur cost when your code is actively executed, offering a scalable and efficient development model without managing servers. Once your Gemini powered applications goes live, continuous monitoring Google Gemini becomes absolutely essential to ensure optimal performance and operational health. There are several key things to track. API latency to ensure response are delivered quickly. Error rates to identify any failing API calls and underlying issues. Cost to vigility monitor your API usage and manage your budget effectively. And critically response quality, which involves collecting users' feedback on running automated checks to confirm the AI's output remaining accurate, relevant, and useful over the time. Prompt security is a critical aspect when deploying any public-facing large language model application to prevent maliciously manipulation. The primary concerns is prompt injection, which occurs while malicious users input text designs to trick the model into ignoring its original instructions or performing united actions. To defend against this, effective techniques include using strong wounded instructions within your system prompts such as ignore all previous instructions as well as robust input sanitization and validation to filter out harmful input and crucially using delimiters to clearly separate your instructions from the user's input, creating a boundary that the model is less likely to breach. Deploying AI is a special. Now let's discuss about the ethics in AI development. Deploying AI, especially powerful models like Gemini, carry significant responsibility, making ethics in AI development a paramount concern. This field guides by several key principles such as fairness and biases requires us to ensure the model doesn't generate biased or unfair outputs, prompting equitability treatment. Transparency means being clear with users about when they interact with an AI, forecast trusting. Safety involves implementing robust safeguards to prevent the generation of harmful or dangerous content. Finally, accountability necessitates having clear process for addressing issues and incorporating users' feedback, ensuring we can respond responsibly to any challenges that arise.
Have you ever wondered how AI models can understand and process multiple types of inputs, like text, images, and audio simultaneously? Hello, everyone. Welcome to our deep dive into multimodal prompting, a transformative approach that's reshaping the landscape of artificial intelligence. My name is Basil Duklala, and in this video, we'll explore what multimodal prompting is, why it's essential, and how it's applied across various industries. Let's embark on this journey to uncover the future of AI together. Here's our agenda. Introduction to multimodal prompting. Evolution of prompting. Core concepts of multimodal prompting. Tools and platforms that support multimodal prompting. Use cases and applications. Getting started with multimodal tools. And then we'll take a look into simple multimodal prompts in action. And we'll have a deep dive or step-by-step prompt building. Last but not least, we'll look into experimenting with different use cases. You might be wondering, what is multimodal prompting? Multimodal prompting is a technique that allows AI models to interpret and respond to input from more than one modality, like combining text, images, audio, or video. Instead of just reading text, the model can basically analyze visuals, sounds, or other forms of data to generate richer, more context-aware responses. It basically mimics how humans process information. Now, why it matters and where is it used? Multimodal prompting matters because the real world isn't just text-based. We live in a sensory-rich environment, and multimodal AI helps machines understand that. It's used in applications like image captioning, video analysis, interactive chatbots with visual context, and even healthcare diagnostics where images and notes are combined. In addition, multimodal prompting is very useful for content creation and recommendation. Let's talk about the evolution of prompting. Let's learn about the evolution of prompting, from text-only models to multimodal models. Prompting has evolved from simple text inputs to complex multimodal interactions. Today's models can understand and respond to combinations of text, images, audio, and more for deeper context. Prompting began with text-only models like GPT-2, which responded solely to written input. They basically leveraged NLP, which stands for Natural Language Processing. Over time, models evolved to process images, audio, and even video, giving rise to truly multimodal systems that can interpret and connect across different types of information. How models understand and process multiple input types. Modern multimodal models have specialized architectures, such as vision transformers, multimodal neural networks to process different inputs. They are also trained on paired data, like images with captions or videos with transcripts. These models learn how different modalities relate to each other, enabling them to take in multiple types of inputs and generate informed outputs that bridge those sensory channels. Cross-model attention helps models link relevant features across inputs, enhancing context and accuracy. At the core, these models use shared embedding spaces to map inputs like text and images into a common understanding. For example, a picture of a dog and the word dog are brought close together in this space, allowing the model to reason across formats in a unified way. Let's talk about core concepts of multimodal prompting. Modalities are different types of information we can give to AI, like text, pictures, sound, or video. They help the model understand things the way humans do, through multiple senses. These senses are text, with written language input like prompts or documents; image, visual content such as photos, charts, or drawings; audio, sound-based input like speech or music; and video, time-based visual and audio content combined. In multimodal prompting, in unimodal prompting, the model receives one type of input, typically text. In contrast, multimodal prompting involves multiple types, like combining a question with an image or a diagram. So, input modalities include one or more types. This requires the model to integrate different streams of information and make connections between them. So let's recap the key difference between unimodal and multimodal prompting. First, we've got the input type. Unimodal prompting has one single type and typically is text. Multimodal prompting has multiple types and it could be text, images, audio, etc. Second, context depth. Unimodal prompting is limited to one form of input. On the other hand, multimodal prompting is richer in context and has combined inputs. 3. Use cases. Unimodal prompting can only be used on text-based tasks, such as writing. Multimodal prompting can be used in multiple tasks and complex ones, like image analysis, and speech to text. 4. Understanding. Unimodal prompting is linear and it's language focused. Multimodal prompting, on the other hand, is cross-modal and human-like. Despite its potential, multimodal prompting comes with challenges. Models can misalign inputs, generate hallucinations, or be biased towards dominant modalities. Input format issues from the model misinterpreting poorly formatted inputs. 2. Limited modal support. Not all models handle every modality. 3. Ambiguity inputs. Unclear inputs can lead to inaccurate responses. 4. High computational load. Multiple modalities require more resources. There's also a lack of standard benchmarks, and combining training data from different formats can be resource intensive. Let's discuss tools and platforms that support multimodal prompting. First, we've got one of the most popular generative AI tools, ChatGPT. Specifically, ChatGPT with Vision. This version of ChatGPT can understand and analyze both text and images. It's useful for tasks like generating captions or answering questions about visual content. If you're not familiar with ChatGPT, it's basically an AI chatbot based on OpenAI's GPT, which stands for Generative Pre-trained Transformer Models. It can understand and generate human-like text for tasks like writing, coding, summarizing, tutoring, and casual conversations. And now it has multimodal capability. It's widely used in education, business, and creative work. ChatGPT can handle multiple ChatGPT can handle multimodal inputs by combining image recognition with text generation, allowing users to ask questions or generate text based on images. It processes the image and merges it with text for a complete response. The second next popular tool is Gemini by Google. Gemini is Google's family of advanced AI models designed to rival GPT. It's multimodal, meaning it can handle text, images, code, and other inputs. Gemini powers tools like Bard and Google Workspace AI, aiming to provide accurate, integrated assistance across Google's ecosystem. It helps with complex interactions like visual-based search and multimodal content generation. It's designed for broader, context-aware AI applications. It handles multimodal inputs very quickly and uses advanced fusion models to integrate text, image, and video inputs, understanding relationships between them for more context-aware responses and generation. Next, Claude is a conventional AI developed by Anthropic, focused on safety, helpfulness, and transparency. It's known for its thoughtful responses and is designed to be steerable and aligned with user intentions. It can also integrate text, images, and documents, allowing for in-depth analysis and interaction with various input formats. Claude is a strong competitor to ChatGPT and excels at tasks like PDF creation, Q&A, and content summarization. Claude also does a good job of breaking down each modality for text, images, and documents separately. It processes them and then combines them for tasks like document analysis or multi-source content generation. DALL-E by OpenAI is an AI model that generates high-quality images from text descriptions. It's known for its detailed, creative outputs and is integrated into ChatGPT's interface for users on the Plus plan. It basically accepts textual prompts and translates them into relevant images, seamlessly merging descriptive text with visual output for creative image generation. It's got a lot of tools that help you build a scene and will turn it into an image from realistic to fantastical. Let's talk about use cases and applications in multimodal prompting. We have users that can upload images, such as diagrams and charts, and then ask questions about them, with AI providing context-aware answers. Next, AI creates articles, social media posts, or marketing copy based on both text and image inputs. In terms of content generation applications, AI can create articles, social media posts, and marketing copy based on both text and image inputs. For product tagging, e-commerce platforms use images and descriptions to generate accurate product tags and recommendations. Multimodal prompting can also be effective for interactive education. AI helps in learning by analyzing images, videos, and text to provide interactive educational content. It's also useful for accessibility. It assists visually impaired users by converting visual content, such as photos and infographics, into descriptive text. Let's see how we can access and set up a basic multimodal prompting environment. First, choose a platform. You can sign up for access to platforms like ChatGPT or Gemini. Next, install required tools and install necessary libraries. Then, obtain API keys for the platform and configure your environment. Then, ensure inputs are properly formatted and compatible for the application. Lastly, test with basic prompts or run simple multimodal tasks. Let's talk about the required tools and input formats. First, you need an API access. Second, install some Python libraries and have a Jupyter Notebook. Also, you can use cloud platforms, although some of these applications can be done using your local machine. Here's a list of the input formats that you can leverage. We've got text, image, audio, and video. Let's jump into a demo to show how LLMs can be used for multimodal tasks. In this demo, we'll be using ChatGPT to showcase its powerful multimodal capabilities. Keep in mind that most LLM tools like Gemini and Claude can also provide similar capabilities that I'm about to show. For ChatGPT, many of the capabilities we're about to showcase are only available in ChatGPT Pro. It's available for a limited number of prompts in the free version. If you want to leverage the full capabilities, you'll need to subscribe to ChatGPT Pro. First, after you log in to ChatGPT, you need to make sure that you have GPT-4 activated. Next, you'll see that there's a plus button that is popping up where I can add media. But before we do this, let's generate media using text prompts. Write a 3-sentence summary of the plot of Inception like you are explaining to a 10-year-old. You can see ChatGPT gave us a response with a concise 3-sentence summary of the plot of Inception. So I'll read the first sentence. Inception is about a man named Cobb who goes into people's dreams to steal their secrets like a spy in their sleep. let's take things to next step. I'm going to ask ChatGPT to generate a poster based on the description in cartoon style. Let's make sure that it's pointing to the description above. Go ahead and run this, and we'll give it a few seconds to generate the image. Keep in mind that ChatGPT sometimes runs under a heavy load of requests, and sometimes image generation takes time. Image generation is done. You can see ChatGPT generated an output according to my description, a cartoon-like poster of Inception. Next, we'll show ChatGPT's ability to analyze images. I find this task very useful for analyzing complex visuals, such as stock charts. I'll click on the plus sign and then add photos and files, select your photo, and then insert the following prompt. Analyze the support and resistance levels of the attached 4-hour interval chart of Google. You can see that ChatGPT was able to analyze the chart for me in an instance and was able to give me multiple support levels and resistance levels with their description. Let's do another example of image analysis. I'm going to click the plus sign here and upload a hand-drawn chart. And here's my prompt. Explain the attached image of a diagram step by step. For reference, here's the image and here's the explanation. Start the process. The program begins execution. Step 1, input value. Gives me a check for Stack Overflow. And then it explains the rest of the steps according to the diagram. It was also able to analyze the gist of the diagram. It is a standard stack push operation with overflow checking, where it prevents adding data when the stack is full and confirms insertion when space is available. It can also offer an equivalent code in Python or C. That was a good example for visual and text reasoning. Let's increase the level of difficulty of this type of task by giving it a mathematical problem. I'll click on the plus sign again, add photos, and select my image. And I'll use the following prompt. What is the answer to the math problem in the attached image? Here's the image for reference. Find the sum of the series. And you can see that ChatGPT is generating LaTeX or Markdown type of syntax in the background so it can display the mathematical syntax and Greek symbols properly. Not only was it able to solve for these problems, but also was able to give me a step-by-step instructions on how to solve for it. Plus, it recognized that we have 2 problems, not just one, to solve for. In this last example, we're going to do the opposite of multimodal prompting. Instead of providing an image, we're going to ask ChatGPT to generate a complex image based on my description. Provide a detailed process for data science and feature engineering for the diabetes healthcare dataset. The diabetes healthcare dataset is a popular dataset available online, so ChatGPT will be able to understand exactly what I'm looking for. Here we can see step-by-step instructions of the process, along with Python code on how to run the analysis, such as EDA, outlier detection, multivariate analysis, and then feature engineering as requested, all the way to modeling and providing proper evaluation metrics. After getting the steps in text format, I want ChatGPT to build a visual diagram of those steps.
So what is deep learning? Deep learning is a subset of machine learning, which itself is a branch of artificial intelligence. Unlike traditional machine learning models, which require manual feature extraction, deep learning models automatically discovers representation from raw data. So this is made possible through neural networks. particularly deep neural networks, which consist of multiple layers of interconnected nodes. So these neural networks are inspired by the structure and the function of human brain. Each layer in the network transforms the input data into more abstract and composite representation. For instance, in image recognition, the initial layer might detect simple features like edges and textures, while the deeper layer recognizes more complex structure like shapes and objects. So one of the key advantages of deep learning is its ability to handle large amount of unstructured data, such as images, audios, and text, making it extremely powerful for various applications. So stay tuned as we delve deeper into how these neural networks are trained, the types of deep learning models, and some exciting applications that are shaping our future. Types of deep learning. Deep learning AI can be applied supervised, unsupervised, and reinforcement machine learning using various methods for each. The first one, supervised machine learning. In supervised learning, the neural network learns to make prediction or classify that data using labeled datasets. Both input features and target variables are provided, and the network learns by minimizing the error between its prediction and the actual targets. A process called backpropagation. CNN and RNN are the common deep learning algorithms used for tasks like image classification, sentiment analysis, and language translation. The second one, unsupervised machine learning. In unsupervised machine learning, the neural network discovers patterns or clusters in unlabeled datasets without target variables. It identifies hidden pattern or relationship within the data. Algorithms like autoencoders and generative models are used for tasks such as clustering, dimensionality reduction, and anomaly detection. The third one, reinforcement machine learning. In this, an agent learns to make decisions in an environment to maximize a reward signal. The agent takes action, observes the records, and learns policies to maximize cumulative rewards over time. Deep reinforcement learning algorithms like deep Q networks and deep deterministic polygradient are used for tasks such as robotics and gameplay. Moving forward, let's see what are the artificial neural networks. Artificial neural networks, ANNs inspired by the structure and the function of human neurons, consist of interconnected layers of artificial neurals or units. The input layer receives data from the external resources and it passes to one or more hidden layers. Each neuron in these layers computes a weighted sum of inputs and transfers the result to the next layer. During training, the weight of these connections are adjusted to optimize the network's performance. A fully connected artificial neural network includes an input layer or more hidden layers and an output layer. Each neuron in a hidden layer receives input from the previous layer and sends its output to the next layer. So this process continues until the final output layer produces a network response. So moving forward, let's see types of neural networks. So deep learning models can automatically learn features from data, making them ideal to tasks like image recognition, speech recognition, and natural language processing. So the most common architecture in deep learnings are the first one, feed-forward neural network, FNNs. So these are the simplest type of neural network where information flows linearly from the input to the output. They are widely used for tasks such as image classification, speech recognition, and natural language processing, NLP. The second one, convolutional neural network, designed specifically for image and video recognition. CNNs automatically learn features from images, making them ideal for image classification, object detection, and image segmentation. The third one, recurrent neural networks, RNNs, are specialized for processing sequential data time series and natural language. They maintain an internal state to capture information from previous input, making them suitable for tasks such as speech recognition, NLP, and language translation. So now let's move forward and see some deep learning application. The first one is autonomous vehicle. Deep learning is changing the development of self-driving car. Algorithms like CNNs process data from sensors and cameras to detect objects, recognize traffic signs, and make driving decisions in real time, enhancing safety and efficiency on the road. The second one is healthcare diagnostic. Deep learning models are being used to analyze medical images such as X-rays, MRIs, and CT scans with high accuracy. They help in early detection and diagnosis of diseases like cancer, improving treatment outcomes and saving lives. The third one is NLP. Recent advancement in NLP powered by deep learning models like Transformer, ChatGPT have led to more sophisticated and human-like text generation, translation, and sentiment analysis. So application include virtual assistant, chatbots, and automated customer service. The fourth one, deepfake technology. So deep learning techniques are used to create highly realistic synthetic media known as deepfakes. While this technology has entertainment and creative application, it also raises ethical concern regarding misinformation and digital manipulation. The fifth one, predictive maintenance. In industries like manufacturing and aviation, deep learning models predict equipment failures before they occur by analyzing sensor data. Their proactive approach reduces downtime, lowers maintenance cost, and improves operational efficiency. So now let's move forward and see some advantages and disadvantages of deep learning. So first one is high computational requirements. So deep learning requires significant data and computational resources for training, whereas advantage is high accuracy, achieves state-of-the-art performance in tasks like image recognition and natural language processing. Whereas deep learning needs large labeled datasets, often require extensive labeled dataset for training, which can be costly and time consuming together. So second advantage of deep learning is automated feature engineering. Automatically discovers and learn relevant features from data without manual intervention. The third disadvantage is overfitting. So deep learning can overfit to training data, leading to poor performance on new unseen data. Whereas the third deep learning advantage is scalability. So deep learning can handle large complex dataset and learn from massive amount of data. So in conclusion, deep learning is a transformative leap in AI, mimicking human neural networks. It has changed healthcare, finance, autonomous vehicles, and NLP.
In this video, we are going to learn how to automate Google Sheets using NA10. It is a very powerful workflow automation tool. We will start by setting up a webhook trigger to receive data from external sources, then connect it to Google Sheets to automatically store and update data in real time. By the end of this tutorial, guys, you will be able to capture form submissions, automate data entry without manual work, or set up live workflow that runs seamlessly. So whether you are a beginner or an automation pro, this tutorial is must-see for you. First, understanding what exactly is NA10. So I'm at the official website of NA10, and NA10 is an open source workflow automation tool that allows you to connect various applications like APIs and databases without writing extensive code. It provides a visual editor where you can create workflows by linking different nodes. Think of it an alternative to Zapier and Apache Airflow. But this tool has more control and flexibility, and also it has self-hosting capabilities. Now if you see, the key features of NA10 are as follows. It has this amazing visual editor where you can drag and drop nodes to create workflows. No complex coding is required. It has over 350 plus integrations, and it supports APIs, databases, messaging apps, AI tools, and cloud services. For example, you can think of like Google Sheets, Slack, Telegram, OpenAI, AWS, GitHub, MySQL. So it has integration to these tools. And apart from that, it has self-hosting and cloud options. You can run it on your own server for data privacy, also available as cloud service. It has also conditional logic and data transformation. It supports if condition, loops, branching. You could also modify API responses, filter data, and perform calculations. And guys, this feature is very amazing. For real-time automation, it has webhooks. So NA10 can receive data from webhooks to trigger instant actions. For example, when a form is submitted in Typeform and send an email via Gmail. So it can automate in real time. Now you'll be wondering, how does N8N works? Now let us try to understand how N8N works exactly. So you can think of N8N as a digital assistant that automates your task without requiring you to write complex codes. It basically works by connecting different applications, services, and database into a sequence of steps called workflow. So if you go and log in to the creators.n8n.io.dashboard, if you register for this N8N, you're going to get a workflow template. Okay, you can go all over here. And you can share your template with the template name and give a description about it. And this could be your template code, whether it is free or paid. You can just click on this. And after that, I have reviewed my submission guidelines of N8N terms and services. And then you can click this workflow. Now, Let us try to understand what exactly is a workflow. But before that, let us try to understand nodes. Okay, so nodes are tiny workers that do specific tasks. You can consider this something like that. And workflows are a sequence of nodes working together to complete a job. Like for example, let us say we are sending an email when you get a new form submission. Imagine you have a Google form where people can contact you. So every time someone builds the form, you want to automatically send them an email. So in N8N, you can create a workflow like this. So a Google Forms node collects the new response and Gmail node sends an automatic email to the person who submits the form. So this is something like this. We'll be doing a one hands-on tutorial also to elaborate more about it. So this is one of the way how it works. Next, there is a concept of triggers. So there are trigger-based execution mode also. How to start your workflow. So you have to also understand, guys, that N8N workflows don't run all the time. They only start when something happens. So there are three ways to trigger a workflow. So the first one is trigger-based execution, okay, which is basically called as an event-driven. The workflow automatically starts when a specific event occurs. For example, let's say a new row is added to the Google Sheets. Now the workflow starts to run. Or you can think about it something like that. When a customer fills out a type form survey, the workflow runs. Think of it like a doorbell. When someone rings a bell, like for example submits a form or updates a database, the workflow wakes up and does its jobs. Next one, we have the schedule execution, or we call it as cron jobs. Now here the workflow run on schedule, like daily, weekly, monthly. For example, every Monday at 9 a.m., a report is generated and sent via email. Or every hour, N8N checks for new tweets and saves them. Think of this like an alarm clock. You set it once and it automatically rings at the right time. Now let us discuss about the workflow components, which are like the brains of the system. So every N8N workflow is made up of different types of nodes. And each node has a special role, just like team members working on a project. So whenever we trigger the node or start the workflow, so what happens exactly? First, there is a webhook node, which starts someone when, like for example, someone is sending a data to your API. Then there is a scheduler node, which starts at a specific time, like every morning at around 8 a.m. And then there is a type form trigger node, which starts when someone fills out a type form survey. So we'll try to cover all these things in this today's tutorial. Now, there are some also nodes, like we call them as action nodes, which basically perform tasks. So these nodes do not actually work in your workflow. For example, let's say send an email node or send an email via Gmail or Outlook. Or there is a HTTP request node, which fetches the data from an API like a weather update or something. Then there is a Google Sheet node, which like adds a new data to a spreadsheet. So these are called as action nodes, which basically performs tasks. Then you could also understand a bit about, let's say, logic nodes, which adds intelligence. So these nodes allow you to add conditions and decision in your workflow. For example, let's say if node checks a condition is met, like for example is an email from a VIP customer. You can imagine something like this. Then there is a switch node, which routes the workflow based on different cases. Like for example, the payment example is the best one. Like if the payment is failed, send a reminder. Otherwise, if it's successful, send a confirmation. And then you could also find out the loop node, which repeats an action multiple times, like sending a follow-up email every 3 days. So guys, these were some of the logics nodes, which basically adds intelligence. And finally, we have the data nodes, which store and retrieves the information. These nodes basically help you save and manage data. For example, like Google Sheet node, which helps you to read and write data from my spreadsheet, or MySQL node, which stores customer data in a database, or Airtable node, which basically updates information in a table. Think of it like filing cabinet. It organizes and stores important documents or data for future use. So putting up all together, let's say you run an online store and you want to notify your team on Slack when a new order is placed in Shopify. So here is how your N8N workflow would look like. There is a trigger node, like Shopify will trigger, like it is going to detect a new order. Then the action node is going to come up, which is going to fetch order details from Shopify. Then there is a logic node. If the order is above 1000 US dollars, it marks it as a high priority. An action node which basically sends a Slack message to your sales team. So this is like the entire process which runs automatically, saving your time and effort. Now guys, you would be wondering, why should you use n8n? See guys, there is no need for coding skills. You can just drag and drop nodes. It saves a lot of time by automating repetitive tasks. And it works with hundreds of apps and APIs like Google, Slack, Shopify, ChatGPT, etc. It also has self-hosting option which ensures privacy and full control. And finally, it is free and open source, unlike some other tools which have some strict limits. Now we are going to move forward and do a small hands-on to make you more understand about this platform. So guys, now let us create an automation using n8n. So first click on the first step. And let's say we want to use a trigger, let's say on a webhook call. So basically when we will be sending any HTTP request like get, post, put or delete, it is going to trigger our webhook on n8n. So just click on this and you could see our method is, let's say, post, and we want to post a data on using this post request. And after selecting this guys, just click for listen for test event. Let's test our webhook API. Copy this and then you can go to this online tool which is called as Recubin. Okay, and it is just a very simple tool where you could just do one thing. You could paste the same URL which you have copied it from here. Okay, now after going all from here, what are you going to do? Just click on the send request. Now you could see we have got a successful message that the workflow has started. But how to be sure of that this thing is working? Because in the output section, you will be seeing these kind of output. Okay, so our webhook API is working very much fine. Now, what next thing you could do? So the next thing, let's say, let us add a node all over here. So for example, let's add a Google Sheet. Okay. And let us trigger an API. Okay, let us say append a row in a sheet, or we want to update a row. So now you could see all over here we have this option called append or update a row from this list. And let's say we have this document called monthly expense, and you could also choose it, let's say, from expense, and we want to add these properties, what values to send. Suppose name, we could say the name as Neil, and all over here, that's one thing. Okay, then what we could do, we could add another option like what would be the cell format, and we could add the next property, let's say as email, let's say .com. Okay, now we could test these steps. Okay, now you could also say let's add a column, okay, to name. Okay, and let's say we could add just one value. Then we could add another column, let's say email. Okay, let's okay, we could write the name of another column. Okay, so we had only two columns that I have actually created all over here, name and email. So that's why our workflow is showing the same. And also guys, there is one point to note. You have to also connect to your given applications. Okay, so I'll just show you how you could do it. But first, let us try to test this step. Okay, so okay, fine. We can choose it, match each column manually. And let's test the given step. Let's wait for the output. And if I open my Google Sheet, you could see, we can see, the name, email, and it's already mentioned here. So this is like how you are basically creating your workflow. So if you go back to your canvas, you could see our workflow has been created using the webhook call. Similarly, you can trigger a lot of, in a very different way. Suppose you could add a next node, like you could add AI and all those things, and you can create this automation using n8n. Guys, this is a very amazing tool, and this automation tool is definitely going to save a lot of time for you.
Did you know that within just a few lines of code, you can transform an AI model into something far more powerful? Something that responds to questions, connects to live data, pull insights from databases, and even interacts with other apps in real time. That's what LangChain allows you to do. And it's quickly becoming the go-to framework for AI developers. Think about this. You're about to create something amazing, an AI that can think, learn, and grow in ways we once only dreamed of. And here's the best part. You don't need to be an AI expert to make that happen. LangChain is like a toolkit that connects the most advanced large language models like OpenAI's GPT to real-time data, allowing you to build AI applications that are smart, flexible, and highly interactive. LangChain is more than just a way to make AI development easier. It's a framework that allows different language models to work together seamlessly. So whether you want to understand user questions with one LLM, create human-like responses with another, or pull in data from an API or a database, LangChain makes all possible. The framework takes care of heavy lifting, connecting models, managing data flows, and even customizing how your AI interacts with external sources. Now the question is, why is LangChain so popular? It has become one of the most fastest growing open source projects because it's solving a huge problem for developers. The challenge of integrating generative AI and LLMs with external data and complex workflows. As AI becomes more central to our lives in 2024, LangChain is helping developers create smarter, more powerful applications. So whether it's just for chatbots, content creation, or advanced data analysis. In this tutorial, I'll show you exactly how to get started with LangChain, from setting up your environment to building the first AI-powered app. I'll walk you through it. So LangChain makes it possible to train models on our own custom data, opening up more possibilities for building specialized intelligent applications. By the end of this video, you will be ready to start building with LangChain, and trust me, once you see how easy it is, you'll wonder why you didn't start using it sooner. Let's start with a simple question: why should we use LangChain? Imagine you're working with large language models like GPT-4 or Hugging Face models, and you want to take their capabilities further, like integrating them with your own data sources or allowing them to take action based on information they retrieve. This is where LangChain comes in. LangChain is like an open source framework that allows you to build intelligent applications by connecting large language models with external data sources. It can turn static AI interactions into dynamic, data-aware workflows. One of the best parts is you don't have to manually code everything from scratch. LangChain abstracts away much more complexity of working with LLMs, allowing developers to focus on building functional applications instead of wrangling API calls and managing data pipelines. So LangChain is set to play even bigger role in AI development because it enables you to harness true power of generative AI by connecting it with real-time data and external tools. So now we have understood what LangChain is. Let us now understand how to install LangChain. So let's start with the installation of LangChain. We'll just simply go to the website docs part, and we'll just read through this documentation. So here it has explained what LangChain is and what are the framework consisting of. So we also have these tutorials on how do we install LangChain. Okay, so for installing, you can just simply click on this quick start and see here it has written how do we set up on Jupyter Notebook. So this is the command. If you want to install LangChain, we will use the pip command. So just simply you can copy this command pip install LangChain, and you have to open your command prompt or the terminal in your computer, and here you have to simply copy paste the command. So as you can see, it will load all the packages which is required for installing LangChain. So you can see your requirement already satisfied. This is because I had already installed my LangChain before. So we have understood how to install this LangChain by using this command, and you can also install the LLM chain. We'll understand it later. So let me just show you what else you need to install. First, we have understood this LangChain. Then we have the Pinecone client. So we'll just simply search here Pinecone client, and it will redirect us to this page. So Pinecone client is actually a vector store for storing and retrieving embeddings, which we will use in the later steps. So Pinecone is also used to actually, create secret API keys. So here you can also create the API keys. You can also read the documentation part. So we'll understand how to create API keys using OpenAI. But first, let us install Pinecone client in our system. So we'll again go to command prompt this terminal and we'll just copy paste pip install Pinecone client. So you can see here it will download and install all the packages required. So it has been installed. Now the third thing we're talking about is OpenAI client. So we'll use OpenAI models for a large language task. So we'll just simply search here OpenAI. Okay. And so it has redirected us to this page, OpenAI platform. And okay, before starting this, so this is the platform here where you can create, export an API key in OpenAI. Okay, so you can see here overview, quick start, concept, everything is there. And to create an API key, we'll just simply click here and here you have to select this option, create a new secret key. Suppose I give my secret key name, anything you can give. Suppose I give test 1, 2, 3. Okay, and permissions is all, and we create the secret key. Now you need to actually save your key. We'll just copy this key because it will be required later while debugging the code. So we will just copy paste this secret key. We will require it later, and then done. So these are the keys I have created. So actually ChatGPT and other LLM models like OpenAI and Hugging Face uses LangChain to integrate with other APIs to create your own custom LLM models or chatbots. So suppose here we have logged in our ChatGPT here, and if I search here who won the WTC World Cup in 2023. So here it has shown the answer, but for example, if I search who won the cricket match World Cup So here, as you can see, the ChatGPT has given answer as my last knowledge update, the 2024 Men's World Cup has not taken place yet. This is happening because this ChatGPT older version has not been trained on the latest upcoming news or whatever the new technology is. So by using LangChain, you can integrate with other APIs and you can create your own customized LLM models or chatbots, which help you to train your own custom data using various tools and APIs. So before we move on, I've already showed you how to create the secret API key and how you have to store the API key address. So first we have already understood how do we install LangChain here. So by using the pip command, we do it. And so you also need to install Python 3.8 or later installed in your system. So I already have Python installed. And to check that, you can just simply, I already have it installed in my system. So to check that, I'll simply just type here Python -- version and click enter. So as you can see, it has shown me the Python version which is installed in my computer. So the second step is already we have discussed, which is OpenAI API key here. So second step, we have already discussed how do we create our OpenAI API key. So we have to sign up in our OpenAI, then go to the API key section and then create a new secret key. And these are the keys I have created, and you can just keep it later. Later you'll use that. So now we'll come to the third step, which is create a project directory and setup. So what we do is we have Jupyter installed in our system. So we'll just go to command prompt here and type JUPY, Jupyter Notebook. So it will redirect us to the Jupyter Notebook installed in our system. So if not, we can just simply go from here. It is loading right now. We have to wait. Now you just need to click on this new and Python 3 IPy kernel because Python has been installed in my system. So we will use Python as our kernel here. And here you can just give the prompts, the command. Before that, you have to create a Python file, which we can also create this Python file in Visual Studio Code. Just simply go to Visual Studio Code here and just simply click on File, New File, and I'll just type here python.py. And you can you have to first store the API key. For this, we use the command OpenAI underscore API underscore key equal to, and just give your secret key. Okay, you can just simply copy paste your secret key and just store this. So this ensures that your API key is stored securely and it can be used whenever needed. Now the step 4 is to initialize a project and install the required libraries. So you need to add some additional libraries like Streamlit to make a user interface. So let's add that too in our project folder. You can either create a text file named requirements.txt and then install all these. We have already installed the OpenAI LangChain. We just need to install Streamlit. So here you can just give the command pip install Streamlit. So as you can see, this I have already installed Streamlit before. Same wise, you can also install OpenAI if it is not installed in your system using the command terminal, the Windows PowerShell. So we have understood this, what all packages and what all we need to install. Now the next step is to build your first LangChain app. To create a simple app which uses a input query and the app will generate a response using OpenAI's GPT model. So you have to create a Python file named main.py here. So as you can see, I've already imported this main.py and this is my code here. Import Streamlit as st from LangChain and the constants I've created, and then I have initialized the OpenAI with our API key. So you have to just type this prompt here. I'm using VS Code here. You can also do it in your Jupyter notebook. And then to create the Streamlit app, you have to give a title, LangChain demo with OpenAI. So this is the title I have provided. And then the text input for prompt. The prompt is st.text input and enter a prompt. You can just type enter a prompt or whatever you wish to. And then display the response. So if prompt response is LLM.predict prompt, so you can use the predict method for LLM. So here what the app will, so after creating and debugging this in the terminal, so your app will initialize OpenAI using your API key and the user inputs a prompt through the Streamlit interface. LangChain processes the input and sends it to the OpenAI's GPT model, and the AI generates a response which is then displayed in the app. So now you can use all these prompts to run on your app. So to do this, you can just, to see your app in action, you can just go to the terminal and run the following command, which is Streamlit run main.py. So you can just simply go to the terminal here and just simply type the command, which is Streamlit run main.py. So by giving this prompt, a new tab in your browser will open displaying the app, and you can also type any question into the input box. So now we have understood all these steps. So this was a quite basic tutorial on how to install LangChain and then, integrate it with the app. You can also customize and expand. So LangChain's flexibility allows you to integrate other APIs also, external data sources, or even add memory to your AI application. So whether you're building a simple chatbot or more complex AI system, the possibilities are endless.
Welcome to the LangChain for LLM App Development short course by Simplilearn. So we will initially start with what is LLM App Development. So LLM App Development is a process of building applications that utilize large language models like GPT-3 or GPT-4 to understand, generate and process human language. So these applications can perform tasks that require language comprehension such as question answering, summarizing text, creating content, or even having conversations. So imagine you have a smart assistant on your phone. You ask it, what's the weather like in New York tomorrow? And within seconds, it gives you a clear human-like response. That's the powered by LLM app development. But it's not just limited to the weather updates. LLM apps can do much more. So let's dive deeper with examples. So first we have customer support chatbots. Imagine you are visiting an e-commerce site and have a question about your order. So instead of waiting for an agent, you instantly get a response from an automated chatbot. It's able to answer questions, solve problems, and even guide you through the buying process. That's an example of LLM app in action. Then we have writing assistants. Think about tools like Grammarly or GPT-powered writing assistants. You are writing an email or a report, and the app suggests improvements or even completes sentences for you. It's like having a virtual editor by your side. Then we have code generation tools. So imagine you are coding and you don't know how to create a specific function. You type your request like create a Python function that adds the two numbers, and instantly the tool generates the code for you. LLMs can help developers code more efficiently by suggesting or writing based on the natural language instructions. Then we have document analysis. Imagine you need to read a long legal contract, but you don't have time to go through every clause. You can upload it to an LLM-powered tool and it will summarize the key points for you. It reads and understands documents like a human would. So now let's move on and understand what is LangChain. So LangChain is a powerful framework that helps developers build applications using large language models like GPT-4. It allows you to easily connect LLMs to the real-world data, tools, external systems to create more advanced, interactive, and intelligent applications. Think of LangChain as a toolkit that helps you build the smarter apps powered by LLMs. Makes easy to work with the language models. It retrieves data from the documents or databases. It automates task and decision making. It keeps track of the context or memory in a conversation. Now, moving on, we will understand the core components of LangChain. So LangChain is designed with several core components that make it flexible and powerful for building the LLM-powered applications. So here's a simple breakdown of the core components. First, we have models that generate text or handle language tasks. Then we have prompts that define how to ask the model questions or request actions. Then we have chains that combine the multiple tasks in sequence or the workflows. Then we have memory that keeps a track of the past interactions for context. And finally, we have agents that make decisions on what actions to take dynamically. Then we have tools, that is the external systems, that is the APIs, databases, etc. that can be accessed by the agents. Then we have retrievers, that is a search and the pull relevant information from the large datasets. And then finally we have output parsers, structure the model's free form output into useful data. These components work together to create intelligent, flexible and modular LLM-based applications that go beyond the simple text generation. So, we'll understand how LangChain in LLM app development actually helps. So LangChain is like a toolkit that makes it easier to build the smart applications powered by the large language models like GPT-4. So here's how LangChain helps you develop the powerful LLM apps. First is easier integration of LLMs. So LangChain makes it super easy to plug in models like GPT-4 or GPT 3.5 or others. You don't need to worry about the complicated setup processes or coding everything from scratch. Then, for example, imagine you want your app to use GPT-4 to generate text or answer questions. So with LangChain, you can set this up with just a few lines of code. Moving on, number 2, we have automate some multiple steps like the chains. So in traditional app development, you would have to manually combine different steps like asking a question, processing the answer, and handling data. So LangChain simplifies this by allowing you to chain actions together, automating multiple processes. For example, if you want to build a chatbot, LangChain helps you chain steps such as getting user input, then sending it to the LLM for processing, and then finally returning the response to the user. So this makes development faster and less error prone. Now moving on to the third one, we have easy data retrieval. So imagine your LLM needs to pull information from a huge pile of documents or data. So LangChain makes this easy with retrievers. You can set up systems to search through documents or databases and bring back the most relevant information. For example, if your app needs to answer questions about the company's quarterly report, LangChain can help you automatically pull the most relevant sections from the report using a retriever. Then we have memory for smarter conversations. So when building apps like the chatbots or virtual assistants, it's important to remember previous interactions. LangChain gives you the ability to add memory to your app. So this means your LLM can remember what was said earlier and respond in a more context-aware way. For example, if you're chatting with a virtual assistant and ask, "What did we talk about yesterday?" the assistant can refer back to your earlier conversation, and thanks to LangChain's memory. Now moving on, we have decision making with agents. LangChain also provides agents that can make decisions based on the information they receive. So these agents can decide what actions to take, such as querying a database, calling an API, or another question all on their own. For example, if a user asks, "What's the weather in Paris?" an agent could decide to fetch the weather from a live API, ensuring the answer is accurate and real-time. Then we have tool integration for added functionality. So LLM apps often need to interact with the external tools like the APIs, databases, or websites. So the LangChain makes it easy to connect these tools to your app, enabling the LLM to take actions based on the real-world data. For example, if you want to build an app that helps users book flights, LangChain can help you integrate the flight booking APIs so the LLM can make the real-time bookings for users. Then we have point number 7 as simplifies the complex tasks. So LangChain takes care of the complicated parts of the app development for you. So you can focus on building the core functionality of your app. So whether it's chaining steps, integrating external tools, or managing memory, LangChain simplifies everything and helps you develop more advanced LLM apps with less effort. So it's a game changer for the developers who want to create intelligent, real-world applications using LLMs without having to build everything from the ground up. Now, let us understand why is LangChain preferred. So LangChain has become the go-to framework for developers working with LLMs because it offers a lot of advantages that make app development faster, easier, and more powerful. Here's why it's preferred. The first one is modularity and flexibility. So LangChain is designed to be modular, meaning you can pick and choose the parts you need for your app. You don't have to use everything, just the components that suit your specific needs. So whether you need a model, a memory system, or an agent, LangChain lets you mix and match components seamlessly. Why it is good? You can actually build only what you need and make your app more customizable. Then let's move on to the next point. We have faster development and prototyping. So with LangChain, you can get from idea to working app quickly. It comes with the pre-built components that you can use right away, like chains, prompts, agents, and memory. So this makes it easy to prototype and test your ideas without reinventing the wheel. So why it's good? It saves your time and allows you to develop the features faster. Then we have built-in tools for the external integrations. So the LangChain makes it easy to connect your LLMs to external tools like APIs, databases, and external data sources. So whether you need to query a database, use a web search API, or interact with the custom tools, LangChain has you covered. So now moving on, we have memory handling for the context-aware apps. Most LLMs don't have memory, meaning they forget everything once the conversation ends. So LangChain lets you store and manage memory, which is essential for the building apps like the chatbots or virtual assistants that need to remember the past interactions. Then we have decision-making agents. So LangChain's agents are a powerful feature. So these agents can decide what actions to take based on the input they receive. So whether it's querying a database, calling an API, or asking for more information. So this makes your app smarter and more autonomous. Then we have, it simplifies the complex workflows. So with LangChain's chain, you can automate multiple step processes that combine prompts, models, and tools. This is especially helpful when you need your app to follow a sequence of actions. It's good because it allows you to build the complex workflows easily without having to manually stitch everything together. Then we have active community and open source. So LangChain is open source and has an active community of developers constantly improving it. So this means you have access to the new features, updates, and support from the other developers as well. So in short, LangChain makes LLM app development simpler, faster, and more powerful. It gives you the tools you need to build advanced smart apps without having to code everything from the scratch. So now let's move on to the next chapter and see the core components in action. So there are various components that work together. So the first one is models. So let us see what are models. In the world of LLM app development, a model is essentially a smart program that has been trained to understand and generate the human language. So these models are built using huge amounts of data like books, websites, articles, etc. to learn how language works, including grammar, facts, reasoning, and context. In simple terms, a model is like a brain that can read and write language. You can ask it questions, give it prompts, or provide it with information, and it will respond in a way that makes sense based on what it has learned. For example, let's consider an example with GPT-3 or GPT-4, two popular language models developed by the OpenAI. You ask, what's the capital of France? The model processes it. It understands that the question is about geography and recognizes the capital and France in the context of the countries. Then it responds to the question as the capital of France is Paris. In this example, the model, like GPT-4, has learned from all the text it has trained on that Paris is the capital of France. The model uses its language understanding to generate a human-like response. Now moving on, we'll understand what are prompts. So in the world of large language models like GPT-4 or GPT-3, a prompt is simply the input or instruction you give to the model. It's like a question or a request that helps guide the model in generating a response. Think of a prompt as a way of asking the model to do something. So whether it's answering a question, completing a sentence, or even writing a story. Then we have a very few examples of prompts and what the model would respond with. So the first example is simple question prompt. That is, what is the capital of Japan? The model's response would be, the capital of Japan is Tokyo. Then we have an example for the creative prompt. The prompt is, write a short story about a cat who loves to swim. The model's response would be a creative story about a cat learning to swim and having fun. Then let us understand what are output parsers. An output parser is a tool that helps to process and structure the text generated by a language model. When a language model generates, it might be in the form of a long paragraph, sentence, or even free from text. But often we need to extract the specific pieces of information from that text, clean it up, and format it into something useful. Then we will see all this in action. So regarding the OpenAI API pricing, you can go directly to this openai.com API pricing wala website, and then when you scroll down, you will see and explore the detailed pricing, and you go there and you will basically find all the latest models with the input, the cached input, and the output as well. So in this course, we are using the GPT 3.5 Turbo, and its input is $3 and the training is $8. And if you contact the pricing, you will see it cost $0.5 and the output is $1.50. You can basically take up any API that suits well in your project. So what's happening in this code is pretty straightforward. So first, the OS and the OpenAI libraries are imported over here. OS helps us work with the operating system, and here it's used to grab the environment variables like the API keys, while OpenAI is the library that lets us interact with the OpenAI's model. So next, the .env library over here is brought in. This is super helpful because it allows us to store the sensitive information like the API keys in a .env file. So instead of hard coding them into the code, which would be very risky. So the find .env function looks for the .env file, and the load.env loads its contents into the environment. This is crucial because it makes the API key from your .env file available to the Python code as an environment variable. So finally, the OpenAI API key is pulled from the environment using the os.envir OpenAI API key, and it's assigned to the OpenAI API key attribute. So any calls to the OpenAI's API are authenticated using that key. So this way you can actually use the OpenAI's services like generating text without exposing your sensitive keys directly in your code. So let's run this. So in the next code over here, the code is handling the deprecation of an LLM, that is a large language model, by checking the current date and the setting the model version accordingly. So it first grabs the current date using the datetime.datetime.now.date and stores it in the current date variable. Then it defines a target date of the June 12, 2024 as the point after which the model should switch to a new version. So in this case, GPT 3.5 Turbo. The code checks if today's date is after the target date. So if it sets the model to GPT 3.5 Turbo. So if the date is still before June 12, 2024, it continues to use GPT 3.5 Turbo 0301, which is an earlier version. So this allows the code to basically automatically adapt to the deprecation of the older models. So by switching to a newer one when the target date arrives. Then let's run this and move on to the next code. So this function, that is get completion, takes a prompt and a model with a default value set to the LLM model variable to generate a response from the OpenAI API. It starts by formatting the input prompt into a message that's structured in a way that OpenAI API understands, with the user's message as the content. So then it sends this message to the OpenAI chat completion API using the OpenAI.chatCompletion.create method, specifying the model, the message, and a temperature setting of 0, which means the model will give more deterministic, less random responses. So basically, it returns the model's response by accessing the first choice in the response and extracting the generated text content. This function especially sends a user's prompt to the model and then returns the answers it generates. So we will run this. Now here, when you call that get completion, what is 1 plus 1? The function sends the prompt, what is 1 plus 1, to the OpenAI model. So this model then processes this prompt and generates a response. Since the default model is set to LLM model, it uses that model to compute the answer. The function then returns the model's response, for example 2, which is extracted from the API response. The function essentially asks the model to calculate 1 plus 1 and then return the result. Let's run this and you can see 1 plus 1 equals to 2. Let's now move on to the next one. Now here, the variable customer email is assigned a multi-line string using the triple quotes. So which contains a playful pirate themed message from a customer. The message describes the frustration of the customer whose blender lid flew off, creating a mess, and they are upset that the warranty doesn't cover the cleaning cost. So the backslashes are used to break the string into multiple lines for readability, but the string will still be treated as a single continuous piece of text. So essentially this is just storing a customer's complaint in a variable with some fun pirate language. So let's give this as input. So here the variable style is being assigned to a multi-line string that describes a style guide for writing. So the string specifies that the writing should be used American English and be in a calm and respectful tone. So the backslash is used to break the string into multiple lines for better readability, but it still remains one continuous string. So this string might be used later to guide the tone and the style of the responses or messages in a program. So here in this code, the variable prompt is being created using a f string, that is a formatted string. So which basically allows you to embed variables directly into a string. The prompt instructs the model to translate the text enclosed by a triple backticks into a specific writing style defined by the variable style. So the customer email, which contains the customer's message, is placed between the triple backticks, which is often used to denote the code or the pre-formatted text. The F string makes it easy to insert the value of the style and the customer email dynamically into the prompt. So finally, the print prompt will output the full prompt, showing the instruction to translate the customer's complaint into the desired style. So we'll run this. And now let's see the response. Response is equal to, we'll call the get function get completion, and inside it would be prompt. So let's run this. So in this line, the function get completion prompt is called with the prompt created earlier as its input. So this prompt, which asks the model to translate the customer's email into a specific style, is sent to the OpenAI model. The model processes the prompt and generates a response based on the given instructions. So the result of the API call is stored in the variable response, which will contain the model's translated version of the customer's email in the requested style. So let's move on to the next one. So here basically the variable response stores the output from calling the getCompletion prompt function, which sends the prompt to the OpenAI model. The model then processes the prompt and returns a response such as the translated email in the specified style. So you can see I'm really frustrated that my blender lid flew off and splattered my kitchen walls. So basically it is the complaint. So here we will just see how to do this with LangChain. So here we are passing pip install upgrade LangChain, and let's see what happens. So this line of code is importing the chat OpenAI class from the LangChain.chat models module. So the chat OpenAI is a class provided by the LangChain that allows you to basically interact with the OpenAI's models in a chat-based format, making it easier to integrate the conversational AI into your application. So by importing it, you are preparing to use this class to create the chat-based interactions with OpenAI's language models in your program. So let's run this. So in this code, a new instance of the chat OpenAI is being created with the temperature set to 0.0 and the model set to the variable of LLM model. So the temperature parameter controls the level of randomness and creativity in the model's response. So by setting it to 0.0, you are telling the model to generate very predictable and deterministic answers with little to no randomness. So this makes the model's responses more focused and consistent. So the model is set to use whatever model is specific in the LLM model variable, which could be something like GPT 3.5 Turbo or another version. Now you basically can see the output. So in this code, the variable template string is assigned a multi-line formatted string. So this string is structured to ask the model to translate the text enclosed by the triple backticks into a specific style, which will be dynamically inserted using the style. The text placeholder is also used to represent the actual content that needs to be translated, and both style and text will be filled in the values passed to the template. So the backslashes are used to break the string across multiple lines of readability, but it remains one continuous string when executed. So this template will be useful when you need to generate a prompt with specific content and style dynamically. So in this code, the chat prompt template class is imported from the LangChain prompts to create a prompt template for chat-based interactions. So the from template string method is used to create a prompt template using the previously defined template string. So this method takes the string with the placeholders and turns it into a reusable template that can be dynamically filled with the specific values from generating prompts for the model. So this allows for consistent and flexible prompt generation where you can easily customize the text and style for each use case. So in this code, the prompt template message is 0. Prompt is accessing the first message in the prompt template object and retrieving its prompt. So by referencing to 0, it's selecting the first message from the list of messages in the template. Finally, dot prompt extracts the actual prompt from the first message, allowing you to see or modify the template before it gets used to generate a dynamic prompt for the model. So let's run this and you can see the first prompt. So in this code, the prompt template dot messages dot prompt dot input variables is accessing the input variables from the first message of the prompt template. So the prompt template was created using the chat prompt template, and each message in the template was a prompt with the placeholders like the style and the text. So by referencing to the input variables, the code is retrieving the list of the variable names that are used in the prompt template. So this helps you to understand which values need to be provided to complete the prompt before it's sent to the model. So in this code, the variable customer style is assigned to the multi-line string that describes a specific writing style, the American English, in a calm and respectful tone. So the backslash at the end of each line allows the string to be split across the multiple lines for readability. So it will be used when interacting with the customer, possibly for generating responses in a polite and professional manner. So let's give this as input. So in this code, the variable customer email is assigned a multi-line string containing a playful pirate themed message from a customer. So here again the backslash at the end of each line provides you to split the string across for readability, but it remains one continuous string when stored in the variable. So this message is designed to simulate a humorous complaint, like for testing or demonstration purposes, with a fun pirate content. So let's run this. So here the prompt template dot format messages method is being used to fill the placeholders in the prompt template with specific values. So the style equal to customer style and text customer email are passed as arguments, which means the placeholders, that is the style and the text in the prompt template, will be replaced with the contents of the customer style, that is the writing style, and the customer email, that is the customer's complaint. So the result stored in the customer's messages is a formatted message where the dynamic values are inserted into the template, creating a customized prompt that can be sent to the language model. So this basically allows you to generate the context specific messages based on the input variables. So let's print this. And basically you can see, you can print the type of customer messages. You can see it is a list, and customer messages 0, that is the first message. It is LangChain.schema human message. Now let's see the first customer message we have. So now basically you can see, now here it is basically the call to the large language model to translate the style of the customer message. So let's run this. And now let's see the response that is changed. Oh man, I'm really frustrated that my blender lid flew off and made a mess of kitchen. And now basically you can see the difference. So here basically the variable service reply is assigned to a multi-line string that represents a service response to a customer's complaint. So the message is written in a direct and somewhat casual tone as well, explaining the warranty does not cover the cleaning expenses. So this reply provides a straightforward explanation, although it's a bit blunt, but yeah, part of mock or example response. This is as well an example. So the variable service style pirate is assigned a multi-line string that describes a specific tone for the communication. So again, it sets the stage for generating the responses that are both courteous and the pirate-like manner. So let's run this. So in this code, the prompt template dot format messages method is used to gain a format new message, but it's time for the service reply. The style is equal to service style pirate and the text equal to service style reply and passed as arguments so that the placeholders style and text in the prompt template are replaced with the pirate theme service style and the actual service reply. The result is then stored in the service messages. This will be a formatted message as well. So finally, print service messages 0 dot content prints the content of the first formatted message, which will display the service reply. So let's see this. So finally, in this code, service response equal to chat service messages sends the formatted service message to the chat function which interacts with the OpenAI model. The model then processes the message and generates a response based on that particular prompt. The resulting response is stored in service response. Finally, we are printing it is used to basically output the content of the model's response in the service response.content, which will be translated service reply generated in the specific pirate tone and displayed for you to see. So now here we will begin with the output parsers and we'll see how it plays. So this code is a JSON object, that is JSON means JavaScript object notation, that contains some data represented in the key value pairs. Here's what each part means. Gift : false indicates that the item is not a gift, and false is basically a boolean value. So delivery day is equal to 5, which means the delivery time for the item is 5. Price value is equal to pretty affordable, provides a description of the price saying it's pretty affordable. Now let's run this. So basically it is a customer review and a review template, the two variables over here, and this is a multi-line string that contains a detailed review of the leaf blower, and the review is inserted into the template using text, and the model is expected to output this information in the JSON format with the specified keys as gift, delivery days, and price value. So this setup is structured to automatically extract and format the relevant details from the customer's review. So let's run this. So in this code, the chat prompt template dot from template review template is used to create a prompt template from the review template string. The review template defines a structured prompt that guides the model on how to extract the specific information from a customer review. So by calling the from template, LangChain is converting the review template string into a chat prompt template object, which can now be used to generate the dynamic prompts. So finally, we are printing the prompt template, allowing you to basically see the structure that will be used to extract and format the data from the review. So in this code, the prompt template.format messages basically formats the review template with the actual customer review text. So this set fills in the placeholder in the template with the content of the review. So next, the chat OpenAI object is created with the model set to LLM model, and the temperature is set to 0, which ensures the model's responses are more deterministic and less random. So the model generates a response and then we are printing it basically, which will be extracted information from the review. That will be a JSON format. Basically, this allows the program to automatically analyze and extract the details like whether the item was a gift, delivery time, and the price value. So now basically we are seeing the type of response.content, and you can basically see this is string. And now let's see this. And now you can see it has shown an error. And why so? It is showing that str object has no attribute get. Now let's solve this. So now here in this code, the two classes are being imported from the LangChain's output parsers, the response schema and the structured output parser. So together these classes help manage and structure the information the model generates, making it easier to extract and use in your application. So here in this code, there are 3 response schema objects are created to define the expected structure for the model's output. So each schema represents a specific piece of information that the model should extract from the customer review. So we have gift schema, delivery day schema, and price value schema. So these schemas are then grouped into a list called response schemas, which will be used to guide the output parsing, ensuring that the model's response is structured and matches the expected format for each piece of information. So here the line structured output parser, this creates a new structured output parser using the response schemas defined earlier. So this parser is responsible for interpreting the model's response and ensuring it matches the structure specified in the schemas. So by passing the response schemas list, you are telling the parser what kind of data it should expect and how to organize it. So this allows the model structured text output to be automatically parsed and formatted into a structured format, just like the Python dictionary or JSON, based on the schemas provided. So here in this line, the output parser.get format instructions is being used to retrieve the format instructions from the structured output parser. So these are essential guidelines for a template that tells the model how the output should be structured to match the defined response schemas. So by calling this method, you are getting the necessary instructions that will help the model generate a response that fits the expected format, making it easier for the output person to properly interpret and organize the data later on. So in this line, we are basically printing the format instructions, and let's print this. And you can see this is a JSON file. And now here basically you can give one review template to some sort of strings, and then you can basically chat prompt template dot from template, and you can even prompt dot format messages over here, and then you can run this. And here basically you are printing the first message in the content, and you can see you have got this. So here basically you can get the response equal to chat messages sends the formatted messages to the chat function, which interacts with the OpenAI model, as I have explained earlier. So this response will be then used for further processing or display. And now here we are printing the response content, and you can see gift, true, delivery days 2, price value. It's slightly more expensive than the other leaf blowers out there, but I think it's worth it for the extra features. So in the next chapter, you will see how to basically feed the memories to the model. So sometimes it's very necessary for a chatbot to remember your conversations. The previous conversations are helpful to be remembered by a customer support chat. So in this chapter, we will basically see how we can actually import memory to the models. So in this code, we are setting up the environment for our project. It starts by importing the OS module, as we have done previously, which helps interact with the operating system, and then brings in the load.env and find.env from the .env package. So these are helping to load the environment variables from .env file. Then we are having to store the sensitive information like the API keys. Then find.env function looks for the .env file, and the load.env loads its contents into the environment, so you can access these variables in your program. So let's run this. So this code is designed to handle the deprecation of a particular version of the large language model. It first imports the datetime module, which allows you to work with the dates and the times in Python. Then it gets the current date using datetime.now.date. Which then fetches the current date. Then it defines the target date, which is in the case of June 12, 2024. The code then checks if the current date is later than the target date. So if it is, it sets the model to GPT 3.5 Turbo, assuming that after this date, the older model version is deprecated. So if the current date is still before the target date, it uses the GPT 3.5 Turbo 0301 older version of the model. So let's run this. So the code snippet imports components from the LangChain library, which is a powerful tool for working with the language models in more structured and interactive ways. It imports a chat OpenAI from the LangChain.chat models, which is a class that allows you to easily interact with the OpenAI's chat models like GPT-3 or GPT-4 for generating the conversational responses. Then it brings in conversation chain from the LangChain, and lastly the conversational buffer memory from the LangChain.memory is imported to handle the memory of the conversation. Basically it stores and retrieves the previous exchanges so the conversation feels more coherent and natural, with the model remembering the past inputs. So all of these components work together to build an interactive chat experience where the model can maintain the context and the flow throughout the conversation. So let's run this. So in this code, you are setting up a conversational AI experience using the LangChain library. So first, the LLM variable is initialized with the chat OpenAI class, where the temperature is set to 0.0 argument, ensures that the model's responses are deterministic, meaning it will give the same output for the same input every time, which can be used for the control interactions. The model is equal to LLM model parameter uses the model name that was defined earlier. So here then the conversation variable creates a conversation chain which ties everything together. So it connects the LLM with the memory and sets verbose is equal to true to ensure that the detailed logs of the conversation are printed out, making it easier to debug or analyze the interaction. So let's run this. So here we are sending the input, "Hi, my name is Andrew," to the model. The conversation object, which was set up earlier, processes the input and generates a response based on the context it has stored in the memory. Now you can see, "Hello, it's nice to meet you. How can I assist you today?" Behaves like a chat. And here the line sends the input, "What is 1 plus 1 to the model again?" So we will see, and you can see 1 plus 1 equals 2. Is there anything else you would like to know? So it definitely behaves like a chat. So here, when you call the chat conversation.predict input, "What is my name?" you're asking the model to recall and respond with your name. Since the conversation memory is active, the model will just look back at the previous conversations to see if it has already learned your name. So if it has, it will reply with, "Your name is Andrew." And you can basically see it has been imported with memory. So here the line print memory.buffer is used to display the contents of the conversation memory. Since the memory is an instance of the conversation buffer memory, it stores all the exchanges that have taken place during the conversation. So by printing memory buffer, you can see the entire conversation history over there. Basically, you can see the whole history. Here, this is used to load the current memory variables into the conversation. So in this case, the third bracket is an empty dictionary, which means you are effectively asking to retrieve all the memory stored so far, but without any specific filtering or conditions. This can help in accessing or managing the entire conversation history stored in the memory, giving you a snapshot of what the model remembers from the interactions so far. So let's see. So it basically remembers everything. So this line basically initializes a new instance of the conversation buffer memory, which is a special type of memory used to store the conversation history. So let's run this. So here the line memory save context input hi output WhatsApp is saving a new interaction to the memory buffer. So the input hi represents what the user said and output WhatsApp represents the model's response. So by calling the save context, you are telling the conversation buffer memory to store this as a pair of input output so the model can refer back to them later in the conversation. So let's see this. Now finally, we are printing the memory buffer is used to display all the stored conversation history in the memory object. So since memory is an instance of the conversation buffer memory, it keeps track of each user input and output response. So by printing the memory.buffer, you are essentially showing the entire conversation log so far. This is helpful for debugging or understanding how the model is processing the conversation over time. So the line memory.load memory variables is a way to retrieve and inspect the stored memory from the conversation buffer memory object. So here the empty third slash is an empty dictionary, meaning you are just asking to load all the memory variables without any specific filters or conditions. Here we are importing conversation buffer window memory from the LangChain.memory and let's run this. So here this code basically creates an instance of the conversation buffer window memory with a window size of 1, meaning the memory will only store the most recent interaction, both input and output. The parameter k is equal to 1 defines that the window will hold just one exchange at a time, discarding the older conversation history. So this setup is helpful when you want the model to focus only on the immediate context, keeping things lightweight and efficient, especially in the longer conversations. So here basically we are saving the content, that is a key value pair, and input hi, output is WhatsApp. Input is not much, just hanging. Output is cool. So let's run this. So here basically we are used to load the stored memory from the conversation buffer memory object. The empty dictionary means you are not applying any specific filters, so it's simply retrieving all the memory variables stored in the buffer. So let's run this. So this code is setting up a conversation with an AI model using the LangChain library. So first the LLM variable is initialized with the chat OpenAI, setting the temperature to 0. which means again the model's responses will be more deterministic. Then the model is chosen based on the LLM model variable, which could dynamically switch between different versions. Next, memory is equal to conversation buffer window, k is equal to 1. Creates a memory that only remembers the most recent interaction. Finally, the conversation variable is set up with the conversation chain, which links the model. Then we have verbose equal to false argument, means that the detailed logs of the conversation won't be shown, keeping the output clean. So let's run this. So here, basically, we have a conversation.predict, which basically sends the input, "Hi, my name is Andrew," to the model for processing. So this model uses the most recent exchange to generate a natural, relevant reply. This is how the conversation begins, with the model acknowledging or responding appropriately to the user's introduction. Then again, we are sending the question, "What is 1 plus 1?" to the model. The conversation object uses that input to generate an appropriate response. Since this is a simple math question, the model will likely respond with the correct answer as 2. This shows how the conversation dynamically builds on each exchange, maintaining the context and the respondingly accordingly. Since here the memory is set up to store the past interactions, the model can look back at the previous exchange where the user introduced themselves as Andrew. So your name is Andrew. This ensures the conversation feels natural and coherent with the model remembering and re-answering the prior inputs. So here we have a conversation token buffer memory, and we will run this. So here the code starts by importing the conversation token buffer memory from the LangChain, which is a type of memory that basically stores the conversation history in terms of tokens. So the OpenAI is imported from the LangChain.LLMs. Next, the LLM variable is initialized with the chat OpenAI, setting the temperature to 0.0 for deterministic responses and selecting the model based on the LLM model. This ensures that the model will generate the consistent outputs based on the given version. So let's run this. So here we are basically storing the conversation history based on the tokens and limits the total tokens to 50 to manage the memory efficiently. So 3 interactions are saved using the save context, each with a user input and the model's corresponding output. So these exchanges are stored in the memory with the most recent conversation, potentially pushing out the older ones if the total token count exceeds the max token limit of 50. So let's run this. So here the line memory.load memory variables is used to load the current stored memory from the conversation token buffer memory. The empty dictionary again indicates that no filters or conditions are applied. Essentially, this command allows you to access the stored conversation context, such as the inputs and the outputs the model has processed, giving you a snapshot of the conversation's history up to that point. It's useful for reviewing or manipulating the memory contained during the interaction. So let's run this. So after we have imported memory to the model, let's understand chains in the LangChain in the next chapter. Now, let us understand what is a chain. In the context of LangChain, a chain is a sequence of steps or components that work together to accomplish a specific task. These steps can be individual operations such as generating text, using a language model, or storing data in memory. A chain can link different parts of the process like the model, the memory, and the tools, ensuring everything flows smoothly from one step to the another. Think of it like a relay race where each runner passes the baton to the next runner, completing the task as a team. Then let us understand why chains matter. So chains organize tasks. They help structure and streamline the way different tasks are carried out in a process. Then, without chains, managing operations become complex. So without a chain, you would need to handle each operation separately, which can get complicated, especially when combining different models, tools, or information sources. Then we have chains create a clear workflow. They set up a repeatable process where each step builds on the previous one, making everything flow smoothly. Then we have chains help scale complex tasks. By using chains, it becomes easier to manage and scale complex systems, ensuring all the parts work together harmoniously. Then we have chain simplify and automate tasks. They reduce the need for manual work, making it easier to handle repetitive tasks automatically and saving time and effort. The first is input is provided. You start by giving an input to the chain. Then we have processing the input. The input passes to the first step in the chain, which could be a language model or a tool that generates a response based on that input. Then we have modify or store the response. The response from the first step is passed to the next step, which could involve storing that response in memory, modifying it, or performing another action like data processing. Then we have output is produced. The final step processes everything and output the result, whether it's an answer, action, or another response. Then we have behind the scenes operation. The chain handles all of these steps automatically, so you don't have to worry about each individual operation, letting you focus on the higher level task. So think of it like an assembly line where all the raw materials, that is the inputs, are processed at different stages to create the final product, that is the output. Now let's see everything in action. So this little piece of code is using Python's warnings module, which is kind of like a built-in system that alerts you if something might go wrong in your code. So this can be helpful if you are working with the code that gives harmless warnings and you just want a cleaner output, but just can be careful not to miss anything important. So let's run this. Here the code is using the Python's .env module to load environment variables from a .env file. So first it imports the necessary functions like the load.env to load the variables and the find.env to locate the .env file. Then the dash is a common way of saying I don't need to use the result of this, just do it. So basically it's setting up your program to securely read any private settings it needs from a little file without hard coding them into your script. So let's run this. So this code I have already explained before. The code checks the current date has passed a specific target date, that is June 12, 24, and then it decides which version of the language model to use. So let's run this. So let's now install pandas. So here basically we are importing the pandas as PD and then we are reading that CSV file, and so I have run this. So this is basically to see the first few rows of the particular file, and you can basically see 0, 1, 2, 3, 4, 5 rows. So here we are again importing some things from the LangChain, chat OpenAI chat prompt template, and then LLM chain. So this line of code is creating a new instance of the chat OpenAI model from the LangChain library. The temperature is again set to 0.9. Setting controls how creative or random the model's responses are. A higher temperature of like 0.9 makes the responses more diverse and less predictable, while a lower temperature makes them more focused and deterministic. So let's run this. So here we are basically creating a prompt template using the chat prompt template dot from template. So the template here asks what is the best name to describe a company that makes particular product, where product is a placeholder that will be filled in with an actual product name when used. So when you use this prompt, you can plug in any product name like bicycles or gadgets, and the model will respond with the suggested company name based on that product. So it's a way to make the prompt flexible and reusable for different scenarios. So here basically we are creating a new LLM chain object, which is a way to link the large language model with a specific prompt. So let's run this. So here in this code, the variable product is set to the value of queen size sheet set, which is a product for which the model will generate a response. So the line chain.run product is using the LLM object to run the model with the given prompt, filling in with the placeholder of with queen size sheet set. So when this runs, the model will use the prompt what is the best name to describe a company that makes a queen size sheet set to generate an answer. So here basically we are importing the simple sequential chain from the LangChain.chains module. Then simple sequential chain is a tool in the LangChain that allows you to create a sequence of tasks where each task output is used as the input for the next one. So We'll run this. So this code sets up a sequence to generate a company name based on the product description using a language model. So LLM is equal to chat OpenAI. This basically creates an instance of the chat OpenAI model with a creativity level of 0.9 and specifies the model to use. Then we have first prompt is equal to chat prompt template and everything. So this creates a prompt template that asks the module for the best company name for a product. So the part is a placeholder that will be replaced with an actual product name when you see it. Then we have chain 1 is equal to LLM chain. This creates LLM chain linking the language model with the prompt. The chain is set up to take the model input as input, apply the template and generate a response suggesting a company name. So we'll run this. So here the part of code sets up a second chain of the actions. First it creates a new prompt template called the second prompt which asks the model to write a 20-word description for a company. Then it creates a second chain, that is chain 2, which links the same language model to this new prompt. So this idea is that after the first chain generates a company name, this second chain will take the name and generate a short 20-word description of the company. So let's run this. So this line of code creates a simple sequential chain called the overall simple chain, which combines the two chains. So the simple sequential chain is used to link these two tasks together in a step-by-step manner. So the verbose is equal to true part ensures that the process will print out the detailed information about each step as it runs, so you can see what's happening during the execution as well. So let's run this. So here in this code, by calling the overall simple chain.run product, you are actually triggering the entire process in one go, and the model will output both the company name and the description based on the input product. You can see. So let's begin with the sequential chain, and for that we are importing sequential chain from the LangChain. Now here we can basically see that we have prompt template 1, that is translate the following review to English. And then we have chain 1, that is output key is equal to English review. So let's run this. So just like the first one, we will pass various second prompts and chain 2. And here in the second prompt, we have can you summarize the following review in one sentence? And for chain 2, we have output key is equal to summary. So let's run this. So here we have prompt template 3 translate to English. Third prompt, that is what language is the following review. And then we have chain 3, that is output key is equal to language. Then we have a fourth template and chain 4 as well, and we'll run this. So this code basically creates an overall chain that combines all 4 chains into one continuous process using the sequential chain. So the overall chain is designed to take a review as input and produce the 3 outputs. And the first translating the review, then summarizing it, then identifying the language, and then finally generating the follow-up message. So the input variables review specifies that the input to the overall chain is the review, while the output variables indicates that the outputs will be these 3 values. The verbose is equal to true part ensures that the details of each step in the process will be printed for clarity. So let's run this. I have already run it. So in this code, the review is equal to df.review5 selecting the 6th review since indexing starts at 0. From the column review in the df data frame and storing it in the variable review. So let's run this. So in this code, 4 different templates are defined to guide the language model's responses depending on the subject of the question. So here each template sets the context and the tone for how the model should respond depending on the area of expertise. The physics template, this template sets the model as a smart physics professor who answers questions about the physics in a clear and concise way. Math template, here's a model is set up as a good mathematician who answers the math question by breaking down the complex problems into simpler components. Then we have history template. So this template positions the model as an expert historian with the deep knowledge of people, events and contexts from various historical periods. Then we have computer science template. So this sets the model as a successful computer scientist with strong problem solving skills, knowledge of algorithms, and the ability to explain the coding solutions clearly. So each template has a placeholder, that is input, where the actual question will be inserted when the template is used. So let's run this. So here we have basically the prompt infos list is created to store the information about the 4 different subject areas like the physics, maths, history, and computer science. So each item in the list is a dictionary containing the 3 keys: name, description, and the prompt template. So the prompt infos act as a collection of the subject specific templates and descriptions that can be used to choose how the model should respond based on the area of expertise. You can use this information to select the right template for the model when asking for a question about a specific topic. So I'll give this as input. So here we are basically importing the multi-prompt chain, the LLM router chain, router output parser, and the prompt template from the LangChain.chains and prompts. So let's run this. So basically we have created an instance of the chat OpenAI model, setting its temperature to 0, which means the model responses will be very focused and deterministic. And the model is equal to LLM model. Part specifies which version of the model to use, with the LLM model being a variable that holds the model name, for example, GPT 3.5 Turbo. So basically this is a configuring state. So this code is basically setting up a dynamic system where multiple chains are created based on the subject areas and stored in the dictionary. So finally, when the list destination is joined into a single string, there is a destination str with each entry separated by a new line. The destination str will contain a neatly formatted list of all the available subject areas with their descriptions, which could be useful for displaying options or instructions for the user. So in short, this code dynamically creates a set of chains based on the subject areas and prepares a list of these subjects with descriptions. So for here, we have a default prompt is created using the chat prompt template .from template. This is a simple template that takes whatever input is given and passes it along to the model without any specific formatting or modification. So the input placeholder just ensures that the text provides as its input is directly used, as in making this template a catch-all for any input. So here we have created the multi-prompt router template. Is designed to basically select the best suited prompt for a given input. It provides a task where the model is given several prompts with a description and has to choose one that fits the input. The model can also modify the input if needed for a better response. The output is a markdown code snippet with a JSON object containing the 2 value pairs: destination and the next inputs. The candidate prompt section lists the available prompts, and the input placeholder holds the raw text input. So the template helps route the input to the most relevant prompt based on its content, allowing dynamic handling of different tasks. So here, this code sets up a dynamic routing system that selects the most appropriate prompt for a given input using the multi-prompt router template. So first, if it creates the router template by formatting the multi-prompt router template with the destination str, which contains a list of available prompts and their descriptions. So in essence, this code basically sets up an intelligent routing system that dynamically evaluates the input and routes it to the appropriate prompt, making the system flexible and adaptable to various types of queries. So here basically this line of code sets up multi-prompt chain which combines the routing system and the multiple destination chains in one cohesive workflow. In summary, this code basically creates a flexible and comprehensive multi-prompt chain that dynamically routes inputs to the best suited response based on the context, with a fallback option for general queries. So this line of code basically executes the chain.run method with the input what is black body radiation. So when the chain is run, the first step is that the router chain evaluates the input question to determine the most appropriate prompt. Given that the question is related to a physics concept, the router chain will likely route to the input to the physics prompt. Next, the system generates the corresponding physics chain from the destination chains dictionary to process the question. Lastly, because the verbose is equal to true setting is enabled, the system will print the detailed information about the routing process and the response is generated, making it clear how the input was processed and which prompt was used to generate the answer. So here we are basically running when the code chain.run, why does every cell in our body contain DNA? So is executed, the routed chain will evaluate the input question and the default chain will then handle the question and the language model will generate a general response that might explain the importance of DNA in the cells. With verbose is equal to true, the process will log the routing decisions and show how the question was processed, including any details about which prompt was chosen and what response was generated. So, after we have actually understood all this, let's now see on the next chapter what is about building smart QA systems with the LangChain. So now we have what is QA. QA or question answering is a task in natural language processing where the goal is to develop models or systems that can understand and respond to the questions posed in the natural language processing. So essentially it's about teaching machines to answer questions based on either a given passage of text, knowledge base, or even their understanding of the world. Then let us understand why is QA so powerful. QA is powerful because it enables machine to interact with the humans in a way that mimics how we process and respond to information. So, QA systems have the ability to provide instant answers. So, QA systems can quickly deliver accurate answers to a wide variety of questions, which can be incredibly helpful in fields like customer service, education, or research. Then we have enhanced user experience. So, with accurate human-like responses, QA systems improve the user experience, allowing people to get the information they need more efficiently. Then it has handled complex queries. Advanced QA systems, particularly when integrated with LLMs, can process complex multiple-step questions that require reasoning or understanding beyond simple factual recall. Now let us understand how does QA work. So, the process begins when the user provides a question ranging from simplex to complex. The next is in LangChain, the question is routed through the prompt templates or chains to refine it before processing. The language model processes the input and generates an answer based on its knowledge. Then we have once processed, the model generates an output that is displayed to the user. Then, if we needed, a feedback loop may ask for clarification for ambiguous or the complex questions. Now, let's see all those in action. So here basically we are installing the upgrade LangChain and let's run this. So here basically we are configuring our Python environment to securely manage the sensitive information like the API keys or database credentials. So here by importing the load.env and the find.env functions from the .env package, you enable your application to locate and load the environment variables from a .env file with your environment. So the find.env function searches for the env file starting from the current directory and then the path to the first.env file it finds. The load.env function that loads the environment variables from this file into your environment. So finally run this. In this code, the goal is to select the appropriate version of the GPT 3.5 Turbo model based on the current date, considering the model's deprecation timeline. So the code first retrieves the today's date and sets a target date of June 12, 24. It is significant because the certain versions of the GPT 3.5 Turbo, such as the GPT 3.5 Turbo 0613, were deprecated around that time. So I have explained this before. So here we are importing some retrieval QA, chat, OpenAI, CSLV, loader, doc array, in memory search, display, markdown, and OpenAI from the LangChain chains, chat models, document loaders, vector stores, delays, basically the environment variables to set up a particular project. So in this code, you are utilizing the LangChain CSLVL loader to load the data from a CSV file named the outdoor clothing catalog. By creating an instance of the CSVL loader with the specified file path, you are preparing to read the CSV file and convert each row into a document object. So let's run this. So here basically we are importing the vector store index create on LangChain.indexes, and let's run this. So here we are installing the doc array and we will install this. So here basically we are creating an index to efficiently search and retrieve the documents using the LangChain's vector store index in combination with the doc array memory search. So by specifying the vector CLS equal to doc array in memory search, you are opting for an in-memory vector store that allows for the exact search capabilities. So we'll run this. So here when selecting shirts with the sun protection, it's important to consider the material, weave, density and color as these factors influence the UV shielding effectiveness. So brands like Solumbrum socialize in clothing with a high UPF ratings, providing garments that block a significant amount of UV rays. So here we are basically setting up a question answering system using the Llama index with the OpenAI's GPT 3.5 Turbo Instruct model by specifying the LLM represent model equal to OpenAI temperature is equal to 0 and the model is GPT 3.5 Turbo. So we are configuring the system to use the specific model for generating responses. So here we'll run this. So here we are basically utilizing the IPython's display and markdown functions to render the response object as formatted markdown within a Jupyter notebook. So by passing this response to the markdown, you are instructing IPython to interpret and display the content with appropriate markdown formatting. And now basically you can see the output. So in this code, you are utilizing the LangChain CSVL loader to load data from a CSV file into a list of document objects. So by specifying the file path, LangChain reads the CSV file and converts each row into a document where each column in the row becomes a key value pair in the document's content. So we'll run this. So here the loader.load method reads the CSV file specified by the file path and converts each row into a document object. So each document contains the data from one row with the columns represented as the key value pairs in the document's content. So let's view the first document over here. And you can see you have got the output. So here basically we are creating an instance of the OpenAI embeddings class from the LangChain, which allows you to generate the vector representations for the text data using the OpenAI's models. So embeddings are the numerical vectors that capture the semantic meaning of the text, enabling the applications like the semantic search, clustering and the recommendation systems. So by initializing the embeddings, you are setting up the system to use OpenAI's default embedding model. So here basically we are using the embed query method from the LangChain's OpenAI embeddings class to convert the input text, "Hi, my name is Harrison," into a numerical vector representation. So this transformation basically captures the semantic meaning of the text, enabling applications like the semantic search and the clustering to process and analyze the content effectively. So here basically we are determining the dimensionality of the vector generated by the text embedding adder. So this model produces embeddings with the 1536 dimensions, meaning the length of the embed vector will be 1536. Here, by executing the print embed :5, you are displaying the first 5 elements of the embedding vector for the phrase "Hi, my name is Harrison." So in Python, the slice notation of :5 retrieves the elements from the start up to but not including the index 5. So this operation allows you to inspect the initial components of the embedding, which are numerical representations capturing the semantic meaning of the text. So here basically in this line db is equal to doc array memory search, you are creating an in-memory vector stored using the LangChain's doc array in-memory search. So this store allows for the efficient similarity searches within your dataset. So let's run this. And we are passing one query, please suggest a shirt with the sun blocking. And now basically you can just pass this query, call this similarity search and check. Now let's see the length of the docs. It's 4. And now here we can actually view the first document. And now basically you can retrieve the DB and we are again calling the chat OpenAI using the temperature is equal to 0 and model is equal to LLM. For here, this is basically a for loop for I in range of length documents, and we are passing one response calling this LLM function. Now let's see this display, and now basically you can see this verbose equal to true for this LLM equal to LLM, chain type equal to staff, and now we are basically passing one query over here. Now basically you can see the response over here, and now you can basically see the markdown response, and now you will gonna see that we have passing this query in this response, index.query, query and LLM. So we'll run this. So here we are basically creating embeddings and vector store and then calling the loader class, and finally we'll run this. So after we have a basic understanding of how question answering actually works, we'll see how to actually evaluate the system we have created. So here basically we are importing the necessary modules to load the environment variables from a .env file using the .env library. So it first imports the OS module, which provides functionality to interact with the operating system, including the environment variables. Then it imports the load.env and find.env from the .env module. Then let's run this. So I have basically explained this almost 2-3 times, so I'm not explaining once again. So we'll run this. So here once again we are importing the retrieval QA from LangChain, then we are importing chat OpenAI, then we are importing CLVL loader, then we are importing vector store index and doc array in memory search. So we'll run this. So this code loads data from a CSV file named outdoor clothing catalog 100.cav. So it first defines the path in the file variable, then uses the CLVL loader class from the LangChain document loaders to load the CSV file. So we will run this. So here the code creates a vector store index using the vector store index creator class. It specifies the doc array in memory search as the class for the vector store, which stores the document embeddings in memory for efficient search. The from loaders method loads the data from the previously defined loader, processes it and creates an in-memory index that can be used for the fast document retrieval based on the vector embeddings. So we'll run this. So this code basically sets up a question answering system using the retrieval QA class that initializes a language model with the chat OpenAI, setting the temperature to 0.0 for deterministic responses. The QA system is then created using the from chain type method, where the model processes data in the stuff chain, and the vector store is used as the retriever to fetch the relevant documents for question answering. So additionally, verbose logged is enabled for tracking the process, and a custom document separator is then specified. So let's run this. Coming up with the test data points, that is, in this code the data 10 is accessing the 11th element. So let's see. So in this code data 11 is accessing the 12th element, since indexing starts at 0 from the data list or array. If data contains the rows loaded from the outdoor clothing catalog 1000.csv file, this will return the 12th row of data. So the structure of the data will depend on how the CSV file was loaded. So if data is a list of dictionaries or a similar structure, data 11 will give you the dictionary or row that corresponds to the 12th entry in the CSV. So here the code defines a list called examples, which contains the 2 dictionaries representing the question answer pairs. Each dictionary includes a query key with the question being asked, such as, do the cozy comfort pullover set have side pockets, and what collection is the ultra lofty 850 stretch down hooded jacket from. So the structure can be used for training or testing a question answering system where the questions are matched with their correct answers. So let's run this. So here basically we are importing the QA generate class from the langchain.evaluation.qa, and here the code initializes a QA generated chain object using the from LLM method. Here's a breakdown of what actually basically happening. So example gen chain is equal to QA generated chain dot from LLM. This creates a QA generated chain object called the example chain, which is set to generate the question answer pairs. Then we have chat OpenAI model equal to LLM model. This initializes the chat OpenAI model with a specified LLM model. So in summary, this code actually sets up a chain that can generate the question answering pairs used as a language model through the chat OpenAI class, which can be used for the various QA tasks. So here this code generates a new question answer pairs by applying the QA generator chain to the first 5 documents in the data list. So it uses a list comprehension to create a list of the dictionaries where each dictionary contains a document wrapped with the key doc. So then let's move on. So let's have a look on the first example. Then let's see the first data we had. And this is the document page. This is basically incrementing the examples with the new examples, and we'll run this. And then we have this code executes the first query. And from the examples list by accessing the query field of the first example, which is in this case is do the cozy comfort pullover set have side pockets. So here when you set the LangChain.debug is equal to true, you are telling the LangChain library to show the detailed information about what it's doing behind the scenes. It will print out the debugging messages and like the errors, messages, and it takes the step it's taking while running your code. Now let's see the first query, and you can basically see it is debugging. So basically we are turning off the debug mode over here. So let's now move on and see how to build agents with the LangChain. So in this lesson of building agents with LangChain, we will basically see how to actually build agents. We are first importing the OS, then from .env we are importing load.env and find.env, basically for reading the local env file. And then we are importing the warnings for warnings.filter warnings ignore. Basically we are creating the project environment. And then this code is designed to automatically switch to a newer version of the LLM model after a specific date. It first imports the datetime module to handle the date operation, then retrieves the current date. So we'll run this. So here basically we're storing the Wikipedia and we'll run this. So here we are finally importing the create Python agent, and then we're importing load tools, initialize agent, agent type, Python RPL tool, then we're importing Python RPL and chat OpenAI. So we'll run this. Basically path of the configuration. We are calling the chat OpenAI. We are setting the temperature to 0 and passing the model as LLM model. So we'll run this. And then basically we are using the load models LLM Math Wikipedia, loading a set of tools, and then we are running this. So basically we are this line of code basically loads a set of tools, especially LLM Math and the Wikipedia, and associate them with the previously defined language model. So here again we will move on. So here this line of code initializes a chat based agent using the initialize chat agent function, setting it up with the specified tools like LLM Math and Wikipedia. The agent is configured as agent type.chat0, and then we'll run this. So this line of code basically processes the query, what is 25% of 300. When the agent is called with this input, it will leverage the tools and the language model defined earlier to compute the result, especially the LLM Math tool will handle the mathematical calculation and the agent will respond with the correct answer. So in this code, the variable question contains a query asking about the book written by Tom Mitchell, an American computer scientist and a professor at the Carnegie Mellon University. So in this case, the agent will likely return the name of the book written by the Tom M, which is machine learning, a well-known textbook in the field of machine learning. So this result is stored in the result variable. So we'll run this. You can basically see the observation, the thought, then again observation, page, line. I have found that Tom M wrote the book Machine Learning. I now know the final answer. This line basically creates a Python agent using the create Python agent function. This agent is configured with a specified language model to handle the task and generate responses. So it also uses the Python RPL tool, which allows the agent to execute the Python code in a real eval print loop. So we'll run this. So basically this is a customer list which contains the sublist. So each sublist represents a customer with two elements, the first name and the last name of the customer. For example, Harrison and Chase, and like this it follows. So we'll run this. This line of code instructs the agent to sort the customer list first by last name and then by first name. So the run method is called with the formatted string where the customer list is passed as part of the query. So I'll run this. So this code basically enables the debugging in LangChain by setting the LangChain.debug equal to true, which provides the detailed logs and information about the operations performed by the LangChain agent. Then it runs the agent to sort the customer list by the last name first and then by first name as requested. So we'll run this. Then we are installing this date time for defining our own tool. So to build our own tool, we are importing tool and date from datetime and tool from the LangChain.agents. This code defines a tool function called the time using the @tool decorator from the LangChain. The function takes a single parameter text which is expected to be an empty string and return the today's date as a string. The doc string clarifies that the function is specially designed to provide the current date and should only be used for this purpose. So let's run this. So this basically initializes an agent using the initialize agent function, which configures the agent with a combination of predefined tools and the newly added time tool for retrieving the today's date. The agent uses a specified language model to handle tasks and generate responses. So we'll run this. So this code basically attempts to query the agent with the question, what's the date today, by calling the agent with that input, expecting it to respond with the current date using the time tool. If the agent encounters any error during execution, such as issues with external access or tool failures, the program will handle it gracefully by moving to the expect block. In case of an error, the message exception on the external access is printed, indicating that something went wrong while trying to retrieve the information. So this setup ensures that the process doesn't crash and provides a clear error message if an issue occurs. So guys, congratulations on completing the LangChain for LLM app development course. You have taken a significant leap towards mastering the AI-driven language models and their integration. Now it's time to apply your skills, experiment with LangChain, refine your LLM's reasoning capabilities, and explore innovative ways to enhance the automation and contextual understanding. Keep pushing the limits of AI and unlock the full potential of LangChain in your projects.
Today we are exploring Hugging Face, an amazing tool that makes working with language and AI super easy. If you are curious about using advanced technology to understand or create text, this video is perfect for you. Hugging Face is a company that helps people use AI models for language tasks like translation, text analysis, or even generating new text. They have created a library called Transformer, which comes with pre-trained models, so you don't have to build everything from scratch. It's simple, powerful, and perfect for developers, researchers, or even beginners. So in this video, I will show you 3 cool things you can do with Hugging Face. Speech to text, turn spoken words into written text easily, great for captions or voice apps. Second one is sentiment analysis. Find out if a text is positive, negative, or neutral. Helpful for understanding reviews or comments. The third one is text generation. Create human-like text that sounds natural. Perfect for chatbots or creative writing. I will also explain some important basics like how pipelines make using Hugging Face models super easy and how tokenization helps AI understand text. By end of this video, you will know how to use Hugging Face to start building your own projects. It's simple, fun, and really powerful. Before we move forward, unlock the future of AI with comprehensive program in collaboration with ENICT Academy, IIT Guwahati. In just a few months, you will master cutting-edge skills in generative AI, large language models, and machine learning from learning tools like ChatGPT and DALL-E 2. to gaining hands-on experience with Python and TensorFlow. This course will equip you to lead AI projects and qualify for top roles like machine learning engineer or data scientist. Plus, with an IIT certificate on your resume, you will stand out to the best employers in tech. So don't forget to check out the course link from the description box below and the pinned comment. So without any further ado, let's get started. So welcome to this demo part of this video. So here, as you know, we will be doing three things. First thing, speech to text recognition. The second thing, text generation from a particular sentence or a word. And the third thing, we will do sentiment analysis. Okay, so we will perform this one by one. So let's start with something called speech to text recognition. Okay, using Hugging Face. So first I will rename this. I will write here Hugging Face speech to text. Okay, yeah. So first I will install transformers library. It is already installed on my system, but again, just for you guys, I'm doing this. Okay, pip install transformer. So now let's see what is transformers. So transformers is a powerful Python library created by Hugging Face. So that allows you to download, manipulate, and run thousands of pre-trained open source AI model. Fine. So as you can see, requirement already satisfied. It means like already installed. So these transformer models cover multiple tasks across modalities like NLP, natural language processing, computer vision, audio, and multimodal learning, like many things. Fine. So now I will do from transformers import pipeline. Okay, so now let's run it. So now what is pipeline? Okay, so a transformer pipeline describes the flow of data from origin system to destination system. Fine, because you already know transformer means you can run or manipulate thousands of pre-trained open source AI model. So pipeline describes the flow of data from origin system to destination system and defines how to transform the data along the way. Okay, so let's check the versions transformers version. Okay, that long tab. Okay, why it is coming? Import transformers. Yeah, so we have currently 4.42.4 version of the transformer. Okay, so I'm using Google Colab. Okay, so you can use either Jupyter Notebook, Visual Code Studio, or Colab. Okay, so now let's import libraries. Import Librosa. Okay, so what is Librosa? So Librosa is a Python package for audio and music analysis, right? Because we are doing speech to text, so we need this. So it provides various functions to quickly extract key audio features and matrices from the audio files. Okay, and this Librosa can also be used to analyze and manipulate audio files in a variety of formats such as WAV wave, MP3, M4A, and like that. Okay, so next we will import Torch. I hope everyone know Torch. So Torch is nothing PyTorch. It is a machine learning library based on the Torch library used for applications such as computer vision and NLP. And originally it was developed by the Meta AI and now the part of Linux Foundation, umbrella. Let's import one more thing. Import. So now let's import IPython. Okay, capital IPython dot display as display. So now you will be wondering what is this IPython display. Okay, so it is an interactive command line for the terminal for Python, and it it can provide a IPython terminal and the web-based notebook platform for Python computing. And this IPython have more advanced features than the Python standard interpreter, and we quickly execute a single line of Python code. Nothing. Okay, for that I'm using this. And the next is from transformers import WAV to vectorizer for CTC and WAV to vectorizer to tokenizer. Okay, so now what is this? So WAV2 vectorizer for CTC is supported by the notebook on how to fine-tune a speech recognition model. Okay, and this tokenizer. So tokenizer is nothing. Tokenization is a conversion of a text into meaningful lexical tokens belonging to categories defined Lexa program. In case of NLP, so those categories include nouns, verbs, adjective, punctuation, etc. Okay, now, and the last library, let's import NumPy as NP. I hope everyone know NumPy. What is NumPy? Again, NumPy is a Python library used for working with arrays. It also has a function, for working in domain like linear algebra, Fourier transform, and matrices, and many others. Fine. I hope everyone know about these library which we have imported. Okay, so let's move forward by tokenizer equals to 2 to tokenizer dot from pre-trained. This is why I love this Google Colab. You will decide just some words and it will show the suggestions. Facebook. So this is again one pre-trained model. Okay, so we are just importing it. Base 968. This is nothing, the name. Okay, then model equals to WAV2 for CTC dot from pre-trained, then Facebook WAV2 vectorizer 2, then base 960. Fine. Now let's run it. So now you can see. So we are loading this. Okay, they are downloading. Okay, so you can ignore these warning. So now let's load the audio file. So here I will write audio sampling rate equals to librosa dot load. Okay, so you know about librosa, right? Then I have v dot m4a. So I have already one speech or one audio, you can say. So I will play it, don't worry. Before the final output, I will show you 16,000. Okay, so now I will write okay, I've already loaded, I guess. Okay,
Okay, no issues. I will load again. Okay, the file is loaded. I will rename it to V. Yeah, fine. So now it won't, the error won't come again. We have v.mp4a. Okay, so now we have to do. Okay, let me try it. We have v.mp4a, but I don't know why it is not coming. Okay, let me copy the path. Now it will run, I guess. It's running. Yeah. So now I will write here audio, comma, sampling rate. Okay, now listen carefully. Then I will write display dot audio, then path, comma, autoplay equals to true. Okay.
Hello and welcome. This is an AI voice message.
I guess you heard, but again, let me play it again.
Hello and welcome. This is an AI voice message.
Okay, so it is saying hello and welcome. This is an AI voice message. Fine. So now what I will do, I will input some values. Input values equals to tokenizer, then audio, comma, return tensors equals to pt. Fine. Dot input values. Okay, then here input values. Okay, input values. Okay, yeah. So now logits will come here. So we have to now store the logits, which means non-normalized predictions. Okay, so logits equals to model input values dot logits. Okay, then here I will write logits. Okay, it's running. Done. So now what we will do, we will store predicted IDs, then we will pass the logits to values to softmax to get the predictive value. Okay, so here I will write predicted IDs equals to torch dot arg max. Okay, then logits comma dimension equals to -1. Okay, then I will pass the prediction to the tokenizer decode to the transcription. Okay, so here I will write transcriptions equals to tokenizer dot decode predicted IDs to 0. Running fine. So now let's see our output transcriptions. So now you can see hello and welcome. This is an AI voice message. So now let's play it again.
Hello and welcome. This is an AI voice message.
Amazing, right?
So this is how you can use Hugging Face for the speech to text recognition. It's a very small code, line of code, as you can see. Okay, so now let's move forward and do the sentiment analysis, okay, or text generation. So let me open new drive. So yeah, so now I will write here, I will write sentiment slash text generation Hugging Face. Okay, so first of all, let's import the files. So first I will write import warnings, then warnings dot filter warnings. Okay, I will write here ignore, then we'll import numpy. You already know what is numpy, and import panda. So these are some basic Python library, and I hope everyone knows. And import matplotlib for the plots, matplotlib dot pyplot as plt. Then I will import cbon for the graphs, the statistics graph. Okay, sns, then sns dot set. So now we'll import sklearn model train trace split. So sklearn is nothing, scikit-learn is probably the most useful library for machine learning Python. So this library contains a lot of efficient tools for machine learning and statistical modeling, including classification you can do, regression you can do, clustering you can do from this sklearn. Okay, from sklearn dot model selection import train trace split from sklearn dot matrix import f1 score comma confusion matrix comma ROC AUC curve or score. So again we will import teams from transformers, import pipeline, everyone know what is this, then import torch. Okay, now let's run it. You have too many active session, terminate existing to continue if you are interested in using one more session. Okay, wait, yeah, fine. Now which one is open, bro? Terminate this, terminate this, terminate this. No. Okay, fine. So now let's do sentiment analysis. So we will explore sentiment analysis using a pre-trained transform model. Okay, the Hugging Face library provides convenient pipeline, as you already know, function that allows us to easily perform sentiment on the text. So now let's first import the necessary dependencies and create a sentiments pipeline using this line. So I will write here classifier equals to pipeline sentiment analysis, then type classifier. Okay, so it will download the pre-trained sentiment analysis pipeline. Pipeline is not defined. How? Okay, error is there. I hope it will run now. Yeah. So now we can pass a single sentence or a list of sentence to the classifier and get the predictive sentiment labels and associate confidence score. Fine. So now just for the testing classifier, so let's write this is a great movie. Okay, now let me run it. So now you can see here label positive. So label positive typically refers to the outcome or a class of interest that the model is designed to predict. So here we are just checking the sentiment analysis model. Okay, so this is why I wrote this. Okay, so let's check one more. This was a great course. Then I did not understood any of it. Now let's check this. Yeah, perfect. And the score, you can see the accuracy score 99%, which is almost close to 100%, and which is amazing. So now you have access to a GPU, so you can also utilize it for the faster processing by specifying the device using the parameter. Okay, so now what I will do first, I will wait. Yeah, fine. So now I will import dataset airline tweets equals to pd dot read. PD means pandas library here we are using. Okay, now first import. I will import here itself. So I have tweets.csv. Okay, tweets.csv. Let it upload. Yeah, done. So now let me airline tweets dot head. Why dot head? Means it will show me the top 5 rows. Okay, 0 1 2 3 4 5. Okay, you can see tweet ID, airline sentiment, neutral, positive, neutral, negative, then this. Okay, so now let's do something. Okay, so what I will do, df means data frame airline tweets, then I will write airline sentiment. We have airline sentiment, this column. Okay, comma text. I need these 2 columns. Okay, df dot head 5. So yeah, so airline sentiment is neutral, and this is what this text is all about. Okay, because these 2 are the main things, text and the sentiment. So now let's make plot, count plot. Then I will write df comma x equals to airline sentiment, then palette equals to with this. Then here I will write plt dot x label airline sentiment. Okay, then plt dot y label count plt dot show. So it will draw one graph. Okay, spelling is wrong. Yeah, so it will show neutral, positive sentiment and the negative. So as you can see, the negative sentences or the sentiments are the more. Okay, so we have now three classes which do not match the two class available in the Hugging Face pipeline. So therefore we will filter out all the rows which have been labeled as neutral. Okay, so df equals to df and again df airline sentiment fine was not equals to neutral. Okay, then df target equals to df airline sentiment dot map. Then I will write here positive 1 and the negative 0. Fine, negative will be 0. Okay, then print number of rows comma df dot shape. Okay, so now you can see number of rows are 11,541. Okay, so now I will write predictions 5. It will, okay, predictions is not defined. Okay, so now what I will do, so here I will write text equals to df text and to list dot to list. Then here I will write predictions equals to classifier text. Okay, so here write probabilities equals to predictions, then score if predictions label dot starts with P means positive. Okay, else 1 minus prediction score. Okay, then I will add for prediction and prediction. Why it is not running? This is taking time, too much time. I don't know why. So as you can see, finally we have the output of predictions values. So this depends on system to system. My system took almost 17 minutes 47 seconds to complete. Okay, so now let's run it. Okay, predictions is not defined, bro. Now predictions. Yeah, so now I will write here predictions equals to np dot array. Np means numpy dot array. Then I will write 1 if prediction label is positive dot starts with P, okay, else 0 for prediction and prediction values. Yep. Okay, fine. So now let's check the accuracy of our model. Print accuracy. Okay, then I will do round up the values. So here I will write np dot mean, then df, then the target, right? Yeah, then I will write equals to predictions, then I will write into 100 comma 2, then I will write percentage. Okay, fine, looks good. Yes, so as you can see, our accuracy is 88.99%, which is very good again. So now let's do some confusion matrix. Confusion matrix, then df target comma predictions comma normalize equals to true. Okay, then I will plot confusion matrix. Okay, df then target comma predictions comma normalize equals to true. Okay, my bad. Right here, confusion matrix comma labels. Okay, so here I will plot a confusion matrix using Seaborn. Okay, so here I will use ARGS, which is confusion matrix np.nArray, so which is labels list. So I will write plt dot figure, then figure size equals to 8,6. That's SNS dot set font scale equals to 1.4. Okay, then let's create the heat map. Confusion matrix comma and not will be true. Okay, then I will write fmt equals to g, then confusion map equals to blues, then x6 labels equals to labels, then y 6 labels equals to labels. Okay, yes, so now I will write plt dot title will be confusion matrix, then plt dot x label will be predicted values, then plt dot y label will be actual values, then plt dot show. Okay, why the chart is not coming? Okay, so I have to write plot confusion matrix, then I write CM, then negative, comma, positive. Okay, now the chart will come. Okay. Yeah. So now you can see here, this is actual, and this is a confusion matrix, and the negative and the positive ratio is there. Okay. So now let's print the, now let's check the ROC AUC score. So I will write here print ROC AUC score. Then here I will write ROC AUC score, then TF target, comma, props. Okay, so 94. Okay, so first let me tell you what is this ROC AUC score. So this is the area under the ROC curve. So what it does, it sum up how well a model can produce relative scores to discriminate between positive and the negative instance across all the classification threshold. So with this ROC score of 94, 0.94, which is 94%, we can conclude that a pre-trained sentiment analysis model has achieved a high level of accuracy and effectiveness. So in predicting the sentiment labels. So this indicates that the model is capable of accuracy classifying text into positive or the negative sentiment categories. Okay. So now we'll do text generation. Okay, so text generation involves generating creative and coherent text-based thing. So I will write here text. Okay. So text generation involves generating creative and coherent text based on a given prompt or starting point. So what we will do first, we will import the necessary dependencies and load the data set of the poem. Okay, so here I am write poems. Let me write poems equals to pd.read.csv. Don't worry, I will give you these files. Okay, description box below I will add. So here I will write robot frost, okay, .csv. Fine, and then I will write poems dot head 5, or head, just have to write head. Module pandas has, okay, not dot underscore csv. Yeah, okay, it will show the top 5. Stopping by woods on a snowy evening, fire and ice. The aim was song, collection, content, year of publication. Okay, so now what we will do, we will write content equals to poems content dot drop na to list. Okay, so to generate text, we extract individual lines from the poems and use the pipeline text generation function to create a text generation pipeline. Fine, so here I will write lines equals to, then I will write for poem and content, okay, for line in poem dot split into next line. Okay, then lines dot append, then I will add line dot right strip. To the right it will add. Okay, fine. So now lines equals to line for line in lines if length of line 0, then show me the lines 5. Okay, so now you have seen here whose woods these are, I think I know. Then the next line, his house is in the village though. That's the next line, he will not sing. Okay, like this. So now let's import that pipeline text generation module. Okay, gen equals to pipeline. So these are the pre-trained model. You already know generation. Okay, so now I will write here lines. Let's run it. Yeah, done. So in line 0 we have whose votes these are, I think I know. Okay, so now we can now generate text by providing a prompt and specifying the parameters such as max length and num return sequence. Okay, why? Because we have imported this text generation module. Okay, for example, see lines 0 dot max length equals to 20. So now it will generate this to the maximum 20. Okay, till 20 word maximum length. Okay, check. Okay, expression cannot contain perhaps double equals to where? Okay, wait, now it will learn. So see, the line was this much only. Whose words these are, I think I know. Whose words these are, think I know. But here, the generated text, I wish to go to church because I feel like. Okay, this is how you can do, text generation. Now let's check for the more. Gen lines 1. Okay, then max length equals to 30, comma, num return sequences equals to 2. Okay, so our first line was this: his house is in the village though. Okay, 0 1 2 3 4 5. Okay, so here you can see his house in the village though. However, you might say that the place was the same with the place this. So these are the generated text. Okay, and this is another return sequence second. So there are two, one and the second. Okay, so now let me import text wrap. Okay, then creating function wrap x. I don't need this. Then return text wrap dot fill x comma replace white space equals to false comma fix sentence endings equals to true. Okay, So now out equals to generated lines 0 to maximum length equals to 30, then print wrap out to 0, then generated text. Okay, so now we are setting the pad tokens to EOS tokens. Okay, so whose these are, I think I know, and this is the maximum 30 till 30. Okay, so now I will write here, okay, preview equals to, okay, so now what you can do, you can generate a prompt to generate text on a specific topic like this. Prompt equals to transformers have a wide variety of application in NLP. Okay, so this is my prompt. Okay, this I'm not importing from the data set. Okay, so I will write out equals to gen prompt comma max length equals to 100, print wrap out. Okay, here I will write, anyways, here I will write generated text prompt. Okay, so it is running. Let's wait. Yeah, so okay, some error is there. Okay, so here the issue is with 100 words. Will go till 50. Yeah, so let me do it again. 100. Yeah, so now you can see we can generate text using by giving a prompt. So we have covered 3 topics in this. First thing is speech to text using Hugging Face. Second thing is sentiment analysis using Hugging Face, and the third is text generation using Hugging Face. Okay, and in this text generation we did with 2 methods, one with the data set and second thing with the by giving prompt like in ChatGPT, you can say. So now what is RNN? RNN are a type of neural network that are designed to process sequential data. They can analyze data with temporal dimensions such as time series, speech, and text. RNN can do this by using a hidden state passed from one timestamp to the next. The next hidden state is updated at each other timestamp based on the input and the previous hidden state. RNN are able to capture short-term dependencies in sequential data, but they struggle with capturing long-term dependencies. Why the LSTMs are made? So moving forward, let's discuss types of LSTM gates. So LSTM models have 3 types of gates: the input gate, the forget gate, and the output gate. So let's first discuss the input gate. The input gate controls the flow of information into the memory cell, deciding what to store. The input gate determines which values from the input should be updated in the memory cell. It uses a sigmoid activation function to scale the values between 0 and 1, and then applies pointwise multiplication to decide what information to store. Next is forget gate. controls the flow of information out of the memory cell, deciding what to discard. The forget gate decides what information should be discarded from the memory cell. It also uses a sigmoid activation function to scale the values between 0 and 1, followed by pointwise multiplication to determine what information to forget. The last one is output gate. Controls the flow of information out of the LSTMs, deciding what to use for the output. The output gate determines the output of the LSTMs unit. It uses a sigmoid activation function to scale the values from 0 to 1, then applies pointwise multiplication to produce the output of the LSTM unit. So these gates implemented using sigmoid function are trained using backpropagation. They open and close based on the input and the previous hidden state, allowing the LSTM to selectively retain or discard information, effectively capturing long-term dependencies. So now let's discuss application of LSTM. LSTM models are highly effective and used in various applications, including video analysis, analyzing video frames to identify action, object, and scenes. The second is language simulation, tasks like language modeling, machine translation, and text summarization. The third one is time series prediction, so predicting future values in a time series. The fourth is voice recognition, tasks such as speech to text transcription and command recognition. The last one is sentiment analysis, classifying text sentiment as positive, negative, or neutral. So there are many more examples of LSTM. So now let's move forward and understand LSTM model and how it works with example. Let's consider the task of predicting the next word in a sentence. This is a common application of LSTM networks in natural language processing. So I will break it down step by step using the analogy of remembering a story and deciding what comes next based on the context. So imagine you are reading a story. As you read, you need to remember what has happened so far to predict what might happen next. So let's illustrate with a simple example sentence. The cat sat on the dash. So you want to predict the next word, which could be mat or roof or something else. An LSTM network helps this make prediction by remembering important parts of the story and forgetting irrelevant details. So now let's dive into step-by-step process. So step-by-step explanation using LSTM. The first one is reading the story, input sequence. As you read each word in the word sentence, you process it and store relevant information. For example, you understand it's a determiner. Cat, you know it's a noun and the subject of the sentence. Sat indicates the action performed by the subject. On, preposition indicating the relationship between the cat and the next noun. So this sequence diagram showing the words being read and processed. So second comes forget gate. As you move through the sentence, you might decide that some details are no longer important. For instance, you might decide that knowing the is less important now that you have cat and said. So the word forget gate helps discard this less important information. So this sequence diagram you can see on the screen showing how relevant information is discarded. So the third one, input gate. When you read on, you need to decide how relevant this information is. So this sequence diagram in the screen is showing how new information is integrated with the last one. Okay, the fourth one is the cell state, memory part. So this is like your memory of the story so far. It carries information about the subject cat and the action sat on. So it updates the new information as you read each word. Okay, the cat sat on the, retaining the important context. So this sequence diagram showing how the memory is updated with the new information. So the last one is output gate. When you need to predict the next word, the output gate helps you decide based on the current memory, cell state. So it uses the context, the cat sat on the. So the predict the next word might be mat because cat and mat are often associated with the context. So it can predict anything. The cat sat on the table or on the sofa, anything. But mat, why I'm saying mat? Because cat and mat are often associated in the same context. So this diagram is showing the prediction of the next word based on the current memory. So there are many applications where you can use LSTM in predicting time series or next word in the sentence. So by the using of LSTM gates, input gate, forget gate, and output gate, and updating the cell state, the network can predict the next word in a sequence by maintaining relevant context and discarding unnecessary information. This step-by-step process allows LSTM network to effectively handle sequence and make accurate prediction based on the context. Hello everyone, I am Mank and welcome to today's video where we will be talking about LLM benchmarks, tools used to test and measure how well large language models like GPT and Google Gemini performs. If you have ever wondered how AI models are evaluated, this video will explain it in simple terms. LLM benchmarks are used to check how good these models are at tasks like coding, answering questions, and translating languages or summarizing text. These tests use sample data and specific measurement to see how well the model performs. For example, the model might be tested with a few examples, like few short learning, or none at all, like zero short learning, to see how it handles new tasks. So now the question arises, why are these benchmarks important? They help developers understand where a model is strong and where it needs improvement. They also make it easier to compare different models, helping people choose the best one for their needs. However, LLM benchmarks do have some limits. They don't always predict how well a model will work in real-world situations, and sometimes model can overfit, meaning they perform well on test data but struggle in practical use. We will also cover how LLM leaderboards rank different models based on their benchmark scores, giving us a clear picture of which models are performing the best. So stay tuned as we dive into how LLM benchmarks work and why they are so important for advancing AI.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
But before we start, here is a quick info for you. Dive into the future of AI with our Generative AI and Machine Learning course in collaboration with ENICT Academy, IIT Guwahati. Learn tools like ChatGPT, OpenAI, Hugging Face, Python, and more. Join masterclass led by IIT Guwahati faculty, engage in hands-on projects, and earn executive alumni status. This Generative AI and Machine Learning course enriches your career journey with comprehensive coverage on machine learning, deep learning, NLP, generative AI, reinforcement learning, computer vision, and many more. So don't forget to find the course link from the description box below and the pinned comment. So without any further ado, let's get started. So what are LLM benchmarks? LLM benchmarks are standardized tools used to evaluate the performance of large language models. They provide a structured way to test LLMs on a specific task or question, using sample data and predefined metrics to measure their capabilities. These benchmarks assess various skills such as coding, common sense reasoning, and NLP tasks like machine translation, question answering, and text summarization. The importance of LLM benchmark lies in their role in advancing model development. They track the progress of an LLM, offering quantitative insights into where the model performs well and where improvement is needed. This feedback is crucial for guiding the fine-tuning process, allowing researchers and developers to enhance model performance. Additionally, benchmarks offers an objective comparison between different LLMs, helping developers and organizations choose the best model for their needs. So how LLM benchmarks work? LLM benchmarks follow a clear and systematic process. They present a task for LLM to complete, evaluate its performance using specific metrics, and assign a score based on how well the model performs. So here is a breakdown of how this process works. The first one is setup. LLM benchmarks come with pre-prepared sample data, including coding challenges, long documents, math problems, and real-world conversation. The task spans various areas like common sense reasoning, problem solving, question answering, summary generation, and translation, all present to the model at the start of testing. The second step is testing. The model is tested on one of the three ways. Few shot, the LLM is provided with a few examples before being prompted to complete a task, demonstrating its ability to learn from limited data. The second one is zero shot. The model is asked to perform a task without any prior examples, testing its ability to understand new concepts and adapt to unfamiliar scenarios. The third one is fine-tune. The model is trained on a dataset similar to the one used in the benchmark, aiming to enhance its performance on the specific task involved. The third step is scoring. So after completing the task, the benchmark compares the model's output with the expected answer and generates a score, typically ranging from 0 to 100, reflecting how accurately the LLM performs. So now moving forward, let's see key metrics for benchmarking LLMs. So LLMs benchmark uses various metrics to assess the performance of large language model. So here are some commonly used metrics. The first one is accuracy or precision. Measure the percentage of correct prediction made by the model. The second one is recall, also known as sensitivity. Measure the number of true positive reflecting the correct prediction made by the model. The third one is F1 score. combines both accuracy and recall into a single metric, weighing them equally to address any false positive or negatives. F1 score ranging from 0 to 1, where 1 indicates perfect precision and recall. The fourth one is exact match. Tracks the percentage of predictions that exactly match the correct answer, which is especially used for the tasks like translation and question answering. The fifth one is perplexity gauges. Here it will tell you how well a model predicts the next word or token. A lower perplexity score indicates better task comprehension by the model. The sixth one is BLUE, bilingual evaluation understudy. Is used for evaluating machine translation by comparing n-grams, sequence of adjacent text element, between the model's output and the human-produced translation. So these quantitative metrics are often combined for more through evaluation. So in addition, human evaluation introduces qualitatively factors like coherence, relevance, and semantic meaning, provide a nuanced assessment. However, human evaluation can be time-consuming and subjective, making a balance between quantitative and qualitative measures important for comprehensive evaluation. So now let's moving forward see some limitation of LLM benchmarking. While LLM benchmarking are valuable for assessing model performance, they have several limitations that prevents them from the fully predicting real-world effectiveness. So here are some few. The first one is bounded scoring. Once a model achieves the highest possible scores on the benchmark, that benchmark loses its utility and must be updated with more challenging tasks to remain a meaningful assessment tool. The second one is broad dataset. LLM benchmark often rely on sample data from diverse subjects and tasks. So this wide scope may not effectively evaluate a model's performance in edge cases, specialized fields, or specific use cases where more tailored data would be needed. The third one is finite assessment. Benchmark only tests a model's current skills, and as LLMs evolve and the new capabilities emerge, new benchmarks must be created to measure these advancements. The fourth one is overfitting. So if an LLM is trained on the same data used for benchmarking, it can be lead to overfitting, where the model performs well on the test data but struggles with the real task. So this result is scores that don't truly represent the model's broader capabilities. So now what are LLM leaderboards? So LLM leaderboards publish a ranking of LLMs based on the variety of benchmarks. Leaderboards provide a way to keep track to the myriad LLMs and compare their performance. LLM leaderboards are especially beneficial in making decisions on which models to use. So here are some. So in this you can see here OpenAI is leading and GPT-4 second and the Llama third with 405 parameter B and 3.5 Sonnet is there. So this is best in multitask reasoning. What about the best in coding? So here OpenAI O1 is leading. I guess this is the Orion one, and the second one is 3.5 Sonnet, and after that in the third position there is GPT-4. So this is in best in coding. So next comes fastest and most affordable models. So fastest models are Llama 8B parameter, and the second one is LLAMA Llama 70B. But the third one is 1.5 Flash. This is Gemini 1. And lowest latency. Here it is leading Llama again. In cheapest models, again Llama 8B is leading. And in the second number, we have Gemini Flash 1.5. And in third, we have GPT-4o Mini. Moving forward, let's see standard benchmarks between Claude 3 Opus and GPT-4. So in general, they are equal. In reasoning, Claude 3 Opus is leading. And in coding, GPT-4 is leading. In math, again GPT-4o is leading. In tool use, Claude 3 Opus is leading. And in multilingual, Claude 3 Opus is leading.
So let's talk about the very first top AI tool, which is Skillora.ai. This AI tool aims to provide the best AI-driven mock interview experience. You can take mock interviews for any job roles and subject, receiving instant constructive feedback. Skillora's AI interviewer listens to your responses and asks dynamic flow of questions to test your depth of knowledge. With the Essential plan, you gain access to 6 AI mock interviews per month. You'll receive instant feedback, ideal answers, and performance reports, helping you upgrade your skills for just $8 per month. The premium plan allows you to enjoy 15 AI mock interviews per month. You'll get the same instant feedback, ideal answers, and performance reports along with priority support, maximizing your learning for only $15 per month. Next up, we have Visco's. Visco's advanced AI coach is designed to elevate your job interview skills, harnessing insights from over 10,000 companies. It offers tailored sessions that simulate real interviews, providing personalized feedback and performance analytics. It transcribes your performance and delivers a conversational experience akin to an actual interview. It also offers customized feedback and performance analytics, helping you refine both your answers and communication skill. During practice session, you can craft questions specific to your desired role and industry, ensuring relevance and depth in your preparation. Supporting various interview styles. The price for AVA services are available for free. Next up, we have interviewing.io. Interviewing.io is an AI-powered platform that provides candidates with simulated technical interviews. The platform uses machine learning algorithms to assess your coding skills, problem-solving abilities, and communication style. You can get 4 simulated technical interviews for $225. Next up, we have MockMate. MockMate is an AI-powered tool that allows you to practice answering common interview questions. This tool provides feedback on your answers and gives tips on how to improve your performance. The service is available for $29 per month. Moving on to ChatGPT. ChatGPT is an AI chatbot that can be used to practice answering interview questions in a conversational setting. The chatbot can be customized to simulate the style of an actual interview, and it provides feedback on your answers. The free plan allows you to get started with writing assistant, problem solving, and many more. You will have limited access to ChatGPT 4o mini, including data analysis, file uploads, vision, web browsing, and custom GPTs. All of this is available at no cost. Then we have the Plus plan, which is for $20 per month. The Plus plan amplifies your productivity by offering early access to new features, access to ChatGPT 4, 4o, and GPT-4o's mini, up to 5x more messages for ChatGPT 4o. You can access to data analysis, upload files, vision, web browsing, and DALL-E, image generation. You can also create and use custom GPTs. Then we have My Interview Practice. My Interview Practice is an AI tool that allows you to practice interviews in a simulated environment. The platform uses AI to generate interview questions based on your chosen field and provides instant feedback on your responses. This tool is particularly useful for those who want to practice their interview skills in low-pressure environment. The Plus plan is for $49 per month. You get 1 month of access. And the Premium plan is for $57 per month, and you will get access to additional features and many more benefits. Next up, we have Udly. Udly offers real-time interview coaching using AI. It analyzes your speech and body language, providing feedback on how to improve your performance. Udly services are available for free. Now you might be wondering how AI tools can help you ace your job interviews. AI tools can assist in several ways. At first, we have research companies. AI tool provides information about companies' website, news articles, and social media, helping you tailor your answers to the interview's question. Practice questions. AI tool help you practice answering common interview questions, boosting your confidence and preparation. Feedback. AI tool offers feedback on your answers, highlighting areas for improvement and refining your responses. Personalized advice. AI tools provide tips and advice on improving your interview skills, giving you an edge to your next job interview. Choose the right AI tool and select an AI tool that fits your needs and preferences. Use the tool consistently, starting a few weeks before your interview to maximize its benefits. After practicing with the AI tool, get feedback from others to identify areas for further improvement. Dress professionally and be punctual for your interview to make a positive first impression. Show enthusiasm and confidence during the interview to leave a lasting impression on the interviewer. AI tools can significantly aid in interviewing preparation. By using them effectively, you can enhance your chances of success in your next job interview. Now with that, we have come to the end of our full course. If you have any doubts or questions, you can ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with Simplilearn. Hi there, if you like this video, subscribe to Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, you can check the description box below.